Hello and welcome everybody to the Micro Frontends Conference 2024. This is the second edition of our conference, and last year we had already a significant number of participants, and we have just checked and we have over 1,700 registrations this time. So thank you very much for your participation and interest in that conference. Yeah, it's a pleasure to introduce this conference. My name is Lothar Schöttner. I'm the CEO of SmartPiot. At SmartPiot, front-end solutions is also a focus area, and we help our customers architecting modern and distributed web applications. At this point, I want to thank already the entire SmartPiot team and our sponsors for making this event even possible. So thank you very much for your efforts and your commitment. Yeah, today is all about micro frontends, and we have interesting content lined up ahead of us. And I just want to share a few details about the day today. So first of all, we have two tracks this time. Last year we had only one track, and we also have two keynotes, and one of which is just starting right after I stop talking here. Also, something new this year is that the conference is not 100% remote. So we are very happy to have here 4 speakers on site with us here in Munich. This gives us also the opportunity to have interactive panel sessions, so one at the lunch break and also one at the coffee break. And after each session, as last year, we have Q&A time and also a raffle where we hand out interesting prizes to you. So please make sure that you use the YouTube comments feature and also the Discord channel to post us your questions. Now, before we get into the sessions today, just one further point. For everyone who wants to get deeper into micro frontends and the topic of micro frontends, we have also 2 workshop scheduled in context with this conference. Just let me bring up quickly the slides for those 2. Oh, that's the wrong one, sorry. Okay, sorry, it's not available at this stage, but I can talk about them. So one of the workshops is about developing micro frontends with Angular Federation and web components. It's hosted by Manfred Steyer, and it's a remote workshop which is split in 2 parts. Each of the part has 4 hours, and that workshop is scheduled for the 29th and the 30th of July. And the second workshop is hosted by Florian Rappel, and it's about developing tooling independent micro frontends with module federation. Also, this one is a remote workshop with 2 parts, and it's scheduled for the 22nd and 23rd of July. So please visit our conference website to find out more about the 2 workshops, and there you can also book your tickets online. So that's everything I wanted to share in the beginning of the conference, and I guess now it's time to introduce the first speaker, which is Luca Mezzalira. He will kick off the conference with a keynote, the perfect micro frontends platform. Luca is a principal solution architect at AWS, international speaker, and also a book author. In fact, his book, Building Micro Frontends, will be one of the raffle prizes at the end of his keynote session. Luca has over 20 years of experience in architecting front-end solutions and cloud solutions. And in his talk, he will cover some questions he often gets asked. So like, how do I implement micro frontends in my company? Or what are valuable recommendations for implementation micro frontends? Using real-world examples and best practices, Luca will give us some insights into what is the best and ideal mindset for implementing micro frontends. So, Luca, welcome on the stage.
Hi, Lothar. Thank you very much for having me. It's a huge pleasure being here.
Yeah, we're very happy to have you here on site in our offices, and now I think we're looking forward to your session. And Luca, the stage is all yours.
Perfect. Fantastic. So let's share. Okay, so I think you can see the slides and we can kick off. Okay, good morning, good afternoon, and good evening, everyone that is listening around the world. So I'm thrilled to be here today. I want to start with the scenario that maybe is familiar with you, right? So you spent month to understand how you can untangle the dependencies across the teams. And at the end of the day, in this massive e-commerce platform, you decided to go through a journey into micro frontends. So you want to take your monolith, breaking down in multiple micro frontends. And then you did few POCs and you did the proof of concept with different technologies. But the one that really shined for you is Module Federation. So why that? Because Module Federation provides you a very frictionless experience, and you can start to remotely and dynamically retrieve JavaScript modules and therefore micro frontends for your application. You decided to go with React, and you started to, let's say, create your proof of concept, and everything is quite flawless. When you find yourself in a point that you need to deal with dependency management, Module Federation got you covered. And therefore, from here, you can start to have like all the different chunks that are produced by Module Federation that are loaded just once. Because suddenly, Module Federation takes care to load React just once and all the other dependencies that are across the entire system that are loaded once. That's basically your micro frontends implementation. So you think that everything is sorted out, right? So everything is fine. You start to work, you start to spread the love of micro frontends across the teams. People start to work on that, start to build the first micro frontend, the second micro frontend, the third micro frontend. But is that all? Not quite. I've already been introduced, so I won't spend time on me, but the important things to know, that is the one thing that I want to highlight, is that the last 8 years, I had the pleasure to onboard into the micro frontends journey hundreds of teams worldwide, from New Zealand to Silicon Valley. And therefore, in this talk, I want to share with you what I have learned in all these engagements that, surprisingly also for me, was quite similar across the world. So let's start with the case study, edX. Okay, edX is an e-learning platform, and they, back in the days, a few years ago, like 5-6 years ago, they started to think about micro frontends. I spoke with one of their architects when I was speaker in New York, and we were discussing about micro frontends, and they created a framework called Open edX framework. And this framework basically enables them to have multiple teams that might be inside edX or might be from the community to build their micro frontends inside the edX platform. So the reason why they decided to go with micro frontends is for untangling the big ball of mud, as you can see from the screenshot that I took. The talk go through all the different, let's say, journey that they have done. So they started with, in 2019, to roll out the micro frontends approach. They created some strong libraries. So they have the login library that was shared, the authorization library was shared, the internalization library that was shared, and so on and so forth. They're defining a clear, let's say, interface for communicating with the rest of the system. And off you go. So you have like everything that you need, you might think. But the reality is that when they started to implement micro frontends, they were moving away from the old problems and they were onboarding new problems. For instance, the first problem was UX inconsistencies. And the reason being is that because the design system, despite was there, it wasn't enforcing anyhow, and of course there wasn't the governance that enabled them to really reach the state that they wanted. Then they have a regression on customizability, and the reason being is because they move from a Django that allow every single team to, or external parties, to customize the way how the content was landing into the HTML to a more React-based approach, and therefore in that case they have like a more let's say templating approach where they provide some templates and everyone will use them, but not as much as they expected. Also because, again, there were third parties that weren't coordinated by the core team, and therefore there was some challenges over there. Developing became harder for the first iteration because now you have like multiple people that are working in parallel. without any control, and they are doing, let's say, whatever they need to do, trying to fix, let's say, their problem. But the thing is, if you don't have an overarching understanding of the platform, then it can become another big ball of mud, and in this case, a distributed ball of mud. And last but not least, in a few years, they ended up to have an incomplete replatforming, and therefore not all the ideal goals that they have set at the beginning were met, and therefore they need to stop and start to understand what could be done better. Because the complete freedom that they provided, despite a bunch of good solutions, led to slowing down the development. That was exactly the opposite of what they were looking for. And therefore, in 2023, they started again. They started to reason about what was working, what wasn't working. They started to be more opinionated. They started to provide, let's say, more guidelines on how to implement Micro Frontends. And if you're interested about that, you can see here their reasoning behind that. They went through a nice, let's say, a check of the different platforms available, and then they ended up to decide to go with Pyral. And I think is a testimony on how really you should think about Micro Frontends, because it's not a silver bullet. It's a way that will enable you and your team to succeed, but you need to make some effort in order to make it happen. So why didn't it work? That's the question that everyone is asking me. So, and this is not only for edX. There are many other case studies out there that they are claiming, oh yeah, we started with Micro Frontends, but they don't work. And they blame the architecture. But not quite, because architecture is just a part of a distributed system. So usually, when I talk about distributed system, backend or frontend, there are what I call the pillars of distributed system. But there are three: organization, culture, and system architecture. Those three elements, unfortunately for us, are tightly coupled. Every time that we touch one, the other two will be affected, for better or worse. And that what it means is that, for instance, if I receive very often the question, should we use monorepo or polyrepo in our Micro Frontends implementation? And there are certain people very opinionated that think, oh, monorepo will solve everything, or polyrepo will solve everything. The reality is just, you are not taking just a technical decision. What you are doing is defining the communication between teams. And if you start to think about that, you stop for a second and start to say, okay, I'm going to sec. So if I'm having a polyrepo, I'm setting my team to communicate in a certain way. If I do monorepo in another way. And that's very important, because as you can see, when you take a design decision, you're going to affect some of those. The engineering practices definitely plays a crucial role in distributed system, and therefore it's very important that you have the culture to, let's say, enable the teams in order to foster the right engineering practices. Otherwise, it's difficult to blame an architecture, because an architecture is thus surfacing and expressing certain friction or not inside your organization. Okay, so very often I refer to this definition that I coined back in the days in 2017. So this one was, at the beginning when I started, was more rough. Now, I think in 2017, I just nailed it. And this is usually a definition that covers the key aspects of Micro Frontends. But let's start to focus on a chunk of that. Usually, I just go through this definition when I do my other presentation, but this would be pivotal to understand how important it is having clarity of what we need to express inside our architecture in order to succeed in our goals. So the first two parts is that Micro Frontends are a technical representation of business domain, and they allow independent implementation. Those two aspects are foundational for Micro Frontends. But let's try to drill down into that. When we talk about a representation of a business domain, there is a clear distinction between components and Micro Frontends. So a component, usually when you think about that, let's take the most, let's say, used component in the world, the button. When you build a button, you start to say, okay, so I want to create a label. So you expose property for a label and someone else will fill this label. Then suddenly you say, okay, I want to extend this button and add also the capability to add an icon if needed. And then you add the capability to change the border color, to have different rollover animation based on the portal that you're using. You start to have internationalization, and therefore you start to have auto size dimension, because we know that in certain language, let's say the same word can be expressed with more characters. And then finally, you have also the possibility to disable the button by default, because you are using a form, so you want that all the fields, mandatory fields, are filled before you enable the button. So all these things that we are defining here are abstraction on top of capabilities of button. It doesn't make any sense that we are going to rewrite that every single time. So they make sense inside the component. But the problem with that is that we are optimizing for reusability. And reusability is a form of coupling. And it's not just me saying that. There are, let's say, well-known architects like Neil Ford that discuss about that extensively when talks about microservices. And therefore, we need to bear in mind that we are expressing, in this case, a technical concept, not a domain concept like Micro Frontends does. And what the Micro Frontend does instead is trying to encapsulate its own state, trying to encapsulate its own logic. Before, the button was leaking its domain to the container. The container understands how to use the button, and based on the context, is enabling the button or changing certain properties for functioning inside the context as expected. But Micro Frontend cannot work in that way, otherwise it's not independent anymore. Therefore, the Micro Frontend is context aware. Understand what you need to express inside your system. It defines clear inputs and outputs, because in reality, what you want to have is this capability for others potentially to integrate with or to communicate with your Micro Frontend. And this is definitely less extensible. We are not optimizing for reusability, because the problem you have, as we said, that we are creating coupling, and we are moving on the complete opposite direction, trying to optimize for fast feedback and fast flow. Therefore, I want to give you some heuristics that you can take away to test if you're building Micro Frontends or not. So the first one, you need to have a very small API that is exposed usually to the container. Vast majority of the time when you have the ID of your Micro Frontend, or sorry, ID of the product for a specific, let's say, things to render, and where to find the token, that usually by convention you can find from a cookie in memory or local storage, is more than enough for a Micro Frontend to function. You don't need to, let's say, expose a bazillion of other properties, because otherwise you are creating coupling. You are basically enabling the container to do more with the Micro Frontend. Therefore, every time you change the Micro Frontend, you need to change also the container. That is not where you want to go. The Micro Frontends are context aware. Therefore, what I just described fits very well in the description. You don't optimize for reusability at all costs. It's obvious that it's always a trade-off. You need to figure out if maybe a Micro Frontend can be useful in multiple contexts, and that's fine. That works, but you don't have to heavily optimize like you would do with the component. That's the key aspect that differentiates components from Micro Frontends. And last but not least, usually Micro Frontends are more coarse-grained. What I mean by that is that usually you don't have like 20 Micro Frontends in a view, because otherwise you have a distributed monolith that basically is nothing more than a bunch of components that are loaded at runtime, and you set up yourself for failure. So bear in mind, the last thing, that the Micro Frontends boundaries, so how you identify Micro Frontends, is not forever. It's there for a reason. So at the beginning, you assess in a certain point in time that this is your Micro Frontends, or those are your Micro Frontends. But as a business evolves, as the maturity of the company evolves, as the complexity of a specific domain evolves, you need to revisit that. And therefore, what was working 6 months ago is not going to work in 6 months' time, because maybe the business drifts towards another direction. Or maybe now the complexity of the domain became so huge that the cognitive load of a team is not there anymore. And therefore, it's important that you take that with, let's say, a good pinch of salt when you are reassessing your Micro Frontends. And usually a suggestion that I provide to many customers that I speak with and many teams is try to have like a healthy feedback loop that every 6 months you are going to reassess if the Micro Frontends are still working, the boundaries of Micro Frontends are still working as expected. Okay, so now let's move into the other aspect, the organizational benefits provided by Micro Frontends, because many think, oh yeah, it's just a technical decision. This is not. Distributed systems weren't created for only technical reasons. They were created mainly for organizational one. Because I'm pretty sure that if you go to buy, I don't know, something in an e-commerce, you're not asking yourself if it's a microservice, it's a monolith, or whatever. You're probably interested to buy a product. And therefore, for that, obviously, there are some benefits on technical side. We will explore that. But the reason why we are using Micro Frontends in this case is for scaling your organization as well. So Micro Frontends benefits are obviously allows you to have incremental upgrades. That's great. You have a decentralization. Therefore, you start to have developers and teams that are part of the decision making. They are domain experts inside their system, and therefore they take decision and design decision that will enable them inside their domain to strive and have all the things that they need. You try to reduce the cognitive load. That is fantastic because it means that another person that is joining that team, it will be able to hit the ground running and start to see immediately some benefit of using Micro Frontends. An example usually I gave in my previous company, I had like engineers that joined a team that in no longer than 3 weeks, they were capable to ship code in production because they just need to understand a portion of the system. And then later on, they will understand more about how the things are working behind the scene and all the other domains and so on. But these definitely enable a lot of things. And last but not least, you want to scale your technology as well, the organization. If you know upfront that your team is going to grow due to the great success of your platform, Micro Frontends are definitely a good solution to look at. Now, the important things to understand, that is one of the pillars that I was describing before, is that any organization will produce a design that is a copy of the organization communication structure. This is not a new thing. As you can see, the Conway's Law, as it's called, it was defined in 1967. It started to have relevance in the 80s, 90s, give or take, when people take more seriously this thing. But it makes a breakthrough with microservices in the early 2000s. And what I mean by that is that usually you cannot blame an architecture if your organization is not set up for enabling the architecture to flower, or the other way around. Both models will work by an architecture designed in a vacuum without taking into consideration the organization structure, how the teams are communicating, how they are working, what are the practices. It doesn't help you to achieve what you want. Just implementing Micro Frontends or implementing microservices inside an organization that is not set up with a decentralization mindset, is not set up for enabling the team to take their own decision, to have skin in the game, is not going to work. It's not going to provide you the benefit that you're looking for. And therefore, be careful when you are designing this kind of architecture, because just embracing a technical implementation in a context that doesn't allow you to strive, it might be a problem. And trust me, the problem is not the architecture, it's because of Conway's Law. Now, when I talk about mindset, usually what we were used to work is something like that. And there are still many companies working this way. So we have like tech leadership that's composed by the platform team, the security team, the architecture team, and then there are engineering teams that are communicating together, they are tangled together, they have external dependencies, and there is this back and forth between these two layers inside the organization. Now, what we want to reach instead is something completely different. In 2019, there was the revolution around how to think about teams with the concept of team topology. The idea that the company should design their organization in order to have a distributed system that enables them to achieve what they want, and their key characteristic of the distributed system was a must. And many companies moved from a decentralized mindset to a decentralized mindset using team topology. Team Topology is a fantastic book. If you didn't read it, I highly recommend. And start with the idea that we have stream-aligned teams. These teams are cross-functional teams that are responsible to deliver a specific area of your application. Obviously, every single company might design and assign, let's say, this domain differently. Obviously, if a company has thousands of developers that are working on the same system, their granularity will be, let's say, more fine-grained, and instead a company that is working with 5 teams might have like a completely different granularity, but it's fine. The idea is that we align our team to a stream-aligned work. Then we have obviously some complicated subsystem. It could be like a very difficult component, or you want to integrate with the data science team for sending a click stream of events that are happening from your front end in order to understand how the customers are using your platform. Then you have a platform team that is enabling your streamlined teams with tools. and in particular with a nice developer experience, with everything that is needed for security. So the streamlined team can think only and mainly to the creating value for the company and for the users. Because the reality is it doesn't make any sense that we reinvent the wheel every time, and we have like every single team that maybe ship a server-side rendering a Micro Frontends application with different type of containers or different container orchestration platform. So it's very important that we have a platform team that is enabling the others to succeed. Okay, but let's try to drill down into the platform responsibilities. So when we talk about the platform team, let's start to look into what they should do. A platform team usually defines the foundation for a distributed system. It's important to understand that sometimes you think about platform teams, sometimes they are called core teams. It doesn't matter how you call it, but usually there is a bunch of people inside the organization that are cross-functional, sometimes people from security, sometimes architects, sometimes lead engineers or staff engineers. So one thing that usually they define at the beginning is how the system would work, how you are going to design. They run the POCs, they try to squeeze in all the functional requirement and non-functional requirement, all the business requirements, everything that is decided by the business. They start to identify how they want to use Micro Frontends. They start to decide how to compose, to route, and to communicate. This is something that they call, back in the days, the decision framework, that nowadays is still at the forefront of every single team that I spoke with worldwide, and they always refer to that when they are thinking how to structure their application. So when we start to drill down, we have different ways that we can identify Micro Frontends. We can have multiple of them in the same view. We can have one page or a group of pages per Micro Frontend. Usually I've seen customers mainly and teams starting with the vertical split, as I call it. So having one page or multiple pages that are representing a Micro Frontend. And when they're more mature, or if there is a requirement for a specific area of the application that require a horizontal split, so multiple Micro Frontends in the same view, because maybe there are multiple domains that has to be expressed in the same view, they go with the other approach. When we think about composition, we start to think about where I want to compose my Micro Frontends. In client-side rendering approach usually is happening at the client side. So you have like an application shell that is basically when you type mysite.com, that's the first thing that is going to download. An application shell will load the specific Micro Frontends for you, and that is composing the page, despite its vertical or horizontal split. On the server side, instead, you usually have a cluster of containers. You have like, I don't know, a serverless layer that is composing your Micro Frontends on the server. And in this case, maybe you are optimizing for organic SEO or for fantastic core web vitals metrics that you want to have. And therefore, doing server-side rendering is the thing that you're looking for. So either way, as you can see, there depends if you're doing client-side rendering or server-side rendering, you have an option in front of that. When we talk about routing, usually you have on the client side the application shell that takes care about that. It has the logic to say when the user goes from /catalog to /my account, knows where to fetch the Micro Frontend. And the other way around, because we are composing on the server every time there is a request is going to the server understands what is the request about and then fetch the right Micro Frontend for that. Either way that you're working, so if you're working with horizontal split or vertical split, you have also to think about communication, because the Micro Frontends are not living in a vacuum. And therefore, what it means is that when you have multiple Micro Frontends in the same UI, you can use a loosely coupled way for dealing with the communication. Event emitter is a good way. It's probably my favorite one. Custom events is another good one. And reactive streams usually are the most common one. I think I put them in the order that I've seen more often embraced by teams worldwide. So event emitter is probably nowadays one of the most used one, followed by very closely by custom events, and reactive streams is mainly used in certain situations. When you have, let's say, either horizontal or vertical split, you need to think also how you share by convention certain things. Think about the authorization token. So if you have a job token and you want to share, you can use local storage, you can use cookies, you can use in memory. And also, when you want, for instance, to move from or pass some ephemeral data from one page to another one, you can use query strings. And there you can append the ID of a product or something like that. And by convention, you say, okay, so to the Micro Frontend, you will fetch the ID from the query strings. Why I'm saying that these are, let's say, by convention? Because the main difference is in one side, you define some code. On the other side, you might create an abstraction layer that is a library, but I would say that this is easily accessible from any front-end developer, and therefore you don't need to build any library around that unless you have, like, let's say, specific use cases. Okay, so when you define that, the platform team has to think about the application shell. There are some considerations that you need to take into account. The first thing is that has to be as vanilla as possible. I have seen often teams that start to, so if they have like some application that running, I don't know, in Angular or React, they write even the application shell in that way. My preference would be stay as, let's say, vanilla as possible because they have more control on the update. Usually, the application shell is a good application shell if you, when you build that and everything is working and routing correctly, you don't have to change very often. And when you reach that stability, then having to dealing with multiple frameworks just for the sake of having a router doesn't make much sense to me. And therefore, usually what I recommend is going as vanilla as possible. It has to be context unaware. It's very important, this aspect. I have seen sometimes teams that start with the Micro Frontends implementation, and what happens is that now, because they want to share globally across multiple Micro Frontends certain information, they leverage the application shell because it's always there. But the problem is now every time that you change let's say a specific API, or you change the object or whatever, you need to change possibly also on the application shell. And this, let's say, coupling is not needed. You can use other techniques like leveraging in-memory or leveraging an API. Or you can leverage local storage, web storage. There are a bazillion ways that you can do that in order to avoid coupling between the application shell and the rest of the system. Because the moment that the application shell is done and dusted and tested, it should be, let's say, as stable as possible. Then, obviously, the application shell is the first thing that we load, especially if you do client-side rendering. It tends to expose certain configuration. In server-side rendering, I've seen as well that thing often, but because, let's say, every time that there is a change of a page, you need to call the server for doing the server-side rendering part is less, let's say, relevant like in client-side rendering. And last but not least, bear in mind that the main reason why you build application shell is for being responsible for routing and composing. Everything else that you have in mind, maybe think twice before you arrive there. Okay, the other thing that the platform team should think about, because when they build the application shell, they know how to route and compose Micro Frontends, great. Now they have time because it's a stable application shell. They don't have to change every single time. So they can think about something more important that could be the developer experience. I'm a huge fan of developer experience for one main reason. Because in order to achieve the fast flow that, let's say, companies are looking for, and therefore to have a healthy feedback loop for developers, we need to have tools that enable us to reach this specific mindset. So the first thing that usually you define in developer experience is the guardrails, what you need to express inside your system. What I mean by that. So first of all, there are certain things that you really want to have available inside your system. For instance, performance. One thing that I was doing in my previous company before joining AWS was creating some, let's say, fitness function that usually are some function that you can run for expressing certain architecture characteristics inside your system. And what I was doing is every time that one developer, one team was opening a PR in Git, we were running a Git hook that was basically calling an API. We were cloning the specific repository. We were building on the fly the system, and we were checking that the output of that Micro Frontend was inside a certain threshold for the budget size of our Micro Frontend. That means that we didn't have any, let's say, surprises when it goes to production. So the team couldn't ship megabyte of Micro Frontend. They have to be, let's say, wise in the way how they were handling the different dependencies, and that enable us to take care about the performance. Obviously, you can think more about that. You can think to integrate any visual tool that you want to have for regression testing. You can let's say check core web vitals dynamically when you before sending to before publishing to production. So there are a bazillion of ways that you can think about that. But this is a guardrail that should be thought on how you want to let's say express a certain behavior of the teams closer to the team actions. So if you can shift towards where the developers are working, therefore a GitHub repository is definitely a good choice. Updating shared library was another cool thing. So how can we update a library that we have shared? Usually design system or login libraries are the classic thing that you share in Micro Frontends. How can you create a mechanism that will enable you to do that? Maintaining the required security posture. For instance, you want to make sure that no one is adding API keys inside the front end or in GitHub. And therefore, you can scan your repositories in order to make sure that nothing is leaking outside your application. And potentially you can have other architecture characteristics, but those are the guardrails that I'm mentioning when I'm thinking, okay, so we need to find a way to solve the most common problems to have an healthy environment for the developers. And that is baked into the developer experience, because if we can create this automatically, then developers will thrive without any problem. The other thing is that I've seen very often is the usage of let's say portals that usually are API portals for creating also templates, and often also for Micro Frontends. I've seen customers worldwide that embrace Backstage, that is an open source platform, was created by Spotify, and that now is used worldwide by multiple companies that use that for leveraging Micro Frontends templates. So they create like a template of a Micro Frontend, so I don't have to spin up a custom project, start to let's say import the libraries or whatever. The core team is responsible for creating and maintaining these templates that the new team that wants to spin up a Micro Frontend just clone the project from there, and then off you go. They have already baked in maybe the CI/CD or the different information needed for starting, and they can focus on creating the value for the company and for the user. Last but not least, deployment. So deployment is another key characteristic, because when you think about that, very often mature teams, when they reach the moment that, okay, we go to production with the first Micro Frontend, second Micro Frontend, and so on, they start to think, how can we make the deployment easier and smoother? Because if you use exactly the same way how you were doing, monolithic architecture is not that simple. Usually, the suggestion is the characteristics I want to see in deployments for distributed systems is that it has to be incremental, frequent, so fast feedback loop that we said before, and it has to be independent. The moment that I found myself, they have to coordinate with multiple Micro Frontends, I need to go back to the whiteboard and understand if some domain leaked around. And therefore, in order to reach that, I created a working group back in 2022 that started to look into this problem. The thing is, as you can see, there are a few familiar faces: the creator of Single SPA, Joel Denning, the creator of Open Components, Matteo Figus, and the creator of Mod Federation, that is Zach Jackson. And I worked for a year with these guys and trying to figure out how we can help the community for doing that. And we come up with this JSON schema, not too opinionated, that enables you to define where to find the Micro Frontends. So when I load my application shell, I call an API that tells me what Micro Frontends are available inside my system, and I can start to load these Micro Frontends straight from this point. But because we are calling a Micro Frontend through, I call an API for retrieving my Micro Frontends, I thought also that would be very nice to use that mechanism for leveraging the possibility to apply canary release and blue-green deployment like we are doing microservices for decades. And it's very important, this aspect, because it will enable you to easily deploy your solution without too much burden. So in this slide, for instance, you can see that the same Micro Frontend, there are multiple versions, and this version can have redirect traffic towards one version or another one incrementally. That is a fantastic mechanism that I have seen teams thriving with that, especially because when they start to have a safe net, as I call it, they start to feel more confident to say, okay, I want to deploy this 5% of the traffic and see if this code will impact the performance of my application. And if it doesn't, it will impact only 5% of your user base. You can even go more granular and say only in this specific country or only for this specific browser. It's up to you to define these things. So if you are interested in this project, it's completely open source. It's called Front-End Discovery. And if you want to contribute, you want to know more, you can find that in this link here. Now, I didn't stop there. When I started to look into how to implement this thing, I thought, okay, so in order to, let's say, do something like that, I have my application shell calling the service. The service is, let's say, querying a database, and then is returning all the logic to the front end. But hang on a sec. So this part here is exactly the same for every single application, not only Micro Frontends, even for single-page applications or server-side rendering. So that could be a very nice project to extract and remove what we call in AWS the undifferentiating heavy lifting for our users. And therefore, with a bunch of other guys, we built internally this open source project. It's called Front-End Service Discovery. This is available again. You can clone it. You can change the code. I have already quite a few large organizations worldwide using that in production. And that is a fantastic testimony on how the community can really help to solve common problems, because usually, in my experience, teams don't have the time or don't have the skills for doing that. In this case, you click a button, you deploy in your AWS account, and you have what you really need for dealing with kind of release, blueprint deployment, and discoverability of Micro Frontends in a very vanilla fashion, because it can be pluggable to any CI/CD. You don't have to change the way how you are deploying your Micro Frontends. You just add one step for telling this system how it should roll out a Micro Frontend. Inside this README file, you can find also a talk that I did in order to show a live demo and everything. Okay, so now we have discussed quite a lot about the platform team. Let's look into the value stream teams. So value stream teams have few responsibility. Obviously, we have seen the rest, but we are want to look into deciding the technology, because that's up to them. We said we decentralize this decision, but it's important to take care about a couple of things. Back in the days when Micro Frontend Word came out in 2016 from the ThoughtWorks Tech Radar, it started to move very fast, this movement, especially for certain organizations, that we end up in what is called the Micro Frontends anarchy. That was a term coined by me. It was in 2020, if I remember well, the Tech Radar of ThoughtWorks started to call it in that way, because what happened is, without guardrails, people start to choose a specific framework, implement that, and then suddenly a mess, because performance-wise, we know that it's not going to work. And by the way, if you're building currently single-page application or server-side rendering one, despite you can have multiple frameworks in the same page, you would not do that. So why you leverage that with Micro Frontends? There are certain situations where I see the value of that when you are, for instance, migrating from one existing monolithic architecture to Micro Frontends. So for a certain period of time, you will deal with multiple frameworks, and that's okay. But let's say don't optimize for that. The other thing is minimize the code share. This is the most controversial part. I remember when I started to talk about that, I was grilled in conferences by my engineers. It was like very complicated time for me. But if you look into why I was doing that, is because duplication is far cheaper than the wrong abstraction. And therefore, we need to be mindful in the way how we are dealing with components and Micro Frontend, and these defining clear boundaries on how to identify that. So you want to definitely reduce the external dependencies, and therefore having bazillion of shared libraries is not going to help with that. It's against basically the architecture we are building. We want to optimize for the fast flow, and therefore, if I don't have external dependency, everything is inside the control of my team, and therefore I'm going to reach this fast flow. And last but not least, we want to have a lean mindset. Why starting to pre-optimize, thinking, oh yes, this library will be used across the entire company, and then suddenly 6 months later is used by only 2 teams, and you are creating all this complexity that is not needed. Maybe it's better that you start to duplicate. At some point, you organize a meeting between 2 teams, say, oh, by the way, we're using the same thing. How can we do an abstraction in order to capitalize on the investment? That is by far a more interesting discussion than starting to think and plan for, let's say, winning the award with your shell library. One heuristic that I want to provide you is trying to look into these libraries. Those are the classic things that I've seen very often shared by teams. So you can have login library, analytics library, design system library, and data layer library. But the rate of change of code is a good indicator, though. Usually a data layer might, let's say, have a high rate of change, because that data layer, if it's shared across all the system and you have a microservices approach, you are designing the organization in order to, let's say, thrive and define their own independent API. So if they change it, they need to quickly change in their system. But if you have a data layer library, now suddenly everyone has to wait that the data layer is changed, and then they can start to consume that API. Now is a problem. And therefore, rate of change is a fantastic heuristic to tell you if that specific library should be shared or not. That is great to understand. It's also a good way when you are thinking about Micro Frontends for identifying boundaries. This is usually rate of change is something that we don't look very often, but I really encourage you to use as a heuristic to have like a direction of travel for your decisions. Last but not least, the ownership part. For me, in 2024, a team responsible for Micro Frontends should code the Micro Frontends, obviously, test the Micro Frontends, quite important, deploy and monitoring. That is usually, I still not see, let's say, everywhere. Vast majority of the company I speak with, they are doing that, but it's very important they have visibility of what is going to be in production and knows having their own dashboard and understand how to debug their Micro Frontend, and adhere to guardrails. Those 4 things are the key let's say, aspect for maintaining the ownership of Micro Frontend. That doesn't mean you are the only team that can contribute on the code base of that Micro Frontend, but you are responsible for what is emerged inside the code base. The moment it goes in production, you will be responsible to handle that part. So one thing that I highly recommend is having a shift-left mindset. So the more you can do...
Luca, we need to look a little bit at the time, because we're already at 45 minutes.
I'm almost finished.
Oh, thank you very much.
You're welcome. We are moving to left as much as possible. Obviously, that's not all. And there are, let's say, more things that we need to take into account. And I don't I underestimate the coding challenges. Absolutely. I know the server-side rendering is still cryptic, and we need to do a better job. Observability is not democratized yet for front-end development. End-to-end testing, we could do a better job as a community. Security, events management, and performance are another thing that we need to think about. But the thing that I describe in this talk are our key elements when we are designing Micro Frontends. The rest you can derive. There are, let's say, great tutorial books around how to apply server-side rendering, how to do observability, etc. But the things that I describe in this talk are usually the hidden things that we don't think straight away, because they are not surfacing immediately when we are designing a platform. Okay, so what we have seen so far. So we have seen the Micro Frontends are what Micro Frontends are and how to distinguish between Micro Frontends and component. We have seen the team ownership in Micro Frontends, that is important. We have understood the importance of feedback loop and fast feedback loop especially, and how this centralized mindset can help us to build the right platform. But I want to share one more thing with you. So in the last few months, I started, let's say, to work on share even more content on Micro Frontends. And I created this newsletter that is a fortnightly newsletter that is available for free if you go to this link, and you will be able to subscribe without any problem. And as I mentioned, if you follow me on social, I mentioned yesterday that I have an announcement to make. And today I want to share with you that the second edition of my book, Building Micro Frontends, is reality. There are already 2 chapters in the Riley platform. Other 3 are coming in the next few weeks. And I'm rewriting that. Half of the book will be completely rewritten. I will add more information, and a lot of the things that I described today will be covered in depth. That's all I got. I hope that you enjoyed the session. If you have any question, feel free to reach me out in the Discord server or in social network. Thank you very much for having me, and enjoy the rest of the conference.
Thank you very much, Luca, for all the considerations and insights, and also your announcements for the second edition of your book. I'm looking forward to read it. Now, we have a few questions, which we, I think, still can squeeze in before we go into the raffle. So the first question is from Florian, which is our teams focusing too often on the technical parts / development rather than on the overall flows or the system.
I think it's natural that the developers are looking into that because it's the part that they're going to deal day to day. However, I think they should surface the need of looking more holistically across the application. You cannot design a distributed system without taking into account also the practice that described in my talk.
Okay, thank you. And then another question. What about a design system library? What would you suggest in this case?
Design systems are common to share. Usually what I recommend is using web components because when you build with that, you are framework agnostic and therefore it's easier to deal with change of framework without any problem. Now, the thing that I usually recommend is having design system and using for updating them across Micro Frontends, something like Dependabots. There's a tool available in all the version control system that basically you can enforce the update of a library. It can be automatic or it could be like a digest that is coming to the email of the teams. Either way, depends on how you want to handle, but either way is a fantastic tool for enforcing this kind of shared libraries across a distributed system. We are doing in AWS very often for microservices and for our system. So it's a tool that is widely used in the industry also for Micro Frontends.
Okay, and thank you very much. Then we have just a final, more general question from Daniel, whether the streams or the sessions today will be recorded to watch later. Yes, as last year, we will record the entire day today, the conference, and split the sessions and also put them onto YouTube for watching later. So thank you very much, Luca. Thank you for your session and the keynote. And we will see you later at the lunch panel for further discussions and answering questions, and also then for the coffee break. Yeah, I guess now it's time to start the first raffle of the day. Just seconds, and preparations are ongoing. Just bear with. Maybe in the meantime, Luca, I have another question to.
Great. Still here.
I think now it's ready. Sorry, we take it. I'll take it into the lunch panel. We can discuss it there.
Okay.
Okay, good. So this year the raffle has a little bit of different structure. So we have the QR code. So for everyone who wants to participate, please scan that QR code, and then you can enter your email address with which you have registered, and also provide your YouTube name. And then if we have enough participants in the raffle, then we can kick off and start. So let's wait until people are joining. Yeah, we will have 3 prizes in this raffle. The first one would be the book Building Micro Frontends, which I mentioned earlier, the book from Luca. Then a license from JetBrains, the writer license, and then also a license for Console Ninja from Wallaby. Let's wait a few more seconds, and then I think we can get started. So then I would say 3, 2, 1. Let's start the raffle. Okay, we have the first winner for the Coca license. And then let's spin the wheel again. Okay, and the second winner for the JetBrains rider license. And then let's spin the wheel for the last one. Okay, and then we have the third winner for the packed ebook. So that, all right, so that, sorry, that was my mistake. It's not the ebook from Luca that will be handed out later. So it's a free ebook from Pact, one of our sponsors. And yeah, then thank you very much for participating in the raffle. And we will contact you during later the week or next week regarding the prizes and then organizing the handout. So thank you very much. And then now we will have a short break and we will see you back in the either track 1 or track 2, as in track 2 now also the sessions start. So thank you very much. See you later.
bit about opportunities and challenges of micro frontends, but also about alternatives. And for this, I want to get started with a picture. So what do you see here on this picture? What you see here seems to be a couple and another couple. They seem to be neighbors and they seem to like each other. They seem to have a good relationship. They are smiling, they are communicating with each other, and so on. But you see something in addition, namely fences. And this brings me to this good old proverb, good fences make good neighbors. And this proverb is also true when it comes to software development, especially when it comes to enterprise scale software systems. Because what we usually want to achieve is, usually we want to slice our huge systems into verticals. Parts, subsystems that don't need to know much about each other. They should not know much about each other to stay maintainable. The goal is to change something here without breaking something there. And usually those verticals contain some co-located features, some features that go together, that need to know something about each other. And usually we can make sure that the dependencies between those verticals are minimized. In a perfect world, they don't know a thing about each other. In this world, sometimes they need to exchange some data, or perhaps sometimes they need to share some code. And at the end of the day, we do this to be capable of assigning different teams to those verticals. Teams that can concentrate on this very vertical and teams that can provide business value on a regular basis. Teams that don't need to communicate with each other all the time when they want to implement something. At the end of the day, this gives us back maintainability, and it gives us back the agility of small teams, even though we have a huge overall software system. When it comes to those verticals, normally they should represent a business domain, an area from the real world we are writing our software for. You know, the real world is where the pizza boy comes from, and usually we look out there to the real world, we analyze those parts of the real world, and then we model those parts in different verticals. So ideally, we mirror the business domain, and one option for implementing those verticals is going with micro frontends, which means that each and every vertical becomes an application of its own, a front end of its own. And this maximizes the independence between the different teams working on those verticals, because now everything is really decoupled. And this brings some opportunities. Because we have minimized the dependencies between those teams, the teams are more or less autonomous. They can do more or less what they want. Of course, they have to align with some decisions, but within the borders of those decisions, they can do what they want. And so this brings back a lot of agility. We can easily add new team members or even additional teams, because a team is only responsible for one vertical, so they only have to concentrate on this subsystem. They don't have to concentrate on everything. So adding new people to such a team is easy, but also adding additional teams that work on additional verticals is easy. This results in shorter release cycles. So from a business perspective, the goal is time to market. And time to market is now faster because the teams just need to concentrate on their stuff. This increases the testability because we don't have to focus on the whole system anymore. We also have fault isolation. If we break something here, this will hopefully not affect something in other verticals. This also improves runtime performance because we now have smaller subsystems. And usually we don't use all the systems at once. And in theory, we could even go with different technology stacks. In practice, this is more or less an anti-pattern because we don't want to have a framework zoo, but this might make sense in the mid or long term. Because we all know in the mid or long term, we have to migrate to another technology stack. Technologies come and go, and after a decade, plus minus, we need to migrate. And so having the opportunity to migrate little by little is for sure a huge benefit. However, micro frontends also come with several challenges. Somehow we need to make sure that we have a unified UI and UX. We have to take care of initial loading times, which means we should not load all the micro frontends at once. We need to take care about coupling. In theory, the micro frontends are really decoupled, but in practice, decoupling them all the times is really difficult because overall they depend to an overarching system. They belong to an overarching system. And so it's not a surprise that sometimes they need to share something. We might have technical conflicts because if we load several applications, micro frontends into a browser window, they could conflict with each other. After all, they don't know each other, and we are using different frameworks, perhaps, that have not been officially tested with other frameworks or other versions with themselves in the same browser window. This might increase the complexity. To be honest, on one side, we are decreasing the complexity. But if we look a bit closer, we see that we are just moving the complexity out of the verticals into the integration layer of those verticals. The verticals themselves might become simpler, but somehow we need to integrate them to an overarching system, and this is what creates some additional complexity. And we might have diverging micro frontends, where different teams develop the micro frontends in some directions so that they don't fit together anymore on a technical level or on an UI UX level and so on. So those are the challenges. The big question that I want to answer with this presentation here is how to deal with these challenges. And for this, I've prepared 3 things for you. I'm getting started with strategies for dealing with these challenges. Then I want to show you the costs of those strategies. Nothing is for free, and so we should talk about the costs. And then I want to talk about alternatives. Perhaps you say, well, micro frontends pay off, even though there are costs. Or you say, well, they don't pay off in my very case, and in those situations, you want to look for alternatives. Okay, so let's get started with strategies for dealing with challenges. One challenge area is UI UX. We want to have a unified UI UX. And to achieve this, we can do several things. We can provide an overarching design system. I would say in general, having a design system makes a lot of sense, regardless if you go with micro frontends or not. And this design system can also result in shared styles, but also in shared libraries. And we can deal with Shadow DOM to isolate different parts of the system away so that a special style from here is not affecting the styling over there. When it comes to initial loading times, we can go with server-side rendering. This is something we might need even though we don't go with micro frontends, because if initial loading times are critical, server-side rendering and hydration and all those other strategies that tie into this are king. We might want to go with automated performance checks. For instance, we could run Lighthouse in a headless mode to get statistics on a regular basis and to get a bell ring when we surpass a given threshold. And at the end of the day, it's also about sharing code. Just because we have 10 micro frontends that need Angular does not mean we need to download Angular 10 times. This would be quite an overhead. Ideally, we just download it once and share it during runtime. And this is something that can be easily achieved with module federation that comes with Webpack and meanwhile also with other bundlers. When we go with federation, we have two roles, two kinds of applications. The first role is the host, which is our micro frontend shell. The second role is the remote, which is our micro frontend itself. And now we can configure both roles. For instance, we can define a mapping for the shell, a mapping that points over to this or that micro frontend. That means every time we import something from here, we grab something from over there. And over there, we can expose files. When we are exposing files, we assign them to a nice alias, because other roles, the shell is not interested into knowing our paths, our directories. The shell is not interested into knowing that this file is in the folder A, B, C, D. No, that's why we are just mapping a nice short alias. And then all we need is a dynamic import that is using the map names. And so we can grab over to a system we did not even know at compile time. And then we can load something from over there. The best about this is that we don't need to tweak our framework. We can use our framework, Angular, React, Vue, or something else in a way it was intended to be used. No dirty tricks, no workarounds. It's business as usual for the framework, because the framework only sees the dynamic import, and so it thinks, okay, that's lazy loading. However, the truth is, it's a bit more than traditional lazy loading, because we are loading something we have not been aware of at runtime. And yeah, this is what federation does for us underneath the covers. So one of the best things about federation is we can define all this data pointing over to another application in a dynamic way, because in a very dynamic system, this information might come out of a configuration file or of a service telling us, well, today, please use this micro frontend over there, and tomorrow, please use the newer version that is now located there. And also, we need to share some metadata. For this, we provide a so-called remote entry point, and this entry point needs to be loaded into the shell, so the shell knows how to interact with the micro frontends. This metadata, by the way, is also necessary to find out what to share with the micro frontends. This is why we started to talk about federation, didn't we? So in order to define what to share, we just need to define the names of the libraries to share on the left side and on the right side. And if we find out at runtime that we have the very same version of those libraries, or even a compatible version, then it will be shared. If there is no compatible version, then there are several strategies we can configure, several strategies how to deal with such a situation. Which means that dealing with version mismatches is part of the game. It's baked into federation. Now, let's have a look at an example for all of this. So what we see here is a simple micro frontend. It's within the red dashed lines. And here we see a shell that has already loaded this micro frontend. Let's go to the home page. Let's reload it. Let's click here. And one more time, we've loaded this micro frontend seamlessly into the shell. That means even though we talk about two different applications, two applications that have been implemented by different teams, that have been deployed separately, the user gets the impression that they are dealing with one big thing, with one integrated thing. One of the best things here is that libraries are shared. So let's have a look at the network tab here. Let's reload everything. And what you see here is that all the program code, but also the libraries are loaded. Each shared library like Angular Common or Angular Common HTTP and so on. And when loading the micro frontend lazily, we don't need to reload Angular. Even though it was compiled with its own Angular, now it is just sharing Angular with the shell. And so we just need to load the source code of the application, which is here just a component, a matter of 3 kilobytes, 3 give or take kilobytes. So if we look into the source code of all of this, then we see we have really a traditional Angular application here. Actually, both the shell, but also the host is, no, the shell, but also the micro frontend is a traditional Angular application. And it could also be a traditional React or Vue or Svelte application or something else. So no special things in there, but a federation config. This federation config defines a unique name. This is especially important for the micro frontends. Here we have a unique name that's called MFE1, like Micro Frontend 1. And micro frontends usually expose files like our application component. They are exposed and we assign a short alias to it. Then we can define what to share. And normally this here is an exhaustive list with all the libraries we want to share. All the libraries like Angular Core, Angular Common, and so on. However, the issue with exhaustive lists is they are normally exhaustive. And that's why I'm going a different way here. I've written this simple share all helper that looks up all my dependencies in my package.json and shares them. By the way, those settings here define how to deal with version mismatches. But this goes too far for today. Let's just assume we are sharing everything in our package.json and we took care with settings of version mismatches. If you find out that you don't want to share everything, well, you have this skip list here that allows you to skip some libraries from bshared. This accelerates your build process a bit. You have a similar configuration file for the shell. And then the shell also gets this federation manifest, a simple file that maps some names of the micro frontends to their locations. To be more precise, it's not the location of the micro frontend, it's the location of the remote entry file, which is the metadata file we've talked about before. This metadata file is generated for you for free. Federation takes care about this, and you just need to point to it. So just define the mapping here and define where to find the micro frontend with its remote entry. This here is a file of its own because usually you want to exchange this file when deploying your application. During your testing, you might have the micro frontend over there in your testing environment. And during production, it might be on a different location. So exchanging this file is a good idea. And perhaps you don't even exchange it. Perhaps you replace this file by a service, a RESTful service that gives you the necessary mappings. When we have defined everything, then all it takes is lazy loading. And usually for lazy loading, we use a dynamic import. A dynamic import that points to this or that file. Some relative path to this or that file could be a TypeScript file. And all we need to do now is to exchange the import, the dynamic import, for this helper function load remote module. Here we are pointing over to our micro frontend. This is the mapped name of the micro frontend. This is the mapped name of the exposed component over there. And then we define which export we want to have. And that's it. This is everything we need to do to lazy load our micro frontend. And as we have seen before, underneath the covers, our defined libraries are shared. Okay. So let's go back to the slides. Let's talk about further challenges we have when going with micro frontends. So one challenge for sure is coupling. In theory, the micro frontends are decoupled from each other, but after all, they are part of one overarching system. So sometimes they need to share data or share source code, as we have seen before. And to define a nice slicing between them, we can go with strategic design, which is a discipline of domain-driven design. It gives you a lot of theory for identifying parts of your overarching system that don't need to know much about other parts. There is never a perfect slicing, because sometimes we always have some dependencies, but the goal is to find some slicing that minimize those dependencies. So strategic design is for sure a good thing. Also, eventing is a good thing for loosely coupling our verticals, our micro frontend. Because when we go with eventing, we just emit an event when something happens, and the other micro frontends can react or not. If they are interested into this or that, they can react on the event, but no hard feeling if they don't react. This allows us to distribute data and information in our system. Can be done in the front end, can also be done in the back end when we want to distribute some domain events like product has been purchased, or product has been cancelled, or product has been delivered. Domain events, also this fits to strategic design and domain-driven design. Another approach is separate ways, where you deliberately decide to not share stuff. Perhaps you have similar things here and there, but you don't share it because you don't want to have the coupling. I mean, the first thing we learn about software design is don't repeat yourself. And don't repeat yourself makes a lot of sense, especially within a domain. However, when it comes to interaction between domains, we have don't repeat yourself on one side and loosely coupling on the other side. And usually we can't have both. So sometimes we have to decide upon if we want to increase coupling or if we want to have separate ways. Both is not possible, so we need to do a smart decision. We need to evaluate on a per case basis. And sometimes two things that have the same name on both sides are not really the same things. Think about a product. A product in your shopping basket could be another product compared to the product in reporting. Both is called a product, and both might refer to the same thing in the real world, but we need a whole bunch of different data here and there. In reporting, perhaps we just need the price and the amount of products that have been sold. When it comes to the shopping cart, we need to have all the information, including pictures and recommendations and so on. So indeed, even though it has the same name, it might be a different thing. We might have a completely different perspective on it. So I think the key takeaway here is decide between don't repeat yourself and between reducing coupling. You can't have both. You can't have the cake and eat it. And inner sourcing is also a nice thing we can do. Inner sourcing means we do open source within a company. This gives us the best of both worlds. This allows us to share stuff. So not everyone needs to implement everything from scratch. But if we need something different, we don't need to wait for the maintainer of this library. We can fork it because it's inner sourcing. We can fork it and send over a pull request. Gives us kind of the best of both worlds, and it gives us agility. When it comes to domain-driven design and identifying verticals, identifying boundaries between our verticals and business domains, then you should look into event storming. It's really a nice strategy where people, domain experts and software development experts come together and try to model the business process with Post-its. And this brings them together, and this leads to a lot of discussions. And so we achieve a common understanding for the business process. And then we do the same with slicing. We try to slice the process into parts, into verticals, into micro frontends, into business domains. And also here, discussions will start. And one more time, this brings together the knowledge of the two important bodies, namely domain experts and software development experts. So if you have such a project, have a look into event storming. It really pays off. Another area with challenges is technical conflicts. You might have naming conventions if you have technical conflicts after loading several micro frontends into the same browser window. You might go with iframes. I know this sounds funny going with iframes, but even though iframes come with a lot of drawbacks, they indeed also have some benefits. They have some benefits we don't find anywhere else. For instance, they isolate really well. With iframes, we can isolate the whole micro frontend away from other micro frontends and from the shell. That means grabbing over there, hacking it by intention or by accident does not work. It's really decoupled. And we have a well-defined messaging mechanism, post message, to get well-defined messages in there or out from there. That's why in critical environments like automotive or like online casinos, online gambling, iframes are quite usual. Even though you might not like them, even though they are not in the top 10 of the most famous HTML decks, they can serve some purposes. They isolate really well. Plus, you can integrate everything, even legacy stuff, PHP code from the 90s or Java code, Java server phases or ASP.NET, Perl-based web applications. You can integrate literally everything. Of course, if you can prevent them, you will prevent them because they also come with several drawbacks. By the way, SAP is also using iframes for integrating their product in the cloud. They have an own framework called the SAP Luigi framework, like Mario and Luigi. Of course, if you can avoid it, you will do it. Also, import maps, script loaders, and module federation, as seen before, allow us to prevent technical conflicts. They allow us to load something from over there, and they have some strategies to deal with version mismatches. And one more time, separate ways could be a nice thing to not share too much so that we don't run into conflicts. Complexity is another field with challenges. To deal with complexities, you can provide starter kits for your teams. You can provide utility libraries. You can provide meta frameworks and guidelines about how to use those meta frameworks. You can go with automated tests that also check if all the micro frontends play nicely together. And you can do a developer survey to find out where you find the pain points so that you can provide further guidelines, starter kits, and utility libraries so that you can also adjust your automated tests. However, as we talk about all of those fields, of those areas with challenges, a lot of strategies for dealing with those strategies, or a lot of strategies for dealing with those challenges might make sense even without micro frontends. So you don't have a lot of burden in addition, because in general, you always should deal with strategic design. Because if you have a large system where several teams implement parts of it, then it makes a lot of sense to have verticals that align with the business. So strategic design, domain-driven design might make sense even though you don't go with micro frontends. And you have the same situation with design systems and starter kits and libraries to make it easier for new people, team members, and teams to onboard. Getting development or developer feedback is also not the worst idea in general, I would say, and so on and so forth. So the thing is, yeah, there are several challenges. We have to apply strategies, but some of the strategies we need even without micro frontends. So now, what is the cost of dealing with micro frontends and applying all those strategies? Well, the thing is, when you go with micro frontends, usually you have several stream-aligned teams in terms of team topologies, teams that work on their vertical, teams that provide business value on a regular basis, hopefully without interruptions. That's why they need to be autonomous. However, we also need a platform team for micro frontends, a platform team that is deciding for or against the strategies we have discussed before, and a platform team that is putting some of those strategies in helper libraries or in an internal framework or in your micro frontend platform. So the thing is, I have consulted a lot of teams or a lot of companies using micro frontends. And all the companies that have been successful with those approaches had a dedicated platform team that were solving issues, applying strategies, providing libraries and helper functions. So this is really vital. This platform team does not need to be huge. I've seen platform teams of 2 or 3 people serving up to 80 or even more stream-aligned teams working on their micro frontends. 80 or even more, 80. So it's quite a number, isn't it? So this does not need to be large, this platform team, but they really need to be experts on the used framework or frameworks, and they need to be experts when it comes to JavaScript itself. So they need to know how the framework works, what happens underneath the covers, because only then they can deal with technical issues that might arise when you load 2 frameworks into one browser window. Yeah. So the key takeaway here is you need a platform team. Otherwise, you will have an issue. And this platform team will just provide their platform, their libraries, their guidelines, their frameworks. So in team topologies, we call this acts as a service. They provide their stuff as a service because they cannot directly work with all the teams. Nevertheless, they will go out to the teams, they will work a bit with them, they will shadow them and find out which challenges they have so that they can address those challenges in the platform. Another thing we need to respect is we need to do a bit more architectural work. We need to evaluate different options. We need to facilitate decisions. We need to communicate those decisions so that the stream-aligned teams working on the micro frontends know why they need to do it this or that way. Because otherwise it's depressing if they are just told, do this, do that, without knowing why we need to do it. Well, we need to tell them, you need to do it that way so that it fits into the micro frontend shell. Also, those points here should not come as a surprise for you, because those are free of the many tasks of a typical software architect. However, if we talk about micro frontends, we need to address those topics, those tasks a bit more, because there are some additional challenges and some additional decisions to be made. So you might say now, yeah, this is exactly what we need, because we have a huge amount of teams. They shall be stream aligned. They shall be capable of delivering business value on a regular basis without any interruptions. And so they shall be autonomous. And in this case, you go with concepts we have discussed before. Or perhaps you say, well, this all is a bit too much for us. We just have one team or a very tiny amount of teams, so we don't want to have the overhead. And then the question is, what's the alternative? And in those cases, what we are proposing to our customers is a monolith, a modular monolith. So we go with one monolithic application. It's one application we are deploying. However, internally, this application is sliced into verticals. And one more time, different teams take care of those verticals. That means we have some amount of autonomy. And also we try to minimize the dependencies between them so that they can do their own decisions, so that they don't need to communicate with all the other teams when they want to provide business value. But still, it's one application that is compiled together. It's optimized, so we can use tree shaking to remove everything we don't need, and everything is usually deployed together. So we get some amount of autonomy, but not the full amount. However, we also get not the full amount of challenges. If you want to implement something like this, like a large-scale monolith, then you need a smart build system, because you don't want to build everything time and again. You just want to rebuild what you've changed so far, and you just want to retest and relint what you have changed or what has been affected by a change. And so a smart build system can take care of this. And one build system I really love to use in the Angular space is NX. And it also comes with first-class support for React and also support for other frameworks. There are some alternatives out there, but I really go with NX. It also feels a bit like the Angular CLI, so it's not a big deal to switch over to it. And yeah, you get incremental compilations and tests. You get everything done in parallel. And yeah, so going with NX is not a bad idea. Besides all of this, NX allows you to enforce modularization. You can enforce this on a library level. You can say this library that is just a part of my monolith is not allowed to access that library. And this in turn allows us to decouple our verticals. And besides this, as mentioned, we get incremental CI/CD, we get a build cache so that we don't need to rebuild something the colleagues already rebuilt, or to retest something the colleagues already retested. And we get everything done in parallel by means of the so-called NX cloud. So some people say we don't want to have that many libraries to subdivide the application into parts. We just want to go with folders. And that's why my colleague, Rainer Hanekamp, implemented the TS Sheriff, which is basically a quite smart and nice ESLint rule. It's just an ESLint rule. And this ESLint rule is highly inspired by NX. However, it allows us to define boundaries on a per folder level, which means we can define that this folder is not allowed to grab over there into that folder. And one more time, this allows us to decouple our verticals so that they can grow and evolve independently. This works with and without NX. And in my example, I'm still going with NX, but I'm switching out the modularization of NX for the modularization of Sheriff, because I want to do it on a per folder basis. So let's have a look into a demonstration of this. In this demonstration, here I have an application. It's called Flights. And as you see here, this application has been subdivided into domains. Different teams work on those domains. We can only define code owners for those domains, which means that if I change something in the domain ticketing, people from the ticketing domain need to do a review in order to land my pull request. And if something is changing something someone is changing something in the check-in domain, people from the check-in domain have to do the code review here. And of course, we have here a shared vertical that can be used by all the domains, because sometimes we need to share stuff, especially technical stuff like authentication or our design system. I would be careful when it comes to sharing use case specific, domain specific stuff, because the idea is to decouple domains from each other. So here we have our shared vertical, here we have our ticketing domain, and the ticketing domain is subdivided into some further modules in a data module talking to the backend and into 2 features. And one of those features contains here my flight search component. It's a traditional Angular component. And please remember, we are still, you see it here in the ticketing domain. And if I want to grab over into a foreign domain, into my luggage domain, I'm getting a hit on my fingers. Rainer, my colleague, is hitting my fingers. He is always hitting me, but it's for the better, because now we see, well, that's not allowed. This is not the idea of our verticalized architecture, to directly grab over into another domain and to use something from over there. No, please don't use it. The linting error we see here is that we seem to be in ticketing. It seems to be a feature of ticketing. And because of the rules we've defined with Sheriff, we are not allowed to grab over into the luggage domain. So better not do this. And this is not only shown as a linting error here in the IDE, we also get the same error when we start the linter on the console. So here we see several linting errors, but in between we also see ours. We are in feature booking, we are in ticketing and in a feature, and we don't have clearance. Don't have clearance for domain luggage. Don't grab over there, hands off. And having this on the console is really vital, because we can automate this check. We can automate it when someone checks source code in, we can perform this check, or if someone wants to merge their pull request, we can perform this check. And if we find those violations, we prevent checking in or merging this pull request. And so we don't have any broken windows anymore. Our overarching architecture, our verticalization is enforced. Quite smart, isn't it? So let me come to a conclusion. What did we see today? We have seen at the beginning, it's first and foremost about verticals. So in the beginning, we should not think that much about how to implement it. First of all, we need to identify good verticals, good business domains that don't need to know much about each other, good business domains that can be modeled separately. This also means we need to apply ideas from strategies, even ideas from event storming. Remember the picture I've shown you before, because we need some proven strategies to identify those verticals. Then it's about several challenges and solutions when we try to implement verticals as micro frontends. There are several benefits. Don't forget about them. But we also have to deal with several challenges. For this, we have some solution strategies. We need a platform team. All the companies I have consulted in terms of micro frontends, and trust me, I've really consulted a huge amount of companies in terms of micro frontends. All the companies that have been successful are going with a platform team. It does not be a huge team. It does not need to be a huge team, but they have to be knowledgeable in terms of the used frameworks and JavaScript in general. They need to know what's going on underneath the covers so that they can provide solutions with their platform, with their libraries, guidelines, frameworks. If you say, well, this is too much for me, then a good alternative would be a monolith, a modular monolith. And when we go with this approach, we can use something like an Axe and or Sheriff to make sure that one vertical is not bleeding into another vertical. And at the end of the day, you need to evaluate if micro frontends pay off for you. If you have a lot of systems and a lot of teams, then it might be quite smart to go with micro frontend. And if they can work in the same repository together, perhaps a modular monolith, a monolith would be the better solution. So at the end of the day, you need to evaluate. And yeah, this is also one of the jobs of a software architect, especially if we don't go with a default architecture. And there is one last thing, and please remember it, namely, good fences make good neighbors. It's all about the business domains. It's all about the verticals. So thanks for having me. I've already uploaded my material to my blog. You find it there. And follow me on X Twitter to stay in contact. Thank you.
So you might have noticed that Manfred wasn't able to present his session and talk in person here live. So we shared the recording of his session. So thank you very much, Manfred, for pre-recording and sharing it with us. Maybe from my side, a few words regarding Manfred. Manfred is a trainer, consultant, and hands-on architect with a specialization in Angular. In this context, I also want to highlight once more our workshops for the conference. So one of the workshops is brought by Manfred and is scheduled for the 29th and 30th of July. So those are remote workshops split in two parts. So each of the session has 4 hours. Yeah, please visit our conference website to find out more about the workshops, and there you can also book your tickets online. Now, as Manfred is not attending here live, we have also Florian, and welcome Florian to the stage. So Florian jumps in and tries to answer one of the other questions we got regarding Manfred's talk. And then let's have a look at the first question, which is, do you have more examples where coupling is not too bad, not bad practice?
I think for the specific examples, we need to ask, of course, Manfred. But one thing that I can come up here is, of course, if you have a very strong relationship that you know will always be required for the application to work, then you might as well couple that, right? But in most cases, of course, you want to prefer loose coupling because that just gives you a little bit more flexibility and resilience as well.
Okay, thank you very much, Florian. We will also forward the questions to Manfred, and then Manfred can also provide his answers to it. Then second question is, right, we take that at the end probably, and then take this one first. What do you mean for the shared starter kits?
So I think what Manfred was referring to is that you can always provide, and I think Luca also brought that up in the keynote, is that you can provide a templating system, for instance, so that when new teams on board with their Micro Frontend, they don't start with 0, but they start already with a boilerplate, right? And that's what you share with all the teams. So something, a code base, for instance, a repository, or a wiki where the snippets are written in there, just to give the teams a head start with the development.
Okay, thank you very much. Then another question just came in. Would implementing broadcast channel API with a pub/sub system make sense for communication?
I guess that could make sense, but I think that also goes beyond micro frontends, because in general you might want to have broadcast system if you want to sync across different browsing contexts, right? For instance, different tabs, and a pub/sub on also makes sense, of course, in my opinion. But then again, there are different ways of communication. It all depends on what your problem is. So for certain problems, an asynchronous communication, like an eventing system, makes sense. For other things, you might want to choose a different mechanism. So there are different patterns, and they fit, of course, to solve different problems. So don't just say, I only have one thing, and with that I solve everything. they all comes, of course, also with pros and cons. For instance, one example is broadcast channel needs to be serializable, meaning that you can't, for instance, transport functions. This makes it rather difficult, for instance, to have a callback mechanism in there. And so you will need to deal in the serializable messages there. But yeah, it can make sense.
Okay, thanks for the answer. And then we have time probably for another question, which is, what do you think about combining bit with micro frontends?
Yeah, so I think Bit refers you to BitDev, so which is a platform for, let's say, creating components in distributed teams, sharing them, and of course composing applications. So what you usually refer to as, let's say, build time micro frontends. Yeah, of course, can make sense. It always depends, right? But if you want to combine at build time, this is a great platform to get started with.
Okay, good. Thank you very much for your answers, Florian. So we will meet Florian later on this afternoon with the second keynote at the end of our conference today. So we're all looking forward to it. And I guess then it's time to answer the generic question is, so what's the difference between the two tracks, what we have? There's literally no difference as such. So it's just we had a high number of talks, and we said, okay, let's introduce two tracks for today. But at the end of the day, it's just two tracks with sessions, and we have the lunch panel and the coffee break in the last keynote as a, let's say, overarching session, so where it's streamed in track one. Okay, good. Then I think it's time to get the next raffle going. Okay, good. So once again, for the taking part in the raffle, please scan the QR code and then enter your email with which you have registered to the conference, and provide your YouTube handle for the registration for the raffle. And this time we have three prizes. So once again, packed ebook. So where you have you can select one of the packed ebooks if you are a winner. Then the second one is again JetBrains rider license. And the third prize is a subscription, a yearly subscription for Wallaby.js. So all good three prizes now here in the raffle. So wait a little bit to have a chance to join the raffle. Wait a few seconds more. Okay, good. Then I guess now it's time to start the raffle for the first prize. Okay, good. We have a first winner for the Wallaby.js yearly subscription. Then let's turn the wheel the second time. Okay, we have a winner for the packed ebook. Then let's have the third attempt. Okay, good. And then we have our third winner for the JetBrains rider license. So thank you very much for participating in the raffle. And now we have a short break in the track one, and then we see each other back in about 6 minutes. Thank you very much.
Hello everybody, my name is Florian Weininger and I'm a solution architect working for the company Smarpiot. We are the creators and the driving force behind the front-end framework Pyral and the Pyral Cloud ecosystem. Today we have Stefan Bley from Zeiss as our guest. His team uses the Pyral Cloud for their product. Hi Stefan, nice to have you.
Hi Florian, nice to be here.
Can you tell us something about yourself and your product?
So my name is Stefan. I'm a software architect at Zeiss Digital Innovation, and I'm specialized in web applications for health solutions with a focus on Angular.
Why did you select the micro front-end architecture pattern for your solution?
Yes, so we develop complex medical software projects, and we needed to split the full solution into sub-applications because in healthcare you have pretty complex processes, and also the teams behind these sub-applications have to remain in control and own their own solution. But at the same time, we also wanted to provide a seamless user experience. And also the teams use different frameworks like Angular and React.
Can you explain how you choose Pyral as your main front-end framework?
Yes, so we evaluated other solutions on the market, for example, SingleSpar. And I mean, many solutions exist, but they usually solve only one part of a problem, like dependency sharing, for example. And with Pyral, we felt that it solved the whole problem space, but also left enough room for customization where we needed it.
And did you face any challenges in implementing a micro front-end architecture?
I think the challenge is to integrate multiple micro frontends with different technologies, especially separate life cycles into one cohesive application. And you also want to enable the deployment and the ownership of the different applications and their teams without any collisions or additional overlapping efforts, so they can do this on their own.
What key functions of the Pyral feed service are you using in your solution?
Yeah, I would say most prominently we use the feed rules and the pilot rules. We use this for authentication of or authorization of these pilots. And the second feature which I would highlight is the pilot configuration. All our teams use this. My favorite feature would probably be these feed rules, as we need to activate and deactivate these micro frontends based on a couple of parameters. And I think another nice feature are the rollbacks, where you can easily deactivate and switch back to a former version of a pilot in case there are any issues.
Stefan, thank you so much for using the Pyral Cloud ecosystem and the feed service. Thank you so much for your time. It was a pleasure.
Thank you, Florian.
Hey, welcome back. I'm Florian Ruppel. I'm the moderator for this session. And what we had so far were two really great sessions, or three in general, but 2 tracks and 1 keynote. And now I'm pleased to announce our next speaker, which is Michael Geers, one of the persons who initiated the Micro Frontend movement and who is also behind the microfrontends.org webpage, which I think for many of us was the trigger point to get into Micro Frontends. Hi, welcome, Michael.
Hey, Florian. Thanks for having me.
Yeah, it's a pleasure. I'm also very happy that you made it here to Munich, to our offices, and that you are now giving this talk from the famous Marienplatz.
Yes.
Cool. So you brought to us today the Drugstore Store version 2. So I'm quite hyped. I already saw, of course, a sneak preview. So I'm very excited about your talk now. I'm honest, for the demos in my presentation later, I still use the version 1, but we will, of course, migrate very soon to the version 2 and show all the great things that you prepared for us. Can you already give a sneak preview in 1 or 2 sentences?
I guess I will just start the talk and then we'll start the talk with a little sneak preview, talk a little bit about something else, and then get deep into the Drugstore Store.
Awesome. So very excited for it. The stage is all yours.
Thank you. Okay. Hello, everyone. Today I'm here to talk to you about tractors and about micro frontends, so some of my favorite topics. Before I get started, a few words about me. So who am I? My name is Michael. I'm a software engineer, front-end architect. I love web technology, love building stuff with web technology. I love the openness about web technology. I've written one of the first books on the topic of micro frontends back in the days, Micro Frontends in Action. And as Florian already said, I built the microfrontends.org website. I work for a company in Bremen, here in Germany, which is called World Büro für Informatik. And we build e-commerce systems or work with larger companies that have e-commerce systems, and in most of the cases, these companies adopt a verticalized structure with independent teams being able to ship features independently. So this is where I'm coming from, where my perspective comes from when I talk about micro frontends. Okay, so let's get started. The Drugstore Store 2.0. So as Florian already said, there is a first version of the Drugstore Store. The examples I show in the you see on the microfrontends.org site, and today I want to announce an iteration of it, so a new version of the Drugstore Store, and it should be a community project, an open project, which gives you material to work with and create learning material, or just check out what others have built. But more on this later. Before I go into the Drugstore Store and the new details, I go a few steps back to motivate why I think it's important to do this and why I've decided on doing this. So let's talk a little bit about learning. How does learning work? So for me, I guess learning works differently for different people. I'm a huge fan of learning by looking at stuff. So learning by example, seeing how stuff is built by having a close look at stuff or under the hood of stuff. So in the open source, in the software world, it's pretty easy. You can look at the source code and see how stuff is built and how the things work, how things lock together, for example. And this is the reason why when I created the microfrontends.org website, where my intention was to share the knowledge we gained when building our first verticalized architectures with modern JavaScript frameworks, how we solve concrete issues. And I thought it's a good idea not to express this in text, but to also show what this means in code. So this example is deliberately kept very, very simple. There are no frameworks in there, but you get the idea of which server owned by which team answers to what request, for example. And this was important to me to really show that, to make this touchable. And then a few years later, after publishing the website, I did a few conference talks, and then I got the offer from Manning to write a book about Micro Frontends. And I thought, nice. Now, a book's many pages, a lot of text. I thought, this is cool. So now I can build a really big example. So tell all about the stuff that you have to solve in a real application. But what I had to realize quite quickly after writing a few chapters is that a book's not a good place to build something that gets more complex and complex over time. So in the book, you try to explain dedicated concepts. So how does routing work? How does isolation work? How does communication work? And you can put them together, but things get quite complicated when you put different concepts together where there are different decisions and they interlock with each other. So I had to realize that I have to focus on the individual concepts, and I created code samples for each of those concepts. And if you know the book, you might have also seen this website. I've created it along with the book, where you can see all of the example code and look browse the code and see the concepts in isolation. So I built a lot of very small self-contained examples that only focus on, for example, routing between different framework applications. But this was a lot of fun, so I like building examples and explaining stuff by example. But what I was missing after writing the book was how these pieces fit together. So explaining the big picture. And I thought about, what I could do about it. And in the meantime, I was part of a lot of new projects where a new Micro Frontend project was built, a new architecture was set up, tech stack was decided, platforms were discussed or built, and in sometimes it was own projects where we were part of the building the project. Sometimes it's just consulting where we had locking points or architecture reviews. But in all of these new Micro Frontend projects, there was always this huge bunch of decisions you have to make before you can build a Micro Frontend application. You don't have to have an answer to all of these questions, but a lot of stuff needs to be decided before you can build something. So do you need an application shell? Do you want to share code? Do we need to share code? Do we want to build a single page application of single page applications? Do we need some kind of module native, whatever federation? Do we want to buy something as part of that solves a problem? Do we need discovery? How does a design system fit? There's a lot of stuff that needs to be decided there. And each of these decisions has an effect on other parts and on the final outcome, obviously. Otherwise, there wouldn't be important decisions. So what you can do to get more confidence by making these decisions is to build proof of concepts. So this is something that we do in all of this project. I guess everyone does it. So to get familiar with the tech stack and the decisions you've made. So most of the time, applications like this come out of a proof of concept. So something where you can click links and click buttons and add something, and counters are a really good example, really pretty example of when you want to show that something client side is working or some state is kept through navigations, whatever. And these work, they are functional and they're important in getting to the final result, to the platform you want to build. But most of the time they look pretty ugly. But that's fine, I guess. But what's not so good, you get technical confidence by these proof of concepts, but having a good idea of is the user experience, the final user experience the users, the customers of our software will get, is it good a user experience? How is the developer experience? Developer experience, maybe we get a feel for it, but user experience with the simple proof of concept, sometimes pretty hard to make a confident decision if soft navigation versus hard navigation, does it really make a difference, whatever. So it's complicated. After making architecture decisions, or architecture decisions oftentimes end up on wiki pages where you have rules, guidelines, documentations, and about specific stuff. So how do we communicate? What are the things we don't want to do in our architecture, for example? And this is pretty important that you have it, because when someone new comes to the team, or some other team did something my team didn't expect, for example, then we have something where we can point to and we can discuss and we can talk about. But oftentimes, if you only have these written rules and guides, they are often theoretical, they are abstract I guess they have to be a little bit abstract. And from an outside perspective, if you come new to a project and were not part of the design and decision phase, they are also sometimes hard to understand. And an example that shows what does this mean when we talk about navigating between different applications and keeping state via X and Y, how does this really look like in code? Which patterns do I have to look for? And this is something that's missing oftentimes. Now a little bit, not another topic, but something that where I come back to the learning by example, what I did earlier. Project that influenced me or was pretty valuable for me back in the day was To Do MVC. I looked it up. The first commit was by Eddie Osmani in 2011, so 13 years ago. And I guess many of you know the project. The idea, it was created in a phase where JavaScript applications, JavaScript frameworks were pretty new, and most of us built web pages using jQuery, for example. And then something like Backbone.js and Ember came along, and everyone talked about it, but no one really knew what it looked like. And the idea was they created an application, a to-do list application. You see on the right the animation where you can have a limited set of actions, but it's not so trivial. You can add stuff, you can check stuff, and you can delete stuff. And this application, the goal was build this application without any framework or with your framework of choice. So there is a Vue.js version, an Angular version, whatever version. And when you build a new JavaScript framework, I guess even today you try to do it to do MVC to show how this application would look like in your new technology. And this is, for me, this was a very, very cool learning resource. And the same team that was behind To Do MVC created a project which is called Movies. I just discovered this project beginning of this year, I guess. This is the same spirit. So they have one type of application, a movie browser in this case, which is implemented in different frameworks, but this time more of these meta frameworks that mostly also have a concept of routing, of having different page types, data fetching, layouts, whatever. So you have an Astro version, a Next.js, a Nuxt version, and you can compare them. And this is how these look. So they all use the same data source. They call the public API of TMDB. So it's an open IMDb project. They all have a similar feature set. So they have a listing page, and then you can navigate down into detail of a specific movie or view via the cast, for example. But what I didn't like so much is that there was no predefined look. So the tasks were defined, but everyone came up with their own style of how to build this. I guess it was a conscious decision, but I would have liked if they were all the same. So the UX differences of these specific choices would be more obvious if you test them side by side. But from a programming, from the code perspective, how to solve specific issues, it's extremely valuable to see these projects. Okay, so last year I did a little bit of research in the Quick framework. I really like the idea behind Quick, so the movement on going from these heavy client-side rendered applications to more server-side stuff. So I guess this fits more with the e-commerce mindset I have. So where mostly server rendered applications are quite a good fit. And when researching Quick, I remembered that 1 year ago at the Micro Frontends conference in 2023, Giorgio Boa did a talk about Quick. So I rewatched this talk, and I saw that he had that he provided a GitHub repository where he did a sample project with Quick and Micro Frontends, so different applications working together, and so really valuable for me. So I was able to go into the details. How did he handle a specific thing? How did he support streaming? Did he support streaming? What did he do there to make this work? What did he have to share? Really impressive and good to find this resource. And now I'm getting to the Tractor Store. I would love to see more large Micro Frontends examples in the wild. So open projects where you can, as a developer, dig in and see how people solved specific issues. And yeah, this is why I thought, instead of writing a new updated version of my book, I want to invest my time in creating a more beautiful but also more featured blueprint sample application for the Micro Frontends community that you can use to evaluate, to test your stuff, and build something upon it. Okay, so the Tractor Store 2.0. This is the product page of the Tractor Store. This one looks pretty similar to the thing we saw before, I guess. So what's new is now we have a header with the logo. This is something that wasn't in the first Tractor Store, but we still have a card button. We have recommendations. We can switch between colors. Colors is also new. Before we did have 3 tractor models, but no colors. But there's more. So let me go through the different parts that we've decided to include in this prototype. Yeah, as I said, more tractor models. So now when you want to build a listing page, for example, and want to think about how would navigation, how would paging work, there's a considerable amount of content you have there. And you can verify things with larger amounts of data. So we have 23 new tractor models and 48 color variants. So most of these tractors, not all of them, have different color variations. And on the product detail page, you can pick between them. You can put a specific color version into the basket and so on. And all of these tractors obviously have cool names. They have also cool color names, and the detail pages also have a nice description text, so you can browse it later on and look at the content we've created there. We've also introduced 2 kinds of tractors. You might have noticed that some tractors are looking quite futuristic, so we decided to keep the classic tractor model, but also include some autonomous tractors, we call them, that are able to navigate their field independently, I guess. We still have 3 teams. The teams have a little bit different names. These are more aligned with the names we use in our real projects. So we try to name our teams along the customer journey and along the specific needs the customer has while doing online shopping. So at first, the user is in the explore phase. He wants to find out what's offered there. So homepage, product lists, recommendations are classical part of this. We also, in this example, included a list of stores, of physical store locations the user can go to. This is also part of the explore team here. We have the decide team. The team is responsible for really helping the user making the product decision. So do I want to buy the red one or the blue one or the autonomous one or the other one, whatever. And the decide team puts everything together and helps the user to make this buying decision. And then at last, we have the checkout team. The checkout name is quite self-explanatory. So this is the team handling the basket and guiding the user through the checkout process. So, and these 3 teams are used with this color coding in the example. And we have of course, new and shiny feature that weren't in the first Tractor Store. So first feature at the bottom, we have built a little helper script you can include, and a little you can specify DOM attributes to signal what the team boundaries are. The boundaries don't have to be the same as here, so you can jumble them a little bit around if your integration technique makes life easier then. But you can you can highlight, show the team boundaries, so see who's responsible for what. But you can also disable the team boundaries, which would make it a lot easier to test the user experience. So give someone a laptop with this page open and say, okay, click through it. Do you notice something? Does it feel sluggish on a mobile device, for example, and without having the distraction of these outlines? Navigation. What we've done here is create. So we have navigation inside of one team. So color selection is you stay on a decide page and navigate between different colors. Here we are on a product list page. You have this filter where you can show all tractors or only the autonomous or the classical ones. You can navigate to the home page, but you can also navigate across teams. So product list, product detail, cart page, that you cross the boundaries. And depending on what you're building, if you want to build a single sparse style application shell application, you can test this cross-level navigation. Like Catherine in the talk before talked a lot about Angular and nested routing. In this example, you can you can test out if this works as you expected. And there are a lot of, well, not a lot of, we try to put not too much in it, but enough to have the most commonly occurring parts of communication covered. So we have this color changing here where other parts of the page also update. So changing the product color updates the recommendation, for example. We also update the URL here. We have a little bit of state. You can add something to a card. The mini card reflects that. You see it on the card page. There's no server-side state in this example. We only store this in cookie, which you won't do in a real online shop, I guess. But we also have a store picker. Maybe you saw it. We'll wait for the animation to go to the checkout page. So we have a form example where inside of a form we have a picker element from another team. This is not a common practice, but sometimes you might face a situation where it is necessary to have a form with a foreign element inside of this form. The form is owned by team A, and the inside thing, a picker, for example, is provided by another team. And you can also try to build this communication with state and whatever. Okay, and to make it a little bit more fun, we also added a little bit of confetti at the end. So if you complete the checkout, fill out everything correctly, you get confetti. And because this feature should be, we also wanted to the Tractor Store to be a good platform to validate if the thing we are building, the amount of JavaScript we are adding, if this leads to good performance or if we get performance issues. So it was important to us that the base Tractor Store, I will come to what the base Tractor Store is in a minute, that this one with no technologies, no dependencies, reaches a LiDAR score of 100. So this is the baseline, and now you can go and add stuff there and try to keep your performance level at 100 or your desired scope, for example. So we have created a solid baseline with all the best practices implemented, and then you can build your stuff on top of it. Okay, so about the project, how does the Tractor Store look? What is it? How does the code look? How can I build my own stuff, or how can I use it in my own projects, in my own prototyping phase? We've created two implementations. The first one we call it the blueprint. So this is the real version where we created HTML, CSS, and the routes, so the features, and also components, but very basic. This is a really simple project. It's a GitHub repository. You see the URL below. I will share them afterwards. And you find a Node.js project there, and it is a monolithic project. So you have one npm start command. It starts a server on port 3000, and then you see the application there. But it is a monolith. We made it a monolith because we wanted to make it as unopinionated as possible, so you can build your own application on top of there. So there's no integration techniques there. There's a little bit of client-side JavaScript using custom events to make these clicking a button and updating the minicard work. But in all places where we could, we kept it as simple as possible. So this is not something you would do in production. You would, build it a little bit more into there. We also didn't include a component model. We used ES6 template strings, which worked surprisingly well. So if you build template strings in combination with Prettier and code formatting, you get pretty close to how it feels to build a React component or a JSX component. But of course, you don't have the luxuries like XSS security and whatever. So disclaimer here, don't use this one in production, but this should be, this is why we call it blueprint. So the basic version that other implementations can build upon. And I guess the more interesting or more user-friendly, but yes, now we have opinion there, implementation is the Preact implementation. So we have these two implementations, the blueprint and the Preact implementation. This is built upon the blueprint. The Preact application is client-side and server-side rendered application. So we have 3 teams. Each team has a single-page application that handles routing inside of their pages. And when we zoom out between these pages, we have a multi-page application. So we have Explore. When you cross from Explore to Decide, you have a hard navigation, and from Decide to Checkout, you also have a hard navigation. In Checkout itself, you now are back to to SPA style stuff with Preact. So a lightweight React version, if you want to call it that, with Preact router and Preact custom element for doing the widgets and the integration. And so we have server-side integration using ESI and client-side integration using custom elements, web components, and I wanted to explore how declarative Shadow DOM feels like. So in the latest browser, I guess a year from now, all of the major browsers implemented declarative Shadow DOM. I wanted to play around with it. So if you want to see how declarative Shadow DOM looks like, it's pretty good fit for combining server-side rendered with custom elements. You can see it there. So you can check out the code later. So we have no live preview of the Preact version right now. I will add this one later. But the other one, you saw a link there. You can open up in the browser and see how it works. A level deeper, let's look at the code. So what comes with the Tractor Store? So here you see a screenshot of the Preact application, but the folder structure of the blueprint looks pretty much the same, just not with JSX files, but with plain JS files. We also didn't include TypeScript here because no opinions. But each of these teams has its own database JSON file, which contains a business-specific data model for the specific team. So we have no shared database, no global JSON file, whatever. Each team has its own database JSON, and in practice, you won't have to touch this database JSON. Just build your whatever you want to do, REST API, GraphQL API, or maybe include it if data fetching is not part of your proof of concept. Just inline the data structure into your JS bundle, whatever. It's small enough to do that. But we've created these database JSON files which include the teasers, for example, the category structure and sorting, filtering, whatever. All your data you need for that are in there. We have a database file for each of these team. teams. And from a component perspective, the blueprint already comes with a componentized model. So you have a button component, footer component, whatever, filter component that is used throughout the blueprint. So in the Preact version, I migrated these components from ES template strings and plain JavaScript to JSX to make this work with Preact and CSS modules, for example. Yeah, but you can make of it what you want. These components are quite simple, quite straightforward, I guess. Yeah, and you can also use the CSS packaging and delivering model you would like. So in the basic version, CSS is just uses BEM notation and manually prefix stuff. Here we have automatically prefix stuff with CSS modules or with team boundary prefixes. But yes, this is what it comes with. And we also did not make a decision or would leave the decision open if you go server-side rendering, if you go client-side rendering, or as I did with the Preact example, combine server-side and client-side rendering. Depending on the area you are in, so most back office applications, I think the way to go is go client-side only. And you can definitely do this with the Tractor Store. You can build an application shell, for example, around it. And then just treat the application as a purely client-side rendered app. So there's no reason why we have to use the server component here, but we can if we want. Okay, and we have a README template, not really a template, but if you want to build your own application, so you can use the Tractor Store just to play around with stuff, use it for a proof of concept, and don't share the results with anyone. It's perfectly fine. This is why it's an open source project. But what I, and I guess the rest of the community would really like is that you build something in a specific configuration with specific decisions. Some of the decisions, I guess, might in all of these cases, that the outcome will be different because there's so much different stuff you can decide against or for or whatever. So yeah. So what I want to encourage you is to take this and implement the Tractor Store with your tech stack of choice, or maybe the tech stack you use in your company, whatever, and then share the result with the community. And therefore, in the Preact application, you see a README file where all the decisions are detailed in a table. So you see what client-side server, client-side integration is used, what we used for styling there. If we implemented a discovery logic, for example, or if we didn't, and it's so the idea is to make these implementations a little bit comparable or easily addressable for others if they find them. And we have hidden 2 bonus tasks in the Tractor Store. As you saw the feature set before. One thing you can do, and this thing is a task that comes up in our project at least very often, is how would a component system look like if we made technology decisions A, B, and C? Should we go with web components? Should we go framework specific component system, whatever? The button component is a really good candidate for extracting it out of these 3 teams. Oh, I guess at the time right now, 2 teams are using this button, and how it's implemented right now, it's copied code. So the button component is not trivial, so I don't have animation here, but this has a, when you press it, you get shadows and what is this very beautiful, but it's not simple CSS, I guess. And it makes sense to refactor this one out and make a design system with it. And so it also has properties and states and whatever. So I guess it's a perfect example to sketch out how a component system would look like in the Tractor Store. Another, if you still have time and you need a new challenge, you can do the mind game of what would we have to change? What do we need to do if we want to scale from 3 teams to 4 teams, for example? What things do we have to change? Who knows what about whom? So the task would be refactor the recommendation strip. You saw the strip earlier. It's on the home page. It's on the product detail page, and it's also on the cart page. It has color sensitive, so if you only have green items in the cart, your recommendations will be green. So there are algorithms behind there. You can look at them later. But the idea is to refactor out these this component, this responsibility, so delivering recommendations into its own team, into its own system. So we also provided a color. If you specify the Inspire team name at the border, you get this nice purple color, so it blends well with the others. Okay, so there are still a few other things I did not mention here, but I guess for now it's fine for you to understand what we are trying to do here. If you want to learn more about the Tractor Store, if you're trying to build a proof of concept or a series of proof of concepts, I encourage you to look at this project. And if you have the capacity to really do an opinionated implementation in a tech stack, you would like a few of the speakers that are here today also signaled that they want to build their the Tractor Store and their technology of choice. Maybe later this day we will see a presentation with a tractor. I didn't know, but I know from one speaker that comes after me that wanted to get early access. You can go to microfrontends.org/tractor, scan the QR code. I will share the link later, and from there you can find the links to the blueprint, to the project version, and look at it. And I'm interested in your feedback. So thanks for listening. If you need help building Micro Frontends projects, if you have interesting stuff that you want an external party to look at, call me. We like doing this stuff. And yes, thank you for listening.
Great. Awesome. Thanks a lot. And yeah, definitely appreciated that we now have some improved graphics here, and overall I also like to have the fourth team, as you know, so this is really incredible. All right. I think we have some questions from the audience. Let's go and let's maybe show the first one here from Manuel. How can we submit our implementations?
Yes, I wanted to do an issue template and stuff. I didn't get around to it for today. When you go to the Tractor Store website, on the bottom, there's a little explanation of what we expect from a good implementation to be added to the list on top of the page. And then you have a submit button, and this opens an email form. It's an email link. I will get this email and I will look at it and I will add it. Maybe I will streamline the process later on.
Awesome, but good to hear that we already have one process at the moment. Yes. And I guess then more implementations will roll in. I also see some comments, so let's just highlight them and maybe discuss them very briefly. Very nice for verifying that this can work with real working application and also different major versions of a framework. So I think in general that is the whole idea behind it, right?
Yes, being able to, what happens if team A decides to update a minor version, patch version, moved from view 2 to view 3, how does it break, whatever. It's easier to do this in a confined, more small, but complex enough scenario. Yeah.
Very nice, great. And I think also from Kari, one add-on to this is that he was just using to do MVC React as an example for creating a micro frontend proof of concept. But of course, this to do is always, on the one hand, it's of course great, but on the other hand, for micro frontends, I mean, I also did that in the past once, and it was quite great. But then on the other side, people might already complained, do you really need micro frontends for that? And of course, yes. You're right. But it's still very nice to just show off that what you can do, right? Right. I think Pascal is asking about a GitHub pull request, but
you can. So the website itself, there's also a GitHub repository behind it, but this one, we have things to do before we publish this. So I guess where we will add GitHub pull requests if we open source the website repository that we plan to do. But if you see improvements in the blueprint, so a colleague of mine a half an hour before before the talks saw that I jumbled up a source that I missed a letter, whatever. If you find bugs in the blueprint, just submit pull requests there, as in any open source project. Yes.
All right. And also, of course, in the same spirit, the next question, sorry, my Hebrew is not very good, but how can I contact you to suggest some new stuff? Email, I guess.
Same email address as submitting, I guess, or just do a pull request. Yes, right.
Great. All right. So this is all the questions I see at the moment. With that, we see each other on the lunch panel again, and we are now doing the raffle. So thanks a lot for the talk, and have a great conference and great time here in Munich.
Thank you. Bye-bye.
All right. So everyone, please scan the QR code, and then we are good to go with the raffle. Another set of awesome prizes here waiting. We got the first ones in. I think we have a JetBrains license, a book, and I forgot which one it is now from Wallaby. I think it's Quokka, but whatever it is, they have such outstanding products. So I think you might be very happy whoever wins it. So in the past, we already had some real nice rainbows there on the wheel of names, but let's see how many are participating. I see already the segments getting smaller and smaller. So I would say let's give it another 3 or 4 seconds, and then let's start rolling here. And the winner is Susanna. No, Yannick. Awesome. No, Susanna. Sorry. Yeah, it was quite fast here on the screen. Susanna, nice. You get the ebook of Michael Gers. Congratulations. The next one is, and it will be Pascal. Yeah, congratulations on the JetBrains rider license. And the last one goes to Mr. Lumpy, Console Ninja it is. So this is awesome. I really like the product. So it's a great output of the console in the browser, then brought back to Visual Studio Code, and really nice visualizations, nice groupings there. Helps a lot in debugging larger flows here. Awesome. Thanks a lot. Then hear you all at the lunch break, which starts in, I think, 15 minutes, and see you there. Bye. We are back. Yeah, I hope everyone has a nice lunch break, maybe breakfast, maybe you're at dinner right now. But for us here in Germany, it's lunchtime. And to have, let's say, a little bit of a different food here, we already brought a nice cake. I hope everyone can see this. So yeah, we got here something. And we will also maybe start eating it already. But in the meantime, I think we start with a nice question for everyone to answer. And please, audience, help us here. Also bring your questions. We are eager to hear it. And the question I have is, what would you say is the most difficult part convincing people to do micro frontends? Michael.
It's interesting. So usually I don't try to convince people to use micro frontends. So
You just do.
No. When people come to me and say they have a problem, and when they talk to me, oftentimes they talk to me because they know I do something with micro frontends. But I've seen many cases where people had issues, but their issues were other issues and not something you can solve with micro frontends. So I would guess when you go micro frontends, you have to prove that decoupling the application in order to gain more speed, in order to develop independently, this does justify the complexity you get when adopting a micro frontends architecture. This does not really answer the question, but I tried not to convince people, I guess.
Yeah, I think it's not always about convincing, sometimes about convincing them not to use it. It really depends on your application, on your requirements, on what you're building, in what is your organization set up, how many teams are developing this, does the user navigate often between different applications. And I think if the complexity in the domain business logic is high, and you have a lot of domains, it might be justified then to say, let's do micro frontends, but then you need to be really clear about architecture upfront to separate those domains, that the needed context handover is kept at a minimum and that everything works.
My side, on top of what we have said today, I would add also the most difficult part, especially if the, let's say, request to move to micro frontends is bottom up, so it's coming from developers and staff engineers, lead developers, etc. I think the big challenge for them, or what I've seen, is translating technical metrics into business metrics. So the fact that so if you have to sell to your C-suite, how beneficial would be the usage of micro frontends. It's the fact that you say, oh yeah, now my, I don't know, CI, CD, or my automation pipeline takes from 50 minutes to 3. That's not enough. So what is, let's say, what is the translation of these 3 minutes to how many, I don't know, features you can deploy in production, how many tests you can do in production, how, let's say, finding a metric that it makes the company sensible about the topic. I think that is by far the most difficult challenge that I've seen teams struggling with.
Nice.
For you, Florian? Don't escape the question.
I think all answers are good, and I share the sentiment. So what I would also add is that there is, many people have been burned by microservices, and one of the problems is that we live in a world where attention spans are short and presentations are very good. So you look today at presentations of Microsoft, Apple, and everyone, of course, also has the same tooling and access to these nice talks. And so you get a lot of shiny things these days. And so we are always in this hype-driven cycle where people are no longer really, as they should, in my opinion, ask, does it make sense for me? What's the context? But they just follow it. And they did, of course, with microservices. And very often that was wrong, maybe because it wasn't a good solution for the problem. Maybe the people also were not really used to it. They also didn't spend the amount of time you need to come up with something, a setup then that works with this technology that we are now trying to use. And so they're very hesitant to use micro frontends. of course, they should still think about the right context, but in my opinion, very often the context is more or less ideal. And then there's still and that, of course, might be also management side, would say another set of development, but it's also from the developers to say, whoa, now changing there, that won't solve a thing. And we also want to go to the latest version of Angular or whatnot. And what can we do here? So in my opinion, this really overcoming this being burned maybe by some other hype cycle and really trying to understand what's the problem. That's for me the most challenging part, I would say, overcoming that.
Fair.
But maybe someone in the audience also has a take on that. In the meantime, while we wait, I would distribute the cake. Because I'm always looking at the cake. I have like a perfect angle. It's like to the camera. And I think everyone here on the first round of answers earned a piece of the cake. So like a puzzle, we're now doing reverse, right? It was already set together, but now it will be taken apart. I think
we won't recompose it later.
Yes.
This looks
Yeah. First one didn't go well, guys.
I take that because
No one saw that.
it dropped, right? And it might be anyway too massive. So you tell me, you see already the, let's call it now the vertical. Tell me the horizontal here. Is it
I would like the mic because Michael.
Okay, so
Yeah.
this is a large one.
That's very smart.
Okay, so hopefully this time it will go better. So great. So Catherine,
Yeah, it's okay.
It's okay, but still, this is many layers, as you expect in a well-done application. And enjoy. You will also get a fork, and you get the puzzle pieces. And I think that
The
also
puzzle piece is
Yeah.
perfect. I always dreamed
now
for
let's
puzzle
make it
pieces.
3 of 3. Perfect.
Thank you.
Self-contained cakes.
Let's distribute the forks.
Thank you very much.
Enjoy life. Start with dessert. Okay. In the meantime, I don't see any more questions, so that's why I now have one left. Just looking out there in teams you've worked with, what is the thing that they struggled with most on the technical side? Because process-wise, I mean, we talk a lot about that, and process-wise, I think there are many things they're struggling with, and that is, of course, then fully company-specific. But maybe technically, we can find something where we say this is where we've seen these teams struggling with. Luca, maybe you start with your side.
I think the biggest offenders, I would say, are definitely server-side rendering. I think there the community has still work to do in order to make it slicker. I think the challenge that involves, obviously, so it depends from let's say, obviously, who is the target audience, because if you think about that, when you move into the server-side rendering part, you might have developers that maybe are Java developers, and they have to do like some Micro Frontends, so they want to do some Micro Frontends, but they don't have skills on the front end. Therefore, a solution like HTMX could be a fantastic approach for them because it's very close to what they are used to. At the same time, when you have like full stack developers that are closer to the front end side, dealing with all the containers or serverless or whatever other compute approach you're going to take, it might or might not be an easy task, because on top of compute, then you think about all the rest, networking part, the security part. So it's stuff that are often over their heads, and therefore, unless you have like a strong team that is simplifying, a strong platform team that is simplifying the work for you, then you might risk that is not getting as slick as possible. So I think that is definitely one of the main challenges I've seen. And probably the second one on the technical side is, especially for teams that are approaching for the first time Micro Frontends, is that there is this confusion between components and Micro Frontends. Because very often the idea of I use the same mindset of before, but now instead of using a library, I'm composing a runtime, is still too much spread across the trenches.
Yeah. So just as a follow-up question before we come to you two,
So one of the challenges I heard or that I see on the server side is that there you can't just assume that, for instance, there's JavaScript, right?
Yeah.
So which means you're potentially on your own. Of course, for Node.js, there are some solutions, and we got, for instance, the now abandoned Taylor project, which was Java-based. But then again, there's, I mean, good luck having your programming language with that framework that you're using on the server being covered, right? So you just need to start from scratch, and then all the other problems come on top of it, right? And
I think though for all the communities that are not JavaScript based, there is still a good path forward. I think leveraging HTML fragment exchange, like at the beginning when we started with Zalando doing that, it's not a bad idea at all, also because it's quite safe compared to other approaches. And now I think HTMX can help a lot, because if you think about server-side rendering, the idea of going every time to the server in order to render a page is normal. And HTMX is using these hyper-driven development where you always pass through link after link to the server. Therefore, there is also, I played quite a bit with the HTMX in order to see how it will pan out in the Micro Frontends world. And it's interesting that, for instance, the similar concept of React server components is implemented also there. So if you want to atomically update a portion of the UI, you will be able to, like Highland architecture or React server components, stuff like that. So that I think is very interesting also for companies that are using other technologies that are not nodes related, and even integration with WebSocket or server-sent events is, let's say, extremely easy with HTMX, that I tried immediately because I found a very cool approach for updating around real time a specific portion of the UI. So I believe there is a lot to play with, and again, I think we have a mission as community also to make for these kind of communities that maybe, if you want, not so close like JavaScript, a very nice and welcoming environment for them, because I believe they have a lot to contribute to this community.
Nice. Catherine?
Yeah, I think it's going in a similar direction. Many teams within the last few years are so accustomed to using SPA frameworks. So since 2016, the rise of the SPA frameworks with Angular and React, many developers do not know what's going on under the hood in vanilla HTML and vanilla JavaScript, and what are the specialities of the browser itself. And this way, really, there needs to be a mindset shift, that the teams are aware what they are used to developing will not work anymore in the micro frontend world, and we have to reinvent something from scratch that's given in a SPA framework. And really the most problematic things is around state management. How do we share state? How do we communicate and not depend on what we are used to having, the SPA, the state framework? And yeah, that's the biggest challenge, I would say. Yeah. And not to violate, not to do dirty hacks. Like, for example, if for security reason it's not allowed to store something in the browser, session storage, local storage, that the teams do not find a way to define some global window variable. To get the mindset to ask, hey, we need something to get transported, and let's define a global, reliable, secure mechanism to transport that.
Yeah. So the question was technical issues people have when implementing micro frontends. So I guess one thing I've observed a lot of times was that oftentimes front-end frameworks, front-end libraries have the concept of single and global scope, whatever, and are built with the assumption that they are they own the complete page. When these libraries started, they were quite simple, and there was not a big problem, I guess. But the abstraction goes higher and higher right now. So we have Next framework. There's a lot of assumption that the complete application manages the header and other stuff. And you, in your talk, talked about modifying the history with Angular router, for example. And these problems are really hard to debug, because you find out that two things operate on the same concept. In most of the cases, it's fine, and then you get into scenarios where things break. You don't understand. People that are not skilled in debugging or reading or understanding these libraries, which are quite complex, depending on what you pick. It's a really hard problem. So I guess many of the frameworks have discovered or noticed that micro frontends is a thing, and providing the ability to having multiple instances of the same framework, maybe different versions on the same page, is something that must be supported from the Quick framework. They have a dedicated micro frontends page in their documentation where they're talking about this topic and what works, what does not work. And I guess I would wish that more and more applications or more and more frameworks would be built or would take this as a concept inside of their development, so that they support multiple instances on the same page.
Yeah, what I think apart from the code is also a challenge and really scary area to discover is how is an application bundled or built or compiled. Not many people know what Angular or so do under the hood with TypeScript compiler, with Webpack bundling and so on. And as soon as anything has to be changed here in how this is compiled, bundled and packaged, problems arise.
Yeah, dependencies, right? It's you need them, but they bring a lot of problems. We also got some questions in the chat, so let's maybe go with them one by one. The first one from Robson: is there any need to manage micro frontend versions independent from their backends? Anyone has an opinion on that?
Yeah, just the opinion that if you build your micro frontend and your microservice independently, you have to be very, very careful in backwards compatibility. And what do you increase first? Do you increase first the backend version, deploy a new backend, and how is this organized? So ideally, you have a micro frontend consisting of frontend and backend versionized together to make sure the APIs match.
For rollbacks, I think that would make the most sense.
Yeah, it's not always possible though, because if you think about GraphQL, then you start to open up a big can of worms, because now that graph, so they work with usually schema federation, therefore that graph is unique, that you like or not, and therefore, and even when you have like, for instance, my previous company, we had to target 45, 50 different front ends with different languages. And therefore, we couldn't align one backend team with one front-end team, because otherwise we create a first-class citizen on one target but not the others. And therefore, API versioning was a thing, and you need to deal with backward compatible APIs for a while. But you need also, the other thing that we learned in the hard way was that you need to have a strategy for decommission old version, because especially if you have like mobile application and web, the adoption of a new version on mobile is definitely slower than one on web, because web is immediate, but on mobile it could take a month before everyone is on the latest version. So therefore you need to have a mechanism that enables you to do a force upgrade on the front end when needed, in order to, let's say, not go crazy with the backward compatibility.
But when you don't have this complex requirements, when you're building a web application, I would highly suggest to align front and back end development and have one pipeline. If you can, yes, of course. It always depends, as we discussed yesterday.
Yeah. But this is also coming from the trend that you separate the front end and back end team. I've been working in full stack teams, domain relevant full stack teams, and this makes your life a whole lot easier. Also to make it understandable. What do I need to make backwards compatible, and to have some testing awareness of your domain with complete backend and front end.
Yeah, this is one of the best parts of micro frontends, that you can now have these full stack teams, and not only, of course, stopping at development, but also maybe a designer there, some guy who knows about the business, and so therefore having everything covered, that you're really fully autonomous, right? Then you have one if you're there. But unfortunately, not always possible.
But even if you are able to create self-contained system, front and back end, with all the disciplines in there, you still have this runtime mismatch. So having an API that's deployed to a server that sits in a data center, and then having a single page application in the front end that is not updated, can force update it, but maybe you don't want to force update it. And the API, when the API is updated, so you still, in these scenarios, have to think about making API changes non-breaking to at least support the previous version that was deployed. Whatever. So in the projects I've worked on, we had some kind of agreement or rule that when we do breaking changes, that we keep them along for 1 day or 3 days time frame, where we can consider all users to have reloaded by now, for example.
That is needed. Great. Let's pick the next one, because I think it fits rather nicely in if we covered the previous one. So this is Lava is asking, what is your opinion on deploying the shell and a bunch of microfrontends to be built and deployed in one Docker image and each repository in a separate Docker image? So essentially already going into the direction of we deploy something, and as a unit of deployment, we have here Docker image.
So the question is if you have like application shell bundle, so deployed alongside with the Micro Frontends in the same
essentially what I understand here is a mix of one is a build time composition and the other is then runtime composition, and I think the cut is then maybe on, let's call it a core layer of Micro Frontends that may be developed in a monorepo, and then you have maybe other teams developing not so essential Micro Frontends in other repos. So at least that's how I understand it as unit of deployment they're using here, Docker.
Yeah, I mean, the advantage of deploying everything as a build time composition is that you can test it upfront and not realize the exceptions at runtime. And the downside is if one of the Micro Frontends needs often updates or versioning updates or whatever, you don't want to build the whole bundle again only for this Micro Frontend. So it always depends how many times you have updates, how many dependencies, shared, versionized libraries you have. But you can have a mix. You can have a shell application, many build time libraries in there, and maybe 1 or 2 module federated or web component injected Micro Frontends.
All right. Maybe then this goes into a direction also to see some of these things in practical use. David is asking, I'm interested to hear about some of the largest platforms or sites or applications that the group has worked on. So large in terms of, for instance, traffic or number of users, maybe also, I don't know, lines of code or something. Look, I mean, you worked from New Zealand to Silicon Valley.
So the one that I worked the most from scratch was the Zone. Or the D is N or dozen. There are plenty of ways to say that. And that was a platform that has huge spikes of traffic. So we moved from tens of thousands users in the platform. A few minutes before a live match, like imagine like the Champions League final, we moved to a couple of million users in a minute or so. And therefore, everything has to scale for that specific minute. That was the challenge that you have when you deal with live. But then after that, I followed quite a few other customers, a few public references that I think we can mention. It's, for instance, PayPal did quite a few talks about Micro Frontends, and if you go to the web application, they're using Micro Frontends. It's been a while that they're doing that, and they're doing successfully. That is a fantastic testimony. Here in Germany, we have another big brand that is Adidas, that deliver a few talks about Micro Frontends. They use like a vanilla implementation, if I remember well. They're not using any framework, but also for them, let's say, if you think about the e-commerce, how much traffic they have, it's crazy. There is in the UK, for instance, there is an e-commerce called Danelle that raised in popularity during pandemic a lot, and they're using server-side rendering Micro Frontends. So, and obviously when there are, let's say, high traffic and there is like Black Friday or stuff like that, they scale very nicely with that. So I think nowadays the problem of finding references is definitely less than an issue compared to a few years back. Now I think many companies are embracing, even Netflix, like they released Lattice, I think it's called, the framework. So there are plenty of companies using that without any problem. So yeah.
Anything to add?
So the German e-commerce
Yeah.
example.
Yeah.
So this
Exactly.
is our business domain. So we have a lot of experience with e-commerce platforms. But since I'm not the DevOps guy, and auto scaling usually works
Out of
in
the
the
box.
project.
Yeah.
So so I can't give real numbers, but it's definitely an area where you get a call when things don't work and when things don't scale properly because they can calculate how many minutes offline relates to how many euros in conversion, for example. And I guess being able to split and doing this Micro Frontends architecture there, so having a lot of traffic on the catalog pages, for example, and then only this team has to make sure that the search is running smoothly, for example. This also helps compared with how we did it back in the days when we had a monolith and it was not possible to just spin up 10 of these giant monolithic applications, for example.
Yeah. But it's usually the backend you have to be more concerned about. I also used to work in e-commerce, and we had these Black Friday peaks, we had newsletter advertisement peaks, and usually we did performance load testing upfront to ensure we can handle 10 times the normal visitors. And then it's usually the backend that crashes, because if some calculation happens on the front end, it happens in your own browser, but on the backends, the server have the load, and there we need to scale much more.
Cool. We don't have so much more time. I would maybe take one or two more questions. Let's see how long we need to answer. More and more. But let's pick this one here from Pascal. What things in the native or vanilla web implementations or the browser API, let's say, are missing to build on the native platform instead of relying solely on frameworks to orchestrate things? Maybe I pick that one
Go
off,
for it.
and then
you know already where I'm going, so probably we have the same answer.
So it depends already, because what do you want, right? Because for instance, if you want to have perfect isolation, you would today say, well, if you need that, use an iframe. So what is stopping you from using iframe? We can't do that isolation. We can isolate styles, for instance, a shadow DOM, but we can't isolate the JavaScript. And for that, we would need, for instance, the realms spec. And that is, we talked about it beforehand. 5 years ago, they said it will come. Maybe in 5 years, it's fully there already. Now we are 5 years away still from it, and maybe in 5 years.
We don't know how long.
I won't give up on it. So I'm optimistic here. But this is, for instance, one thing. Another is, well, on the sharing side, we already have import maps, which are great, but they are still very limited. So you couldn't, for instance, extend them once it's set up, right? So you cannot, for instance, bring in an ESM loaded and then expect it to extend that import map list. So once the first ESM is loaded, the browser then fixes that, and there is no way for you to extend it and build upon it any further. Which is also one of the reasons why in native federation you can't do the cascade so well, because you need to know upfront already what's there, because you need to build the import map. It's also the reason native federation carrier script is a normal script and not an ESM already. And so it's little things like that. And quite often, if you follow the spec or the discussions that happen also in the open on GitHub, someone brings up the topic of Micro Frontends and said, hey, wouldn't it be great to have this? Wouldn't it be great to have a scoped element registry? Wouldn't it be great? And very often the discussion then ends with someone saying, no, we don't see the use case. And I'm like, come on. Maybe then some years later, we see that the scoped registry, it happens. But in general, I think we are getting closer and closer. It's just that on the JavaScript spectrum or the APIs there, it's not moving so fast. CSS, for instance, they made great progress in CSS. I mean, now Micro Frontends with CSS, they are really doable in my opinion. There's not so much room now for conflicts and everything, with Shadow DOM especially, but there are more and more things coming. And CSS, I feel positive, but JavaScript we are lagging behind. I see I'm nodding, which means
+1 on the industry.
It was an exhaustive answer. So.
But maybe it also just needs a catalog, a better organization. What vanilla APIs do we have to find a set of APIs you can use as a toolbox?
Well, one more thing to add is maybe even if these things exist, maybe you still want to use a framework.
Yeah.
But the reason is not
Yeah.
that a framework could do something you couldn't. It's just maybe gives you already
More
a boost.
convenient,
Because
yeah.
I mean, what React does, for instance, you could also do. What Angular
Yeah.
does, you could also do. It's just, you know, they do already so much. And do you really want to reinvent
Yeah.
everything that they do?
Yeah.
So with that in mind, we would have more questions, but maybe then for the coffee chat.
Exactly.
It was great having you guys. Enjoy the rest of the cake. I
Thank
see Luca, you need to have now more of that. And with this in mind, we go to the raffles. So let's see who will win now some prize for the lunchtime raffle. Let's give it a few minutes. So we have at the moment over 100 viewers in the stream and 3 prizes to hand out. And I can take more of that.
Of course, I was doing that.
So at the moment, the segments are still quite okay. We're getting more people in. So the segment is getting smaller and smaller, but the moment you would still have a good chance to win, I guess. Let's give it another 30 seconds. So once you scan the QR code, you need to enter the email address that you used for entering the conference and your screen handle name that you use it in the Discord chat or on YouTube. Don't forget the Discord, because if some questions not answered in the YouTube chat, always enter the Discord. That one will stay active even after the conference, and we will answer all the questions.
Yeah.
And most questions will be answered with "it depends," but but then we might argue why it depends and what the conditions are. We should have a meme for that, and we can always post a meme. So it's like, good question, but it depends.
Neil Ford and Mark Richard used to say that we should take the least worst, let's say, solution in order to make our application working. And usually everything is a trade-off. So
yeah,
if they say that, I'm perfectly fine to say it depends.
Should we start? Let's start the raffle. Oh yeah. Okay, so full rainbow again. Now a little closer, who will it be? Hard to tell still. Robson wasn't there. Maybe you win something. I don't know if you got something already today. But now is the time for Lucky Loogie. Awesome. And you win a license of JetBrains Rider. And I know that you are using .NET, so congrats. And I think this will be highly useful. So spin it. And it is Shilipi Priya. And you win another license of JetBrains. This is one of the ones where we have 3 JetBrains, but anyway, I hope you can use it well. Rider is also an awesome IDE for developing web applications, so therefore enjoy. And third one. Unfortunately, we don't hear the ruffle sound here.
Yeah.
It's a clicking sound.
But yes.
It is a clicking sound, yeah. On the stream, you could hear the clicking sound. It also would, I think, run more smoothly than what we see in the preview. But it was Be a War, and you get a packed print book. So this is like insane. So congrats. We will contact each winner after the conference via the email address, and make sure to not have us in your spam folder, because then, of course, we can't deliver the prize to you. But congratulations to everyone, and then see you in 10 minutes with the next sessions.
See ya.
Hello everybody, my name is Florian Weininger and I'm a solution architect working for the company Smartyacht. We are the creators and the driving force behind the front-end framework Pyral and the Pyral Cloud ecosystem. Today we have Christian Bormann from FSD as our guest. His team uses the Pyral Cloud for their product. Hi Christian, nice to have you. Can you tell us something about yourself and your product?
Sure. My name is Christian Bormann and I'm in favor of being a technical project manager of new tools and services we are creating here at FSD. And generally, our company aids the periodical technical inspection of vehicles. There is a huge demand of data at this site to be managed. This is where the Pyral framework comes into play.
Why did you choose the front-end, Micro Frontend architecture for your product?
Yeah, it's like this, that we face some problems with our mono repositories. We face situation that Team A wants to deliver or publish some feature in our test cluster. Team B, for example, wasn't that ready and developed a feature which is just accessible in the dev cluster. We always say, hey, teams must be isolated, independent, and responsible for their work. And so we faced a situation that those teams were blocking themselves. We thought, isn't there something like microservices, but for the UI?
Yeah, you made the decision to pick Pyral as the main framework for this application.
Yeah, digging deep into documentation about Micro Frontend as architecture pattern leads us to Pyral. There were a lot of documentation, a lot of examples, online resources, and videos. And
did you encounter any challenges in implementing the new architecture into the product?
We couldn't have known this beforehand, but I have to say the support was very outstanding. Sometimes like instant, so there is Discord channel and also also the Git repository where problems were mentioned and quickly solved. So that was nice, yeah.
And how does the Pyral feed service fit into your architecture?
We are happy to use this feed service, which perfectly fits into our existing microservice architecture. This service has the domain of managing the GUI modules.
And what are the key functions of the Pyral feed service that you use in your solution?
We like that the whole management can be done. So like configuration, to being able to disable specific modules or to make a version downgrade, for example, to have also some feed service groups. So
if I would have to ask you what is your favorite feature of the Pyral Cloud feed service, what would you say?
I would say the version downgrade feature. So to have just one click and to restore the last working version of this graphical module, it's very nice.
Because it's also seamless, right? You don't have to deploy anything, just refresh the page and it gets it instantly.
Forget to mention, you do not have to redeploy it because it's existent in the service itself. The service serves the module. For this, it's perfectly fine and helps us here a lot.
Thank you very much. This has have been a pleasure. It's great to have you guys using the Pyral Cloud ecosystem. And thank you so much for your time, Christian.
Thank you, and nice day, and keep up the good work. Yeah.
Thank you very much.
All right, welcome back to the Micro Frontends Conference 2024, and welcome back after the lunch panel. Hope you had the opportunity to stop by the lunch panel and had a good lunch break as well, or another break, depending on the time zone you're currently in. I'm very excited to introduce two speakers from Zeiss Digital Innovation to the stage now, Stefan Bley and Lukas Breschke. Welcome. Stefan Bley is a software architect at Zeiss Digital Innovation in Berlin, and Lukas Breschke is a full-stack developer also at Zeiss Digital Innovation in Berlin. And they have both worked quite intensively with Angular already, and also have gained a lot of practical experience already with Micro Frontends and the Pyro framework at Zeiss in the area of performant healthcare digitization. And today, we will learn from them about a fundamental topic of Micro Frontends, namely how to manage dependencies in your Micro Frontends project, maintaining consistency and reduce loading times in such a project. It was actually also a topic that came up during the lunch panel, so I'm very excited about this now. They will also discuss the challenges that go along with sharing dependencies and how to overcome them, and introduce their process to ensure a collaborative effort between all Micro Frontends. Very excited now to basically introduce the title of this talk. It's Hitchhiker's Guide to Dependency Management in Micro Frontends, and the stage is all yours, Stefan and Lukas.
Yeah, thank you, Felix. I hope you can all hear me well. You've already introduced us, so I can maybe skip our introduction, except of the fact that Lukas is in Dresden. But we do Micro Frontends in the healthcare industry, and we have, before we ventured in the Micro Frontends, we had a strong focus on Angular frontends. I would like to first give you the context of what we will be talking about today. So we are in healthcare, as I said, and we help creating a software solution that helps medical staff in their daily work with patients. And depending on the nature of the features in this solution, or let's call them modules, they can be classified as medical products. And when you are a medical product, this means that you have very high quality standards, because this is a product that involves patients, real patients. High quality standards and also regulatory requirements. And this usually goes along with very complex and time-consuming processes, including documentation and verification by the legal bodies. So we want to keep these processes to a minimum. They can take weeks or even months. So if you have one change in a part of this solution, it should not slow down the rest of the solution. And that's why we decided to modularize the solution using a micro frontend architecture. While we wanted to provide a good user experience, having an integrated solution, we, for example, also including single sign-on, custom look and feel, common look and feel, we modularized the solution, which enabled us to have independent release cycles of these apps. And the sub-application can be owned and developed by different teams. And to still have this integrated solution, we also needed to enable the applications to integrate with each other, to have this seamless experience for the user. And there's an extra requirement given by the nature of these independent teams, which are also sometimes of different companies. We had to allow for different technologies. Now, so this is all cool. This is a funny project. We have a micro frontend architecture. The apps can use their own technology and dependencies. We also even share some dependencies because we are kind people in the app shell team. So what could possibly happen? I will present you one worst case scenario that actually happened to us. And this is when we first wanted to update Angular to the next version. And by the way, we shared Angular to all the micro frontends. So we say we want to update to Angular 17. And Lucas, can you please click? And the first app says, yeah, that's cool. We also want to update. We need the new features. And the second app says, no, we won't update our app to newest Angular because we are even out of maintenance. We can't develop anymore. We can deploy a new version. So what we eventually had to decide is to deactivate this second app from the productive system in order for the others to still run. Okay, so this talk is about dependency management. So let's look into what dependencies are. And first into the question why we would want to share dependencies. There are a couple of reasons. And the first one is for performance. If you go on, please. So performance, I think is obvious. We want to reduce the bundle sizes and we want to decrease the loading times to enhance the user experience. For example, if you consider the Angular framework with a megabyte or a UI library with fonts and images and all this, which in our case could be 5 megabytes, you don't want 10 or more micro frontends to bring this all along with them. Second reason to share dependencies would be consistency. We want to ensure a consistent look and feel by providing component libraries, for example, and also enforce compliant versions. Compliant meaning compliant with the current UI design, so we don't have any outdated design. And we also want to enforce consistent functionality, for example, by providing a certain version of a library that has the functionality that we expect and not something outdated. Third reason to share dependencies is to prevent runtime errors with libraries that cannot be used in different versions at the same time. In this example here, we see a runtime error from PDF.js, which cannot be used in multiple instances at the same time. And it will just error out at runtime. And lastly, we have security as a reason. Imagine there is a security vulnerability in Angular 17, for example, which has been fixed in 17.03. And wouldn't it be good if we can just provide that fixed version to the micro frontends, although they have been built with 7.00, so that they can benefit from this security fix and don't need to roll out their app again. Okay, so now that we know why we would want to share dependencies, let's have a look into the types of dependencies. And I've clustered them here into 3 groups. The first one is what I call the easy group. These are small dependencies. They don't have any global variables and no other dependencies. And they usually don't need any special consideration in the micro frontend setup. 2 examples here would be RxJS or Lodash. Then the second category is what I call the tricky ones. They are larger. They might have global variables and incompatible API. If we, for example, consider Angular, it is quite large. It also brings dependencies like RxJS, or even teams use NGRX, and we also see this as a transitive dependency then, which needs to be considered. Angular also brings Stone.js, which creates problems on its own. It has global variables, like zone variable, also on current. And different versions have incompatible APIs. And it is unpredictable which version will be used in a given context, which then can lead to inconsistent behavior. And the third group is the very hard ones, which are just not made to coexist. One example would be web components. It was already discussed before that only one version of a custom element can be registered with the DOM at a time. And there may also arise style conflicts when they define different styles for the same custom element. You don't know what you get. And the second example I already teased is PDF.js. This library registers service workers to cache PDF files and improve performance. And in order to prevent multiple versions of PDF.js to register new service workers with different behavior, PDF.js JS itself does not allow multiple versions and then errors out at runtime. And with that, I hand over to Lucas to present us common use cases in Micro Frontends.
Yeah. Hello, everybody. Also, welcome from my side. Great to be here. Yeah, now we know what we want to share and why we want to share things. And now let's have a little bit a look at the how, and we can share these dependencies. But before we do this, let's have a look at the use cases our solution has to support. So the first one is that we want to use here different versions. This could mean on the one hand side, something like we want to use Angular in version 16 or 17 in parallel, for example. But also, like we have seen an example at the beginning, maybe it's important to be here backward compatibility. Could be very important if we, for example, share your Angular as an app shell and we move on to the newest Angular version, that an old micro frontend still is able to operate. Also important, like we have seen, for example, with PDF.js, that we might have some dependencies which should only be there once. So we need to ensure that this is only existing once and only is loaded once. Also, a common use case, which we have in our project at least, is that some micro frontends want to share a dependency from their own. Let's say we have two micro frontends here who both use something like a whiteboard, have a library for that, and they don't want that this dependencies may be very huge, so they don't want that this is loaded twice, and they want to share this on their own. But actually, this is not the concern of the app shell to provide this library. So use case could be that they also want to share this by themselves with their other micro frontend, for example. And last but not least, what we have also already mentioned is this security issues. So let's say there's a vulnerability in one of the libraries, and it could be important that we update these. And this would mean that we would try to force an update here to maybe the next minor version or the next patch version, if possible. All right, with that, let's have then look at the actual solutions. And some quite common approaches are listed here. So one is the universal module definition. We have module federation, which also talk quite a lot about this here today, import maps, and system.js. In general, I try to give you now an overview about these solutions and will not go that much into details here because actually to all of them, you could do an own presentation on your own. So then let's get started with UMD here. UMD is a module format actually from the dark old days where you had actually some problems to use the same library in the front end as well as the back end. And consists mainly of two functionalities here. The first one is on top, where we actually in the end define the context in which the library is used or the dependency. And the second one is the actual implementation of the module itself. So what happens on top? Root and factory is used, to distinguish or to figure out in which context the dependency is running. So first check is actually if this is an AMD context. Second one is then checked if this is a common JS context. And last but not least, it's then expected that the dependency is used in the browser. In all three calls in the end, AXJS is used as a dependency, and in all three, it's actually expected that AXJS is already loaded. The second part is then the call of the function itself. So what happens here is there's first of all a check if self or this is defined. And then we have in the end our factory, our function here. And here you could in the end implement your own code. You can export things via the exports, and you could also use AXJS here as a dependency. The final result, if you would then call this module, for example, in the browser, would be something like window.mymodule.action, and then I could call this function. So this is an example how this could look like if you use this then here in your index.html or something like that. If you have script tag, which loads AXJS from a content delivery network,
And after the UMD module is in the end loaded, you can see that we can use then AXJS here via the window. And yeah, we have then completely access to all of their provided library functionality in the library. So then what I personally like really about UMD is the simple setup. We used this once in one of our prototypes, and it was actually quite easy. So we get started with UMD as we approach Micro Frontends since then. But at least on my point of view, I personally would not use this today anymore because there are other solutions out there. And in general, UMD is quite outdated. It's not that new anymore. We have now E6 modules, which I personally would, of course, prefer here. But it has also other downsides. For example, UMD could have sometimes some problems with naming collisions. If the imported dependency has a different name than the file itself, there could be issues sometimes. And also, this resolving of the dependencies, the example which you have seen before will work definitely, but we are talking here about dynamically load and unload micro frontends. So there could be maybe some conflicts here that maybe your XJS library is not loaded yet, and then you access the window object, but XJS is not there. So there could be some issues. So yeah, UMD could be in some situations quite somehow tricky, and there could be race conditions. It works definitely, but you have to be a little bit careful. Okay, then let's have a look at something maybe more modern. And we have talked today quite a lot about that. So once again, I will not go that much into details, but there's of course module federation. And this is an example here, how this looks like for the Webpack configuration. So we initialize a new module federation plugin. This has a name. You can have a file name which should be exported. You can expose here your components. But what we, of course, are interested in is here this shared entry. In this example, we have here AXJS. And module federation provides actually quite a lot of possibilities which you can configure here. For example, we have here eager true. This means that this library has to be there if the module is initialized. Singleton means this dependency should be only there once. And also we have this required version here. This follows the same notation like NPM does. So in this case, every 7.8 version would be fine. And the patch version would be ignored in the end and would just use the highest one, or the one which is provided by the app shell, to be more precise. What we have to see this in one of the other presentations today. The result would be that AXJS would be a separate bundle. So it would not be bundled as part of the module one, but it would be separated and could be loaded if required. So it's some form of a fallback here already. So in the shell itself, it looks quite similar. Also here, we initialize our module federation plugin. We have here as well a name. And what is here, of course, important is which dependencies should be shared from the shell itself. So then let's have a look at the code itself. If you use this plugin, you have access to certain methods. The first one is here in the first line, this Webpack init sharing. What it does is it initializes a new list of shared dependencies based on the configuration in the initial module federation plugin. Then we create a script, load our module, append this to the DOM, and after this is loaded, module one will be available in the window object. What is then missing is that we need to initialize this module. And for that, we actually need to provide here our list of shared dependencies. And then the module in the end will check, okay, which dependencies does the shell provide? Which one can I use? For which one I have to use my own fallback? But also it will enrich this list of shared dependencies with its own dependencies. So let's say the module will provide here, for example, Lodash. Then it would be added as well to this list of shared dependencies. And another micro frontend could then reuse these dependencies as well and does not have to provide its own. Yeah. In the end, modification is very mighty. There's a reason why we talk about this that much. It not only provides you, of course, utility to share dependencies, but in general, it's a very solid solution. What I personally like quite a lot about this is this version resolution, which is already here built into this approach. So we don't have to care about anything. It is all happening at one time. We don't have to provide here our own meta system or something like that. It's all included here. And of course, we also don't have to care here about resolving of dependencies. This is all done by the plugin in the end. So we don't have to care that everything is loaded or something like that. This is all done here by the framework. Only downside here is that we are bound to Webpack, which is of course a risk you might want to take, but still, at least from my point of view, this is a downside if you are bound here to one certain bundler. There are maybe faster bundler out there which you might want to use, so then you are here somehow limited. Okay, with that, then let's have a look at the more agnostic approach. I'm talking about import maps. Import maps is an standard of the browsers, which most of them supports today. And it's actually quite simple. You have one script tag with a type import map with a JSON structure. And the most important property is imports, where you can specify where your dependencies are available under which domain or which URL in the end. For example, I provide here an approach how you could use AXJS in parallel in version 6 and version 7. In this case, we load them from a CDN, but in theory, you could use here also your local domain, or I don't know, something else. And if I want to use them, it's also quite trivial. I just have here my ES6 module, and I can use my ES6 imports to just use these dependencies. And of course, they are not resolved if the import map is loaded, but only if they are used. So I only load those dependencies which I also need. And then I can just use them in my code like I'm used to. So a little downside is here, of course, the browsers, which supports import maps. All new browsers actually support them, like we can see here. But for example, the old Edge is not supported, or the Safari 15 is not here. And of course, something like Internet Explorer or something like that will also not work. So personally, once again, what I like about this is this is native browser functionality that I can use my pure E6 imports, and this resolving of dependencies is all done by this ES6 modules. And once again, I don't have to care here about anything. Downside is that there can only be one import map. So let's say I load my Micro Frontend, then it not can just add its own dependencies to this import maps. They all have to be defined before we use this. So at the start of the application, if we fetch the application in the end. So I really need here a central register for my dependencies. Also, browser support is somehow an issue. Like I said, new browsers are supported, but if you have to support some legacy browsers, you could run into some troubles here. With that, let's have a look at System.js, who somehow tries to solve this gap. System.js is also a form of module. Every modern bundler is able to produce this. And in order to use this, you need a library as well, the System.js library, which needs to be initialized once. Afterwards, the system is then globally available, and you have this .register functionality. And the two important properties here are this array at the start and the factory here as well. In the array, we can, in the end, also, similar to UMD, somehow define here which these dependencies we need. And this factory needs to return an object with setters and execute. These setters are invoked in the same order like our array at the start. So right now we have here only AXJS, but let's say we would have Lodash, then there should be a second setter, and the first setter would be called for AXJS, and the second setter in the setters array would be called for Lodash. Then we have here our execute property, which will invoke if our module gets loaded. In the end, once again, similar to UMD, we can in the end define here our module, we can write our code, and we can use this underscore export notation to export anything we like. System.js also supports import maps, so we can then use also import maps here on all the browsers. In this case, we have one that's again our XJS example. So yeah, System.js provides actually everything, at least from my point of view, that import maps already provide, but of course, it will fill here the gaps. So in theory, you can use this System.js also, of course, in your backend, but also in the Internet Explorer if you like. It's backwards compatible, and I personally also really like that you can use here almost the same semantic as we can use for our E6 modules. Own real downside is they have here additional dependency, so System.js needs to be there, and sometimes there could be some little quirks, but in general, it's of course working wonderful, and I can really recommend this. So besides our technology approach, we have also some other things that we do as an app shell team. And what is there the most important thing is, of course, this to ensure this backwards compatibility, that something like we have actually described in our worst case scenario at the beginning will never happen. For that, all modules, all micro frontends should be self-contained and not be dependent on any external dependencies, because they could change for some reasons or the other. One of our key tasks is here, of course, to facilitate between the teams, support them to implement their business use cases, and also, of course, the coordination. Especially if you're talking about major updates, this needs to be coordinated. We need to all be aligned, and we should also, of course, try to target here the same version. It really does not make sense if every micro frontend provides here its own Angular. So something we do is we establish target versions for our releases. It could look something like this. We are talking about now 1.2, 1.3, 2.0, and they don't match with the dependencies. But what we do is we say, okay, in version 1.2, we use AXJS in version 6.6. In version 1.3, we use version 7.5. And we do this because we have these long release cycles. So micro frontend teams need really time to adapt here. They need to be aligned. We're talking here about quite a lot of people, quite a lot of micro frontends, and all of them need to plan this effort. Especially a major update is, of course, not something you can do in some cases on an afternoon. Sometimes you need to really spend effort here to make this work. So for us, this is one of our main responsibilities, that everybody is aiming here for the same versions to decrease the bundle size as best as we can. With that, I will hand over once again to Stefan.
Yeah, thank you, Lucas. And I will give a short summary of what we have achieved in our project. So we managed to create a micro frontend architecture in a healthcare setting with all the requirements that come with it. With single page application composition, currently supporting Angular and React as frontend frameworks. And we integrate currently more than 12 micro frontends from individual teams with different technologies and also around the world, the teams being located. And the number of these micro frontends is still rising. As we have learned, dependency management is a challenging thing. There are important reasons to share dependencies or enforce equal versions, as we've learned, and at the same time also allow the feature teams as much freedom as possible. You always need a solid concept that includes clear processes, for example, for the version updates, as Lucas explained, the focus on backward compatibility, thorough documentation, and also you need to foster a communication between all the teams involved. I think we have come up with such a concept, but we haven't solved all our challenges yet, which leads us to the outlook, what we can improve. And there I want to highlight two things. One would be better tooling. So we can imagine that we provide some linting where we display conflicting versions of libraries before runtime. So it might be at build time or at the deploy time when they upload their pilots. And the second thing, which was actually already mentioned in the panel talk at lunchtime, is about web components. There we still have this limitation of custom elements, which can be registered only once in the DOM. And as you know, there is the scope custom element registry proposal out there, which would then help to create multiple registries, which can then be attached to shadow DOMs, and which would then resolve the problem for web components. We're currently looking into these two things, also others, but these have our main focus. And yeah, I think we are on a good track. With that being said, I thank you for your attention. And if you have questions, please go ahead.
Thank you so much, Stefan and Lucas, for this very informative talk, breaking down all the different ways to share dependencies in the context of micro frontends. Great stuff. There was also like a lot of comments coming up in the section, and I will just choose one of them. The first one was from Denislava. She was asking, what framework are you actually using for micro frontends applications with Angular? Maybe you can also like elaborate a little bit on that, why you chose it.
And now if you have seen the commercial, but we're using actually Pyrrole here. And it actually helps us quite a lot to facilitate this. Provides already quite a lot of utilities, also has its own notation to set up these import maps. But they were, especially with Angular, we had recently an issue, for example, where it was quite hard to use here Angular 17 and 16 in parallel because they mess up with, they have a property in the window object, and then Pyrrole has already resolved this, so this is already fixed. But yeah, we had quite a lot of, or not quite a lot, but we had some problems. It was actually not that simple as we had expected, but this was not, was more a problem how Angular works than Pyrrole.
Right, it's not really designed for micro frontends, as we already learned.
Yeah.
Just have to find a way to make it work. Next question was from Twine. What is the role of NPM packages in micro frontends? Maybe like
I don't get the question 100%.
Yeah.
So of course we use these. If we talk about our micro frontends, we mostly we're just talking about here NPM dependencies which we use and which we would like to share. And then of course what we want to do is that we try to use here the versions from NPM as well to identify which version we want to use. Just in general, I would say the role of NPM packages for us, the main source for dependencies.
Great. And next one from Robson. How do you prevent version conflicts of a dependency using presented methods? How can I use, for example, multiple ArcGIS versions using import maps?
Yeah, I can skip back and show this. So in general, ArcGIS is actually not big of a deal. What you actually need to do here is what, for example, Pyrrole does. It provides its own meta framework in addition to these import maps. So Pyrrole has their system on their own. If you want to just go pure, you of course have to think about a notation in your team which you would like to use. Okay, this is not SystemJS, but it's the same notation. But for example, this example here, it's ArcGIS at 6.x to use the 6 version and ArcGIS 7.x to use the 7.8 version. If we have, for example, it depends which only could be used once, let's say Zone.js or maybe PDF.js, then you should maybe make sure that this is just named once in your import maps, and all micro frontends are only allowed to use this dependency in your via the import map and not bundle this by their own. And of course, this is what Stefan also said in the end. For this, you need maybe some tooling, some custom linting or something like that to enforce this, because otherwise there could be then issues at runtime. And if we are talking here about maybe dynamic micro frontends, which are not always there at the time, it could be also quite hard to test them. So I would definitely go here then also maybe for an build time check if these rules are used correctly.
More and more questions coming in now while we're answering the other ones. I think we still have enough time. For example, this one, how do you manage the upgrade of one of the runtime only dependencies like Angular React across all the micro frontends?
Yeah, so also about it, we talked already. So what we are aiming for is to have a short period where we actually want to use both in parallel. So it should be possible that, for example, use an Angular in version 16 and 17, because in our process it's really hard for teams or even to make a hotfix. This is already quite expensive because you have to provide there's this regulatory process which you need to fulfill. You need to provide documentation and things like that. There's, of course, QA you have to pass, system verification, and so on. So what we are aiming here for is to have them both in parallel, at least a short amount of time, and then until all teams in the end have used then the latest version, and then and all of this should be, of course, dynamic and be in a way to do not have this issue we mentioned at the beginning, that you have one time you have a Micro Frontend which just does not work anymore because it was dependent on the old version. This should, of course, never happen. So because of that, we need these two dependencies in parallel.
Makes sense. Thank you so much. I think one more. Let's go with this one. What is your vision on share scope in Micro Frontends? So module federation, I guess we can manage versions even though it is singleton. I don't know if you heard of that.
Can you repeat the question, please?
What is your vision on share scope in Micro Frontends? As far as I know, with share scope and module federation, I guess we can manage versions even though it is singleton.
I don't get the
maybe,
question.
Maybe, yeah, maybe.
I don't know.
You can elaborate a little bit more. Yeah.
Okay, maybe you can also just chat then afterwards.
Yeah, like just answer in the YouTube section, in the comment section, right? I have one more from Greg, maybe this one. From styling perspective, you mentioned component library. Do you have separate team to manage component libraries in a storybook, or do you use third-party libraries?
Yes, so we have a dedicated team in Zeiss that creates this component library using web components. We also provide a React wrapper, and this is used across Zeiss. And maybe to also answer another question in the chat I saw about prefixing the custom elements with numbers or something else. We also went down this road now for a first solution to have multiple instances of this web component library used at the same time. It helps, but it is not the ultimate solution. So custom scope registries would be much better.
Awesome. I think that's a wrap. Thanks again for presenting your talk and all the insights you shared today. And I think we can now continue with the raffle. Thanks again, Lukas and Stefan.
Thanks for having us.
Thanks.
Bye. All right, guys. Another talk, another raffle. You know how it works. You can see the QR code, scan it, enter the email address you used for registering the conference. What can be won today now? We have another JetBrains writer license. We have Wallaby Chess and another packed ebook, basically coupon voucher. So you can choose any ebook you like from Pact, the online library and learning platform for professional developers. Right. Like 1 more minute. And it's 1:40 here in Germany, so let's start the raffle. And the first prize, the ebook voucher, goes to Katik. Awesome. Thank you also asked the question, so well deserved. And the Champions license goes to Citroën X1. And one more. It's gonna be the Wallaby. Let's spin the wheel. Ah, that was close. Nilesh Shwal, sorry for pronouncing it wrongly. But you got the Wallaby license. Congrats. Awesome. So yeah, we're gonna continue with the next talk in around 20 minutes. Stay tuned. See you. Bye. right, welcome back to the conference. I'm very happy to introduce the next talk of track 1. On his LinkedIn page, it says he's a JavaScript addict and a software architecture maniac. Welcome, Dimitri Shekhovtsov. Welcome on stage. But he's also a Google developer expert, actually, in web technologies and Angular. He contributed significantly to projects such as Angular, TypeScript, NX, RSpec. He's the founder and CEO of Valor Software, where he and his team have authored numerous open source projects, open source libraries. So thanks for all the hard work you've put into these projects. Also the co-founder and CTO of Zephyr Cloud. And today he will talk about modern development strategies and the tooling needed to move at the speed of thought, which is also the title of his talk. Basically when developing micro frontend applications, of course, and he will also show practical solutions for the biggest issues with such applications. So without further ado, I would say, Dimitri, the stage is yours.
Awesome. Thank you for your introduction. It's actually a pleasure to speak at your conference. So I could skip most part of my self-introduction thanks to you, but definitely we're going to speak about moving at the speed of thought when you develop your applications. So everything about me you already heard from our host. So getting to the topic. In terms of the performance and perception of the speed, we are as engineers have a different perceptions of what speed is. Like we cannot agree on what done is, and like we want to discuss what is performance or speed of thought or how to quickly develop things, right? So yes, it may sound as an unrelated question, but before we go into conversation about performance, things to keep in mind while we are going through the slides is why we can commit and push on Friday evening or even on the weekends, but cannot do the same for our deployments, right? So that's something to keep on the background when we are speaking about performance too, because that's in a nutshell will be part of the answer of not only how to move fast with your thoughts and your code to deployment to production whatsoever, but why we can do that. And reason is like performance for this conversation would be how much time it takes your code to hit production. If I do the change on my local machine right now, I do commit, I do push, and how much time gonna be there in between of my push and when it actually gonna land to production. I do believe that answer will be very, very different, depends on how do you work. If you do, I don't know, FTP to PHP server, that's gonna be instant change most likely, right? But if you speak about like modern development, most likely you're using a lot of things in between, like your local quality gate checks, your CI/CD quality checks, code review, human interaction, some time spent on that. Then we're going to have one more production build, one more testing, one more end-to-end, one more deployment. If there are any issues, it goes back. And that time can take somewhere, usually in between, from a day to weeks or even a month, right? Which is kind of not very close to moving fast or delivering your changes or delivering your code are performant, right? So even if you like hit your local builds under a second and like your reduce time spent on CI from hours to minutes or like whatever, it's still going to spend a considerable amount of time to hit the production. So what potentially we can do about that? And I will try to show a very small demo just to give it a small glimpse of how that's potentially may be. And of course, what kind of model federation without character sample. We will go to not so pretty thing, but very, very fast. So for me here, I'm super lazy engineer. I'm just hit build and going to do something. And what it does in the background, it actually deploys this application to version environment. And all of that was done quite around a second. We can try to change this wording, hit again to see how that's going to work. And let's do that in a simpler way, maybe. For now. When you hit development, the good thing about it is it's at least it's not works just on my machine. It's actually available on any of your environments. Okay, I will go to sampler. I will do another way. Let's build quick. Whatever works the same way. Just hit build. Just waited for it being deployed. Okay, all of that's deployed. Let's go here and see that our deployment to this one took around like a second, because we was updating a lot of new assets, and for some reason this tool doesn't like me today. So I'll just skip the part of looking for the text. And well, I was like, okay, let's try another one. And this one just error-spark. Whatsoever, I can build deploy it under a second for all day long now. Yes, finally something I'm working a lot with. So I'm going here, and let's say that we are finally found the sample, which we are going to deploy to productions one and more again. And our moving with the sort of light, moving fast. And all I need to do is to hit the build again. And there are a lot of things interesting here, which is kind of internal, not super important. But even my mistakes I'm going to hit and will be in the history now, because each deployment creates something. The fun part about it is how much time I have to spend on configuration for this part. And the only thing for configuration for these deployments and provision environments is pretty much just a one-liner, right? So this is not in a nutshell how your deployment may look like. You don't do CI, you don't do other things around. What you do is you do build, and that build actually hits production or some version. So the main question is here, is it nuts as it sounds that any of my code changes after the build are deployed? Let's figure it out that together. So in terms of like micro frontends and model configuration in particular, that's kind of an old slide. I suppose there are more websites which are already using it, but there are a huge amount of engineers, huge amount of websites, web applications, whatsoever, already benefiting from model federation. It means that whatever we are discussing here applies not only to a particular solution, but that applies to a lot of people who may potentially use the benefits of moving with a sort of speed. Up here, I mean that your build time and deployment time are similar, and you don't have to wait for days, hours, or weeks in between when you potentially may look on your code change, deliver it to production-like environment. So, and in order to understand why, we can actually skip a huge part of the things which we are kind of get used to work with, which is like 10 years ago wasn't even a thing, but now we are seamlessly want to follow it. We don't want to break it. We want to kind of go through the code, through the build, through the tests, through the CIs, through the code review, then release, then deploy, then make it operate, monitor the changes, and then repeat it again. And all that takes a huge amount of time. And there are such important things, especially for your managers whatsoever, is tied to market, which is kind of sounds great, but for me as engineer, is more important to increment faster, and developer experience in general mean that if you have like 3-4 hour builds or nightly builds, which some people most likely have seen in their lives, that's an awful way to see how your changes actually affect your application. Now we're at the stage of engineering when we are kind of have a super fast builds, we have a lot of tooling around developer experience on your local machine, but still operate in terms when we have to wait for considerable amount of time in order to push it forward. We're gonna skip the planning phase of the cycle, which is kind of start. Nobody can actually do that. So we have a ChatGPT to ask whatever we should do today, and even ask for parts of code. And we will see how currently what developer experience tools are doing for making your coding, or what kind of practices for code build and tests already on the market, and what we can introduce for release deploy, or how we can kind of hack the cycle in order to move with the speed of thought. So at a build stage, that's not an advertisement. I am not affiliate of Nextcloud, but I'm a very, very a fan of this tool, which helps you a lot. There are similar things like Bazel, like Turbo Repo, and some like Rush or some others, which are providing similar functionality. But main idea is here that whenever you do kind of build of particular commit, I would say, it's able to cache those things to the cloud, and whoever else repeat that build or actual test or whatsoever will be able to save a time on not rebuilding the things again, which is kind of good concept based on centralized caching of results. So you're pretty much caching of what you have on input and what you're going to have on output, and being able to reuse that information to speed up your local or CI builds or whatsoever. Obviously, before this, and in parallel to this one, we do understand the larger the code base is, the slower the builds are. So splitting your we are in Micro Frontends conference, so splitting your monolith application into smaller parts, into modular system or federated applications, obviously gonna reduce the amount of code which you have to build at once, but meaning that it's gonna speed up the way how fast it's gonna be built, right? And on top of that, we may introduce tooling like Nix or similar in order to move even faster, to reduce the time from seconds to milliseconds, which are going to help you to improve and move faster. After code and build, obviously, we're going to discuss release and deployment, which are oftentimes used as a one thing, while in a nutshell, especially for library engineers, whatever, we speak about that release is potentially for humans when we are was working on a chunk of functionality of fixes whatsoever, and we have a human readable pretty much description and version and a time and contributor list of who was working on the release, and we are preparing the chunk kind of code and a description for it to being deployed, while deployment is pretty much to make this new version of your application to work on desired environment. That's usually doesn't really make sense to have a difference in between of those, but for our conversation, that's gonna make some sense. After we have our code on deployed, it operates, right? When we are deployed at a particular environment, it starts to operate, meaning that it's running up there, going to live, and then we are able to monitor. And when we monitor, we mean like we can use Sentry, Google Analytics, and any logging whatsoever in order to understand how our application is actually performing on the desired environment. So looking into this, right? That's just another perception on SDLC. What we was not discussing, that in between of code build test, we're gonna repeat that same stuff again on CI, most likely several times for each of your commit, then for each branch, then for each merge, and for different environments where it's going to be deployed. Even if it's deployed and we have some kind of like have to do rollbacks or fixes, whatever, we have to repeat the same parts of this life cycle over and over again, which is completely not a bad thing, especially taking into account that most of the parts are automated. But our conversation is about the performance which you may achieve and getting from your code and build into deploy, not throwing away all of the other parts like continuous integration or deployment, but potentially being able to view your code changes in production environments immediately to make it operate and actually monitor. So this is a super important question of how we can achieve that. We'll try to decompose SDLC into common terms which are familiar to most of us, and that will make easier to get to concept that while we are speaking about deployment, the things, improvement to deployment process, the things which we're using daily and exist there, that's something we should have used for federated applications for a while and for deployment in particular. So for a code, you can see that I'm not very good at cleaning subheaders. For a code itself, for storage and for distribution, I'm using Git or GitHub, which is kind of distributed version, control systems. And the most important part here is to understand how, for example, Git works, and that we have a Git flow, we have commits, which are kind of immutable set of changes, which has a particular version, right? How Git works, how it actually pushes the code to Git server. And what is most important, we don't really care in most cases where that Git server is actually located, because after the clone, we don't really think that if we need to create a branch, how are we going to orchestrate that branch on the Git server, right? So all we do is we actually doing the code changes, then we do a commit, and then pushing those changes to actually server, which now our code changes are served on the particular server. So it's starting to operate. In terms of package manager, is super important for us that people who are from older days remember things like Bower, remembering things like jQuery source code, which was committed to your repository, and some particular people who was fixing jQuery issues in your local copy of a library, which is committed to your branch, and particular results fixes making your kind of stuck into a particular version of the library which you use. And this is really was a quality step moving forward when we moved into more centralized way. When we have an NPM, we have like a name of library and a version. We don't really care where it's hosted, and we just can, through the name resolution, through the package manager, get the proper version and start to work with that, right? Of course, tools like AI, which became our third hand into development, became in particular important. You don't even realize how many people actually using that when things like ChatGPT goes down for half a day and your Twitter just exploded. People aren't able to work anymore. Moving into just highlighting some parts from Git, which I didn't spoke before, is whenever the model of deployment to Git server, which we are not using for deployments of our build application, is uploading only changed files. So if you look how Git works internally, whenever you do a change to your files, you can, of course, take a look on what has been changed. But Git actually doesn't load the difference. So it doesn't use computation later on to understand what has been changed. It actually has a copy of each file which has been changed. And then you're able to compare that across versions, close sibling version or remote branch versions quite easy, because Git is able to reproduce the state of your repository based on files which has been changed. And that's super important for incremental work with Git, because like you don't spend a lot of time, especially when you have huge repositories. You don't upload each time 100 megabytes of code each time you do a Git commit, because it would take a considerable amount of time. But on the other hand, that's what we do for each deployment when it does or doesn't actually makes any sense. In terms of what Git as a process gives to us is being able to check out a particular version, being able to roll back to a particular version very fast, like super fast Git checkout on a local machine for a particular version, or checking out to a master and pushing that. It's seconds or sub-seconds. That's in particular making like a standard for what should mean moving with the speed of SOD. If you speak about like Git, that's a sub-second to do. And because how Git works, most cases you feel safe when you are able to do things like commit and push and all of that daily routine. You don't really scared to Git push to the Git branch if it's not master, which have continuous deployment on the Friday evenings, and knew exactly that everything's going to be fine and nothing going to break, which we don't have with the deployment. For Git flow, this is just a map of things to keep in mind, that while our understanding of the code base itself is not a snapshot, right? It's not linear. It's not like just linear events of time. That's work which is done by a team in parallel. And that's a model how our brain works when we do perceive the code base itself. And we're going to get back to this thing, because that's something our brain is already, how it works already, and what it brings for our understanding as engineers in order to move forward. So if as of package managers like NPM, ESM, or kind of over, just for a joke here, I suppose it discontinued for a while, but we do understand, so no matter how many times we are going to check out a particular version, by name a version of the library, we're going to check it out the same thing. So our expectation for developer experience of engineers, that particular version is immutable, and that the version has a particular structure, and there are logic behind of the 3 or more numbers in Semver, right? We do expect then we are writing our packages and file or using CLI tool to resolve particular name in a version into something, into actual library source code that is going to behave as expected. We cannot say the same about when we do configure our model federation configuration or any other federated model federation implementations for the UI. Whenever we point to some other federated or remote application, that what we're going to get is going to be versioned or going to be same thing each time we pull, which unfortunately not a thing, and put us in danger that our application going to break because somebody has updated the application itself. So pretty much we always look in a particular or several URLs in order to pull whatever latest there without any particular control or safety, obviously, which makes us less self-confident in what we do. In terms of package manager, what is important to discuss is the pretty much settled down process of releasing a new version. There are some tooling around that, and this concept, which is more available to and familiar to people who do developing libraries. That's very funny pain to have to release an NPM library each time, and most of the things are automated, generated, and pretty much the logic behind that is a process which is settled down for a while with some deviations. We know that we are able to have a place to discover, to find libraries, to find those versions, to see how that work. And in particular, we do expect when we open a particular page of a library that there will be at least some kind of level of documentation around the package itself. While we are, if to map this in kind of this approach to federated application, like our current stage of things, we do not expect that application which may federate we'll have releases, we will be able to find the documentation whatsoever, which obviously makes our life slower to find and test and realize what we are working with. So the build phase is one of the parts of life cycle which has the most variable amount of tooling available for us, and all of them are trying to hit the same goal which we are discussing, is to improve the performance of your build. So there are different approaches, for example, like RSpec from Webpack, which is kind of Rust implementation of Webpack interfaces, which obviously works several times faster. And there are Vite, and there are like roll up, roll down. As far as I know, roll down is kind of Rust version, yes build, SVC, and obviously all of the tooling which we are using for build for like decades, struggling to improve the performance of the build in order to reduce the time spent by engineers waiting. So kind of the same goal which we want to achieve here, right? We want to like to reduce the time of waiting in between our code change or build into hitting the production. These tools are doing us great help, and in particular, Nix introduces very good and proven concepts which are used by other tools like Bazel and others, of what we can take away, in particular practical, into implementations which are going to help us to move faster. The bad part about the builders itself that most of them have different interfaces, and even speaking about model federation, we may have a bit of different configuration or plugins. When we move into federated applications, we lose some great things like reload or HMR server, and there are particular specifics of the builders for framework, libs, CLI, and the platforms. Not going to speak too much about testing using same benefits from tooling like Nix, which has a caching based on if your affected artifacts haven't been changed. The results of tests most likely not going to change too. Unfortunately, to keep in mind that all of those tooling mostly, except Bazel, I suppose, are taking effect the graph of your code, which is available on the local machine, pretty much in one repository. So that works, which works great for one repository, not always great for federated applications, unfortunately, but still gives us a lot of time reduction to move. As for end-to-end testing, situation even worse, because when we are deploying something on the later stages to a particular environment to be tested, or just running that on CI in a Docker, which is kind of a great idea to end-to-end something on environment which doesn't actually matches how that's going to work in production, right? And we run our end-to-end test, and we are already not able to trace back whatever changes we had in code into the stage after deployment when it operates on any environment. So we have to run all of that, and obviously in order to improve performance of waiting, we do split into smaller application and to modular architecture, whatever. It helps us to chunk the end-to-ends into smaller parts, being able to run only part of it to wait less. So as you could hear me, I'm like repeating a lot of things that in developer experience for us, it makes us wait less to achieve our goal. And our goal is actually to do a code change and make that code change to be delivered on production. In a nutshell, that's what we are paid for, right? Have to mention a kind of honorable mention for build orchestration tools, which are helping us to achieve those time reductions, not only on local machines, but on CI/CD integration. And particular approaches which are used by those tools are the things which we're going to use for deployments itself, right? In terms of release, things getting a bit funnier because not everybody care about what particular goes into release, especially on smaller applications or smaller teams when they kind of know each other. But for as soon as like larger teams, and we speak about like federation and like Micro Frontends kind of conference, and we do understand that the reason to move to federated applications when your like code base is kind of huge, right? And you want to like split it to smaller chunks to be able to iterate faster. That's one of the reasons, obviously, which potentially mean that there are a lot of parallel work and there are a lot of like people who are working on those code bases, and in particular introducing release to your chunks of like features and fixes to make that human readable to assign the particular version, to know who's responsible for those changes, became super important, because that's how you can understand what has changed in between federated applications. So I was speaking about situation when you don't have yet tools in PM like for your federated applications, which is obviously something not super cool. In terms of deployment, we're not going to go into much particular details, but there are a lot of ways to deploy, obviously, which all of them are similar in some sense. But if to highlight one of the important parts for our conversation, so like rolling deployment is when we are gradually updating our environments, blue-green, when one is available to user and other tests and post kind in production. For canary releases, we have a small increment which is available to a small group, pretty much on production too. For A/B testing, obviously we have one kind of couple of more production environments which then shown to user to have to see reaction and actually use monitoring to understand which version to actually evolve later. And a shadow version when it's more used for kind of performance testing, understanding that how new version behaves. But what most important here in description of all of those deployments, and that I'm not proposing you something which is completely nuts, is in most cases we already have more than one production available at the same time, and that's completely fine. So nothing to shame about that. But unfortunately, in most cases, while we have our kind of fancy Git flow, we have a history, which that was why it was important to bring it back in your memory. Our deployments are still kind of fancy words, which are just an upload of a zip file. Whatever you do, like in a nutshell, you are creating a zip file which is uploaded somewhere. In the best case, like Netlify, Vercel, or Cloudflare, you will have a linear history of deployments, which has nothing in common with the way how we work. So on one hand, you have a Git flow, which is kind of have a branches, have a history, and participants, and all of those things, which are you get used to how your brain works and perceive the history of your work. And on the other hand, you have a deployment history, which is linear, in the best case, if you have any. And under the hood, whenever we do build, we have our artifacts, and we push those artifacts to a particular deployment environment. We lose the history. We lose the connection in between the changes we did and what is actually served and how that's consumed. So, and whatever zip file we uploaded, it starts to operate somewhere on CDN, on workers, on engine servers. The best things, obviously, which I love is like when people do Docker builds of static React applications, deploying them to AWS, EC2 servers, whatever, which obviously makes a lot of sense to have it because that became kind of immutable environments, and you have kind of the history of your Docker registry, if any. Whenever stuff is already operating, is available to users, doesn't really matter if it's end user or just like stage environment, whatever, we're already able to collect information, which is important for us about the performance, about error rates. Potentially, if you use a proper continuous deployment or any other approach, even a manual, being able to correlate those metrics to particular versions which have been released to understand how our release, which is a chunk of changes, actually affected our application. To at least have a connection, if you lost a connection between the deploy artifact to a particular code, we still at least should be able to understand that there was a release, which is kind of human readable connection in between, if any, and to trace back. So, taking into account all of the information we have discussed and SDLC, can we deploy under a second? As you have seen on a live demo, we are definitely able to deploy under a second. And technically speaking, we are not introducing something which is hard or super new, but combined in a bit different combination of things, which allows you to achieve for each build to have a deployment under a second, because let it be Git-like, and kind of, if you speak about deployments, usually like, great, we have to make a clean build with package log on continuous on some CI server in a Docker, to be immutable, to be kind of isolated whatsoever, right? And at the end of that build, we have just files. In particular, we just have it files. And why it's fine to upload just a set of changed files, because that's what Git does for years, and nobody have complained yet that it works. Kind of, it should upload all of everything in my kind of local folder in order to make it work. Now, that's completely fine to have incremental uploads and reconstruct that on a server to reduce engineer time on waiting of uploading those assets. And again, whenever you do a build, you kind of could use npm-like approach, because you still, in most cases, have some kind of version of your application, maybe in packages or maybe some other place, which is where we can create an increment, kind of a chunk. You did a change. Each change in particular may be counted as a release, and that release may have a version, which is completely fine. That's how, for example, TypeScript works. There are a lot of temporary, I would say, builds, and which was deployed on npm. And if you wish, you can consume the latest from kind of someone else, local or CI build, and that doesn't really break the stuff for anybody. In terms of NX-like, what tools to orchestrate our build process could bring to deployment process is centralized cache. So pretty much in order to reduce the amount of data, we can say first, and NX-like or Git-like, the main difference is kind of Git-like is distributed version control, and NX-like is more server-oriented, which is what we do. And that allows us to, for your particular application, to see what kind of artifacts we have already for that application and upload only the new one, which reduces the amount of time spent on waiting. And it means that whenever your build is around maybe 10-15 seconds, then you have a deployment under a second, and you have still every load, even if it's deployed somewhere globally available URL, the way we have seen before in demo. That's kind of an experience where you kind of don't have to change back to local development anymore. You don't have to serve from your local machine on particular setup it, and you can deploy under a second for each build you like. And of course, each time you build, it creates an immutable version. Similar to npm or Git, whenever you do commit, it creates a set of changes which is later on consumed. So can we deploy each build? Why not? So by moving on from current situation, when we have, in best scenario, linear history of deployments, to more Git-like structure, when each commit on each branch, on each commit may have several builds on it while you work. We are moving into structure which we have the same visualization, and we have our change set, and we have our deployments in the same tree-like structure, which is connected to each other. And we are not losing anymore this connection of what change have triggered something else, because after each deployment, we are having our monitoring enabled and being able to understand how that particular small change, right, like a canary deployments, how that affects our environment or our end users. And based on monitoring, of course, because we can touch a lot of things, follow canary release practice, and because all of the versions are available, they never goes anywhere if they are kind of used. You are able to make benefit of automatic rollbacks based on data from monitoring. Because like, what is the difference in between, like, we are using AI to improve our like coding skills, but why we can't use AI and we're already actually using some kind of AI logic in order to watch for metrics, which is important. Because humans, what we are doing, like, we're doing deployment. Why we don't do deployments on Friday evening? Because we have to watch ourselves for those metrics to understand if things goes correct, if there are any support tickets, if there are something goes down, or if there are like performance drop down, right? So nothing from this list cannot be linked as a stream of data into the service responsible for your deployments, which is meaning that we are able to safely and confidently doing Friday YOLO deployments, as some people most likely who watch me love to do. So for all 3 questions, we are having yes, yes, and yes. We are able to deploy under a second. We are able to build and deploy each kind of change you do locally. And yes, in a nutshell, if your project manager doesn't know where you live, you are able to deploy on Friday evening, which is kind of a great thing. But this kind of level is available only when we introduce a tooling on a higher order of registration tooling, right? It's like higher order of components consume other functions, and for higher order of registration tooling actually consumes information and is able to use and work on the practices which are available already to us, but combine them and uses them together in order to achieve the goal which we want to, right? And our goal and the question we like said initially, can we move at the speed of thought? And I suppose it's obvious the answer is yes. There are kind of not so many tools which are available for higher order. We will like mention one, obviously, where I work at. But important things and takeaways for us, that when it was discussing Git branching, you don't really care where the Git is served, where the Git server is. When you do a new branch, you don't really care how this branch is going to be deployed and served on a Git server, because it works automatically. You do expect it to work like that. You don't really care how npm going to serve your package whenever you publish that, right? So why is any kind of different for our web applications? Why we have to configure each environment if like kind of technology actually allows to achieve infrastructuralness? So whenever we like check out a master branch, we do kind of branch, we do the build, and it's automatically is able to create a new URL and serve our code, serve a new version which we did. Why not? Super effective. And because each version which has been deployed is immutable and has a release and has attached monitoring, we have some kind of a confidence around it, right? We know how that version behaves on a target environment. And that target environment could be any, could be consuming production API, who cares? In terms of the speed, because we are able to kind of skip all of the parts of SDLC, right? Like CI/CD, code review, whatever, and deliver features directly to a place where it's available for production. We are not actually like throwing away SDLC and years of expertise, right? We're just doing that in a parallel in the background. Why we should wait for it to get our stuff working? We don't, right? So it doesn't mean we're gonna like throw in the face of end users whatever we just did locally, but we are potentially can do that already and even run our end-to-end or whatsoever on a production-based API for our tooling which was deployed. Taking the best of NPM and Git tooling in terms of practices which are proven to work for years, and is actually something you expect and your tools to behave like, how that should work. And whenever you work with NPM, you do can do like npm-ls particular version to see how it's used. You can understand what kind of like dependency you have and like take a look at the other packages and see how it works. And you know the places where it will be, you know, the tooling, how that's going to work, and you can go around, discover things internally, maybe find some issues whatsoever. But when you work with federated applications, you don't have such experience, which is kind of very, very disappointing, because in a nutshell, when you have an application, it actually has a name, it has a version, and if you are able to deploy that in a way like npm does releases, right, then you're able to consume that application, not by manually enter at URL, because it's not like an abstraction leak when you have your URL provided to your configuration for local builds, and instead of that, use package.json-like approach to delegate resolution of application name and version resolution into a particular version of the remote application which will be consumed, which on the other hand will be immutable, which allows you to be confident that whatever build you did and deployed, you know that it's going to work whenever it takes. So in the background, all of the things which we are discussing, or most of them, are already working on Zephyr Cloud. Obviously, it's an alpha, and there are a lot of things to be done more, but the core concepts which we have discussed and the demo I have shown works and operates based on the principles which we discussed, which I hope will become a new, it's not even about like the product itself, but approaches there which allow us to move with the speed of thought. The way how we change the code, deploy to production, whatever, being able to consume it. Like we get rid of works in my machine, and like we have always uptime, which is kind of great things, and getting our deployments and releases to level of other parts of our life cycle is, right? So what we have for code, for build, for test should be available and should be as a part of our developer experience when we work with deployments, when we work with federation, and things which are not related to performance itself, but most common questions are, it's not platform dependent, so you don't deploy to Zephyr. Think about Zephyr like NPM, which helps you to deploy somewhere, and that somewhere could be your own cloud, like Netlify, AWS, GCP, whatsoever. So the main goal here is to bring an experience which is super familiar and expected for any engineer, right? Because those topics are when just fast is not enough for your management. In terms of builder support, there are a lot of samples. So that's not super complicated, but we are a part of the build, so we are context aware and helping to reduce the amount of time spent on waiting. So you don't have to run additional CLI command to be deployed. You just build, and we help you to get it done. So there are other several things which are getting back, like live reload or automated NPM-like versions to you, which are a part of Zephyr and going to help you to achieve your, I hopefully, expected level of developer experience for your deployments.
Thank you so much, Dimitri. Thanks a lot for this very interesting talk and showing us how to move at the speed of thought. Unfortunately, we're running a little bit out of time here for questions. Well, and there's one coming in right now. Now they're coming in. It seems like maybe this one, I just saw it here. I just put it on the screen. Is it possible in a monorepo to identify the changed packages to run the CI/CD for based on the imports of the changed files rather than via package JSON dependencies? As far as I know, NX runs as per package JSON dependencies.
Yes, kind of, I suppose. Question, I'm not sure about Zephyr itself or NX, but for NX actually works in monorepos and able to understand, especially if your imports through like tsconfig path is able to understand that. If we speak about Zephyr and federated applications, obviously you have a different, another level, a higher order level of graph of connections from federated applications, which you should be able, obviously, to run and build.
Perfect. Unfortunately, we have to end here. But if any more questions come up, maybe you could just take a look at the comment section and reply
Sure.
there. That would be great. Perfect. Thanks again, Dimitri, and
Thank you so
enjoy
much
the rest
for
of the
hosting me.
conference. Bye-bye.
Bye.
All right. I think we're just gonna continue with the raffle now. So we have 1 minute remaining. The price for this raffle would be another JetBrains writer license. We have a Console Ninja license as well for this raffle, and another voucher for an ebook for the packed online library and learning platform. So just scan the QR code with your phone and enter the same email address you used for the registration of this conference. Has anyone already scanned the code? Because I cannot see any participants right now. We need to refresh the page. Okay. Yeah, I think we're just trying to refresh the page now. By the way, after this talk, there's going to be a coffee chat with Michael, Luca, Catherine, and Florian. It's going to be in like 8 minutes from now. So if you're interested in that, you can just stay on track 1. So let's see if we get the raffle on the screen this time. No, it looks better. I think it's coming up now. Perfect. Here's the audience. I was a little bit skeptical that no one wanted to win something. All right, let's just press the start button, I guess. All right, and that's the ebook voucher for Pucham. Congrats. Next prize should be the writer license. Let's go. And we have a winner there as well. Nichiran. Congrats. And for the Console Ninja, let's spin the wheel again. And the Console Ninja license goes to Shilpi. Congrats to all of you. We will contact you in the coming days. And as I said, now it's only 5 minutes remaining. There are going to be a coffee chat here on track 1 with Michael, Michael, Luca, Catherine, and Florian. So just stay in the stream. Stay tuned for that. Bye. See you.
Hello everybody, my name is Florian Weininger and I'm a solution architect for the company Smarpiot. We are the creators and the driving force behind the front-end framework Pyral and the Pyral Cloud ecosystem. Today we have Kevin Kasper from Consolino Energy as our guest. Can you tell us something about you and your product?
As a green tech company, we at Consolino Energy aim to drive forward the energy transition and are pioneers when it comes to optimizing energy systems through the use of intelligent technology. We work enthusiastically to use the available energy sensibly and efficiently through digitization and intelligent energy management. True to the motto, climate protection is our drive. Technology is our contribution. We offer an energy management platform that can be used with our own IoT devices, as well as others.
Why did you select the Micro Frontend architecture pattern for your solution?
We have opted for a Micro Frontend architecture as we want to offer many different applications in the field of energy management on our platform, which the customer can book separately but use together. By strictly separating the domains, we can work in parallel in feature teams.
And what made you choose Pyral?
3 years ago, a Micro Frontend architecture was to be used in a project, as various partners wanted to implement features independently of each other. Our first look was in the direction of Webpack Module Federation. After Smarpiot was brought on board as consultants, Florian Rappel promptly presented Pyral to us. We were immediately impressed by the idea and implementation. We particularly liked the integration of all JavaScript libraries and frameworks. Since then, we have also been using Pyral internally.
What challenges of your front-end architecture have been addressed by using a Micro Frontend discovery service?
Customers can book features on the platform. One requirement was that the client should only receive the code for the booked features. This can be easily realized by using the Pyral feed service. The delivery of the Micro Frontends can be provided with rules. An authentication and authorization rule made it possible to implement this requirement.
How does the Pyral feed service fit into your architecture?
As we had already worked with GitLab CI, CD pipelines and Kubernetes in advance, integrating the Pyral feed service in the form of a Helm chart was a manageable effort. The service could be seamlessly embedded into our existing infrastructure.
What key functions of the Pyral feed service are you using in your solution?
We use the Micro Frontend discovery service and the rule management of the Pyral feed service.
Which feature of the Pyral feed service do you like the most?
This decision is not easy for us, as we benefit significantly from both of the aforementioned features. However, if I had to make a decision, I would choose the rule management feature, as there is a wide range of rules here and you can also create your own rules.
Start from the lunch break. Yeah. We're back.
Yeah.
Hi everyone. We're just enjoying our coffee here, and there are still some questions left open from the lunch break. So we only have 20 minutes. Let's just dive right into it. First question that I see was asked by Juan. Based on your experience, what is the best choice for handling shell routing and composition challenges? Is vendor login on the shell a good practice? Catherine, you already laughed, and your talk was specifically about that in an Angular context.
Yeah.
What is your opinion, and how would you answer
Yeah.
that?
For sure, it depends.
There's your answer.
Need a jingle, we can
and
say.
it can be you just need a lightweight shell, which is really just the bare minimum. But it can be you need some base, some core functionality. And some people call it belonging to the shell. Other people say it's not part of the shell. It's some foundation component, whatever. But for convenience sakes, it might make sense if you have a good UI library, a corporate design, which brings a header, which brings a sidebar navigation, which brings a footer or something, that you might use your shell also in Angular if the UI library is made from there, which makes it also easier to orchestrate, for example, routing. Doing routing by hand is a very complicated topic to get this history manipulation set up, to keep track of the state manipulation of these changes. What happens if I go on browser back and so on? So I wouldn't want to do this vanilla if I don't have to. But it depends on your application. Do you need excessive routing? Do you need heavy deep linking? Or do you have a central screen and maybe some sub areas you reach via a top level link and then all happens there? So this is bringing you to the choice if you rather use something stable, some framework or Angular itself or React itself for the outer parts, or if you can do it lightweight. Also, how much context do you have? The exact opposite would be a CMS, maybe, which is with no login state. So just a canvas, just something holding your content. Then for sure, you could go much easier with a vanilla shell than with something stateful.
All right. Anything to add?
No.
No. Let's move on then. Next one from Miguela. Hybrid micro frontends, login registration flow, vertical, horizontal, yay or nay?
For me, is yes. You can have vertical and horizontal split in the same application, mainly because it depends on your domains, right? So you might end up to have sometimes, for some projects, it's the homepage that requires to have a sort of dashboard or a composition of different domains. And sometimes it's maybe the my account part that you want to cover, like the payment, the user detail, and subscription. The vast majority of the time, those are well-defined and independent domains, but you want to aggregate them into the view. And therefore, it makes sense to have an horizontal split in that side. But for the rest of the application, maybe you can use a vertical split. And it's absolutely acceptable, in my opinion. There isn't, let's say, any wrong answer over there. The only challenge that I can tell you when you are dealing with multiple domains in the same view is that it's very likely that you want to use a backend for frontend for your APIs, because it's likely that those APIs are used for other domains, and the composition is just one of the many. And in order to reduce the chattiness of the frontend with backend, it's not a bad idea if you create either an orchestration API that takes care of retrieving the data for the client instead of doing multiple calls, or you create a backend for frontend.
Yeah, and I would add for horizontal split, ideally you just have widget micro frontends, so no routing, which reduces the complexity a lot.
Indeed. It's not really part of the question, but hybrid micro frontends, what we notice in our teams as well is that also the integration techniques and the rendering mode may differ from team to team. When we think about an e-commerce example, server-side rendering, first load performance is extremely crucial on landing pages, on product detail pages, on product list and home pages, but it's very uncrucial in the checkout process. In the checkout process, there's simplicity or fault tolerance is much more important. So we often see a pattern where the first domains pick
server-side or universal rendering approach, and the more back-end or maybe behind the login domains. So my account, for example, they just do client-side render and skip the complexity with also deploying server-side rendering stuff. You remain with the challenge at the integration point. Things have to, if the mini card, maybe it must be server-side rendered, or maybe you can get away with the mini card being the one exception that is always client-side rendered. But you have to talk about and think about these integration points where these teams with different strategies meet. But I guess it's perfectly acceptable to, when you can minimize complexity, to do a non-uniform approach.
Right, and I would want to add that these are all correct answers and very general. In the specific example of login registration, you anyway quite often have the possibility to have it in a dedicated team already, because very often you're using flows which are then, let's say, tuned for single sign-on, for instance, and there you wouldn't bring this login flow directly on your site. You would then redirect somewhere else. So this is then anyway deployed independently, and maybe even not in your own infrastructure, right? You're using maybe Incognito or something, AWS or Azure B2C or Entra ID, how it's now called. So Auth0, there are many cases there. And of course, someone then just designs, or I don't know, puts in the logo or something for the login space. But then this login registration flow is somewhere else already. And all you care about is how do you now get the user information. And therefore, this is in some sense a special scenario anyway, which is very nice to just put somewhere else in the hands of someone or a dedicated team. Then from Jay-Z, nowadays I have a feeling in new projects that domain-driven design is always a good idea throughout the team's code and throughout these teams if they're not Micro Frontend ready. Would you commit on that? Maybe a quick thumbs up or thumbs down in the middle.
You have to
depends.
Yeah, that is the sign for it depends.
Yeah, okay, I can live with that. Let's do it like this.
No, it's like that.
Okay, great.
To be honest, I believe that domain-driven design helps a lot, but the problem is it's not easy to master it. And I have seen a lot of, so you can use the initial, let's say, part of domain-driven design to define an ubiquitous language between the team, identifying the boundaries using event storming, for instance. You can arrive to have the definition or categorization of a specific subdomain into generic supporting and core domain and assign characteristics to the stuff. But on the front end, let's say, arriving further down into aggregates and the read models, etc., I think it's a bit too far, and it will require a bit of abstraction in order to arrive there, because in reality you're not dealing with, let's say, schema design and models and stuff like that. So I would say that in reality, what you need is identifying your domains, definitely, and usually one thing that I recommend is spending a bit of time, because you might be surprised on the outcome of this kind of workshops. So if you use event storming, that is a technique that you can find online, was created by an Italian guy called Alberto Brandolini. That was designed for understanding the business. So you take a step back, you don't talk about technology, you look into the process and the flow. And then from there, you start to look into, you map everything, you create a timeline of how you accomplish a specific task for a user. It could be the subscription, it could be how navigate a catalog, stuff like that. And then based on that, and you start to look into when there is a change of vocabulary on side the events that are happening. And then usually you are in a good shape for saying, okay, so probably here there is a bounded context. And then you start from that, taking out the bounded context, start to test it. And still in the design phase, you look into the events that are coming in, the events that are going out, how much chattiness there is between different domains. And then from there, you can start to understand that part. And this technique I use a lot. Not only for Micro Frontends, also a lot for microservices, and I'm helping customers to do that. And I truly believe that is extremely important. But in a let's say short, let's say in a short way, you can also use looking into the way how your users are using your application, because very often we think that we know how our users are using. But trust me, you can be surprised when you start to look into the click streams and Google Analytics and whatever other tool you're using, because the reality is that our perception of how the platform is used is not how our customers are doing often. And therefore, starting from that, and you start to see maybe that the user lands, when he's authenticated, lands always in the same place and use always the same tools. It will enable you also to say, oh, probably if I slice here the my front end, I can guarantee that all the authenticated users will have a fantastic experience because they never reload. Stuff like that really help. DDD is definitely amazing, but I cannot be let's say the only way to identify boundaries, because otherwise, let's say the effort or the cognitive load for starting my front end will be too high. That's my 50 cents.
Yeah, that's why we usually just abbreviate it with "it depends."
Yes, but that
because
is the long
there you see there are some conditions, and you need to carefully evaluate all of them to reach a good conclusion. Now, speaking of good conclusions, the next question that I have here came from Rady Murai. Currently, we are using the awesome Pyro framework, a little bit added for me for Micro Frontends, but forget about this technical aspect. We are developing a pilot, so that's a Micro Frontend, for a given domain logic where the pilot interacts with different microservices. I think that's the crucial part here, because now, what do you think of this approach? So one Micro Frontend talking to multiple microservices. This will be another episode in the "it depends" section.
I would be more absolute. I would say is inevitable, because the reality is, if you think about that, when you design any system on the back end, for better or worse, you have authentication on your way. You have, let's say, east-west communication between services. Maybe they're using HMAC, so therefore they talk with another server. Maybe you need, I don't know, translation. Maybe you need like these cross-cutting services that you have to understand, despite are not related to your domain. And sometimes, you have like the request for a feature that has a lot of data in another domain. Therefore, you want to replicate on your side, but you need to take into account the cost of replicating the data, the eventual consistency of the data. So there are a lot of things that you need to take into account. So I believe that at some point, you will end up that you need to handle that situation. And if it becomes too chatty, backend for frontend is your best friend.
I think that the question is not if your system can talk to a microservice. The question is, what microservice does it talk to? So if you have three teams with different domains, and they talk to each other through microservice or have shared code in there, then this may be a smell, and you maybe have to investigate. If they all talk to the authentication database or put something into tracking, whatever, then this is perfectly fine.
Exactly.
Yeah. But to simplify the rollout and the configuration, I would also vote for backend for frontend approach, and just let the backend for frontend talk to the different APIs.
Sometimes.
Depends on what we're talking about.
It always depends. But there are some nice benefits you would get from Gateway or BFF. So, for instance, also you wouldn't need a token anymore, right? So you could solve that, for instance, with a session cookie, which then solves another area where a natural question often comes up with Micro Frontends. How do I distribute the token, right? So because either you would need to, hijack fetch and say, then we always, if it goes to the right domain, we place the token in there, or you have some event beforehand on the client, give me a tokens from somewhere. So all things a little bit shaky, and so it's just implied, right? The cookie is just from the browser inserted, and you're happy. And but again, this is just one of the things where I say, then if you have a BFF or a gateway, it's great, because another thing that you can put on top of it, but doesn't mean it's the only way. And there are certainly pros and cons. All right, so another great one from the tech trends with VIA. Nice to have you. It's awesome. Is it advisable to separate the header and footer into distinct microfrontends to avoid redeploying them across multiple applications? Or would this approach negatively affect performance? So in other words, we are now using microfrontends for, runtime components that we want to reuse. Good use case or not? Again, I think we could say it depends already, but maybe on what does it depend?
It depends on what data is in there, I guess. So if we have an e-commerce header with the product catalog, flyout navigation, lots of complex stuff, auto-suggest in there, this may be a good idea that there's a team behind this header that works on this header, implements new feature, tests out stuff. If it's this dumb header of a back office application, it's just a collection of links that change every few weeks, months, whatever, then it can be a component in the component library, or fixed part, as you said before, of your application.
Yeah, I would collect it that you don't have this footer and header separate, but maybe some layout frame as a core component, and then have one instance of this. Because I've also seen projects where we had a library version of this header, and then on multiple screens connected via hyperlinks, we had different versions of the header, and then some link was missing or so. I wouldn't recommend this. And if it has to be dynamic, there's also the option to make this header or the sidebar navigation configurable, that every Micro Frontend can contribute some entry points, and it's a composition of this configuration provided by different MFEs. But the UI component, I would make central singleton.
Mm-hmm. You want to see the question regarding
Yeah.
the fake? Okay, then we got maybe already best, most relevant question from Robson here. Is Michael still hiding behind the first piece of cake from the first, I think what is meant is the lunch break?
Yeah.
Who will answer this question?
Not me.
I mean, you need to. I have my opinion here, and that is not, it depends.
No, the fact is, I ate the first one, and now I'm on the second one.
Yeah. There's no jigsaw on it, so.
Yes. Yeah, the first one was MIC, and now I'm at FER for front end, I guess. No, FER.
Yeah.
Conference.
Conference. Yeah.
So yeah, we have printing on there. I guess it's. I should have shown the first one to get proof.
Yeah.
You have to believe me.
Alrighty. So maybe one final question, because we are almost at the end. This is a remark. Maybe let's see. Yeah, okay. This is, I think, a question. There's a question mark. But how do we effectively manage common component across Micro Frontend?
Yeah, have a core application. It doesn't need to be the shell itself. It can be some core Micro Frontend, but please take care to not have multiple instances of the header and have some common shared layout.
All right, well, this was a quick one. So then let's see, there's someone else, Robson, very awesome. I think this is just another remark, but let's maybe bring it in the stream from Reddy regarding the question before. And our teams are not separated for different domains. Okay, yeah, I mean, you can do that. There can also be technical reasons for doing Micro Frontends, but of course, it makes most sense if you can put them in different domains, right? Each team can contribute to different microservices and different Micro Frontends. Okay. The context would be here more interesting, I guess. With your replies, there's something to improve here. Yeah.
It depends, no?
I guess my favorite.
I don't want to rule it out, right? So there might be
Yeah.
good reasons for doing it.
Yeah.
At first glance, I would say there is really room for improvement, but then again, I'm missing a lot of the context here, I feel. But
Sorry, Michael, you were
Yeah,
saying.
I guess ownership is something I find from experience is really crucial. So every piece of software needs someone who feels that it's their own, even as a person or as a team, so that this does not. So someone takes care of this piece of software and develops it and takes care of maintaining dependencies and whatever. And maybe you have something in your setup where ownership and enough responsibility is taken by the group. This is not ruled out, but
yeah.
I mean, I can tell you, I mean, they're using Pyro. So one thing that I can think of, which would make it, let's say, feasible, is that they might have a monorepo or similar setup, and where they say for them it's important that at runtime it gets composed per user, right? So that you have all these fragments that can come in or not, depending on the user. So it's not about now for the teams to really scale up for Micro Frontends, but it's really the technical reason you want to be able to compose dynamically at runtime and have this all figured out by the framework. So this is at the moment I take that, and I see there's a valid point. And also, of course, that's why they can contribute to everything, because after all, it's just like this monorepo where they say, I just contribute to this one thing or the other thing. And at the end, that these are different things. It's just because for the one user this might be active, for the other this, and for a third one maybe both modules. So yeah,
for multi-tenancy, I've seen quite a lot of small teams embracing Micro Frontends, because usually they say 80% of my B2B application is identical. But there are the 20% that I want to customize per customers, and therefore they can say they can divide. Usually they split in a vertical fashion, so they have like a page or group of pages that represent like the onboarding experience with login and sign up, etc. Then they have like the settings part that are common, but then they have like the internal part. Like I've seen already twice with companies that are dealing with the digital till that you have at the restaurant, where you can select the table or whatever. So the part of how you design the tables is custom, and maybe they have different functionalities. So in that case, I've seen that they build potentially multiple Micro Frontends in that part, but the rest remains independent. That is a very nice way, despite you are a small team, to leverage the independence of Micro Frontends.
All right. A couple of months ago, I saw a talk from a lead tech from ING, so the Dutch financial institution, bank, whatever. They have a mobile app that runs in all over Europe, I guess. And the thing he described was very Micro Frontend-like in the technical composition part. So you have features that are small fragments, more of widgets that compose to complete pages. And they said that they try to remove the concept of pages and just thought about features. But they had a very interesting approach from my perspective, that the ownership part, they scrapped that and said, okay, we have a team, and the next team who's free can pick off the list, pick one of the new features, and then build a feature, have this widget contributed to the complete code base, monorepo, for example, and then deploy it. And they have in all of these countries people that configure their local app, the German app, the Spanish app, whatever, from these components. And they divide the feature development with delivering the actual stuff. And they said for them that was a really efficient process. And it has a lot of in common with what we are talking about, but it's not the same.
Okay.
All right. I think we also have a raffle here. So let's do the raffle. Can make this. We have a tech guy. Raffle. Do you want to participate in the raffle? Take your chances.
Can.
I think you didn't register for the conference. Right?
No, I tried in the train yesterday, but the Wi-Fi was really bad.
If you didn't register for the conference, the link won't work.
Okay.
I mean, you come to a page, but if you have no email address.
I'm not quite sure how far my registration went, so maybe it's enough.
Are you registering?
All right, so the wheel is already growing and growing, and now we also have a
YouTube name.
me in there.
You will win for sure.
But I will, if I win, I give it for charity.
I was not found in the database.
Yeah, I thought so. Next year, right?
Next year.
Register.
Do you have a disclaimer that employees or affiliate relatives cannot
No,
apply?
But we can add it.
Everything goes.
We eat the cake, right? So we get the cake, we eat the cake. Yes. All right. I would say let's spin the wheel.
Well, it tries to test YouTube's product, right?
Yeah, everything says it's like the acid test. Okay, now.
Is this still a thing?
I mean, you're talking about the rendering test, or you're talking about the original ACID test?
No, I'm talking about the HTML5
right?
rendering test. I didn't know that before.
Yeah, that was Stuart Brand was one of the first tests there. They make this series of like a conference, like they called the ACID test, but it was very close to when they did the official LSD tests. Spin the wheel, please, and we got JC winning TechFriends license. Congratulations. it will be. Oh, Lucky Lucky again. We saw him also winning at the lunch break.
Nice.
JetBrains. So you now have 2 JetBrains licenses. This is a repeat or something. Am I looking at the right game here? All right. So last winner for the coffee break raffle will be. Who will it be? You don't know? You don't see it there? You want to see it? Let's make it like this. And it will be... Adnan wins a packed print book.
Good.
Wow, great. I think we only had 2 print books this time, so one of the 2 winners is you. Congratulations. And then see you all in 5 minutes, the next sessions.
See ya.
Bye-bye.
Hello and good afternoon from Munich. My name is Oliver, and I will introduce the next guest for our conference, which is Jennifer Waldella. She works at Bitovi, and hello, Jennifer. Okay, so Jennifer is known for managing and leading tech teams at Bitova, and also has a long time experience with JavaScript and development and Micro Frontends. She's also the founder of the nonprofit organization Kansas City Women in Technology, which sounds awesome. And yeah, I guess we will have a very interesting talk now. If you take a look at the chapter of the next talk, it sounds like a little bit that we are now entering the dark side of micro frontends. Okay, Jennifer, the stage is yours.
Awesome. Thanks so much for having me. Can you hear me okay?
Okay.
Yes. All right, here we go. Well, good morning, good afternoon, good evening, depending on where you are in the world. It's the morning for me, but I think I have like the light blocked off my face. Otherwise, you're just going to see the sun slowly creep up on my eyes. But I'm excited to be here with you all, regardless of where you are in the world. So yes, we are entering the dark side of micro frontends. I've given this talk for a while now. It's called The Problems Micro Frontends Won't Solve That No One Wants to Talk About. So a little context, my name is Jennifer Waldella. Like mentioned, I work at Bitovi, which is a software consultancy. I'm the VP of front-end engineering there. And I see a lot of our clients looking to micro frontends, looking to adopt them. And a lot of times I'm helping them deal with the fallout or some of the things they experience walking into it. And so when I hear a new client telling me they think they need to implement micro frontends, this is often what my reaction looks like. One of the great and terrible things about the tech industry is we have conferences like these and we talk about these new things and we get really, really excited. And there's a lot of fun stuff going on, especially in front-end development, that you might hear about at a conference and then you run home to implement, the next week without really thinking about if this technical solution is a good fit for your organization. I've had numerous clients have some, lead architect or somebody attend some sort of a conference, hear about micro frontends, think they are the most amazing concept in the world that's going to solve absolutely all of their problems. They go down this pathway, they start implementing micro frontends, start to run into some pretty serious consequences from those choices. And so that's the basis of this talk today is what I've seen, what the reality can often look like for teams, and things that you need to be aware of if you are considering adopting micro frontends. Because again, you might, run home from this conference and say, hey, there's this whole conference lineup of people talking about micro frontends and how amazing everyone's doing them. They're going to solve all of our problems. And I'm here to tell you, no, they are not. This is not going to be a bashing on micro frontends talk. This is simply going to be a look at what the reality of implementing micro frontends looks like and things you need to be aware of before making this decision for your organization. Maybe you're already down the micro frontend pathway and you're looking for a little bit of solidarity or therapy, that you're not the only one experiencing these issues, which I hope you'll get from this talk as well. But we describe micro frontends as an architectural style where independently deliverable applications are composed into a greater whole. I'm pulling a lot of concepts today from the speakers that you've heard from in this lineup, the actual geniuses in micro frontend architecture and implementation. But what I want to talk about some of those concepts and the way they impact what I see in software delivery teams a lot. So there's some core ideas behind micro frontends, and these are solid. The idea of being able to be technology agnostic, isolating team code, establishing team prefixes, favoring native browser features over custom APIs, and ultimately building a resilient site. And these are all great core ideas. However, these are core ideas that, favor people who have been building JavaScript applications for the last decade. If you're like me, where you've been a front-end developer since the jQuery days, like this is our domain, this is our play space. We have been building single-page applications. We've been writing JavaScript for the web for a very long time, and we know the problems that we've run into, and we've started to solve a lot of those problems. And so the idea of micro frontends built on these core ideas is great for those experienced JavaScript developers who are used to shipping for the web. The reality is the teams that I see shipping software are not necessarily front-end developers who've been doing this for a decade. I work with a lot of clients that, have a back-end team and maybe one front-end developer with experience, and you throw them into an architecture with micro front-ends. And these are people who are, not experienced with web performance or have any idea what native browser features are, trying to build micro front-ends, and teams can start to run into roadblocks really quickly. We've also evolved a lot as a JavaScript ecosystem. We are favoring frameworks now. We have React, we have Angular, we have Vue, we have Svelte. We have all these different frameworks that have abstracted around these core concepts and built a lot of functionality for us that we very rarely interact with native browser APIs anymore. We interact with abstractions. And so we have an entire generation of front-end developers who never have written vanilla JavaScript. They have never actually bound a click event to the DOM outside of the way they would do it through Angular or React. And so we're setting up a lot of these software engineers to have expectations of something they've never dealt with before because they grew up in the framework years. So it can become very difficult and very restrictive to have a team of even, more seasoned front-end engineers that's only ever dealt in frameworks try and implement and then solve some of the problems that arise when we start adopting micro frontends. But again, this is not a bashing micro frontends talk. Like, I do think there are really great viable problems that micro frontends can solve. The number one I see is incremental upgrades. I come from the Angular world, and so I don't know how familiar you are with Angular, but if you have an Angular JS application, which is, by the way, no longer supported by Google, you basically have to do a full application rewrite to move into modern Angular. There are some small things that you can do along the way, some upgrade processes that make it easier, but most of the time, this is going to be a full application rewrite. And so one of the really powerful things we can do with micro frontends is do incremental upgrades through using the strangler pattern. We can basically partition off pieces of our application, rewrite it as we go into micro frontends. And so instead of, going to our business team, going to our product owners and saying, hey, we need 6 months to 2 years where we're not going to ship any new features, we're just going to rewrite our application. You can do it in smaller pieces, and a lot of times that's a more palatable sell to a business team. So incremental upgrades are a great use case for micro frontends. The idea of being able to ship pieces of an application independently. Maybe you already have a lot of autonomous teams. They get a lot of really great user feedback. They really understand what they're building. They're able to ship features faster if they're dealing in a micro front-end architecture where they can focus on just what they've done, deploy those small sections, and this enables teams to have smaller, more incremental development. That is a really, really great use case for the organizations that are already set up to do this effectively. This also allows us to have more product-focused teams. I love the idea of product-focused teams that can more narrowly have their focus on pieces of the application. I talk about, the difficulties of software engineering a lot, and it's not just writing the code, but it's understanding the product that we're building and then being able to write good code for that. And sometimes we're dealing with very advanced business scenarios. My big example here is I'm from the US. Our insurance system is a nightmare. Not only do we have to pay a lot of money for our health insurance and still might end up bankrupt from a hospital visit, but registering for insurance is an absolute nightmare. There's so many different rules and regulations that change from state to state, different options that are available depending on different things that your company may offer that you can pick from. It's very robust, complex business logic that you need to understand. And so the great thing with more product-focused teams is they can take more narrow pieces of an entire application and really get a deep understanding of a small area they're working on, get feedback from a user just regarding that, and really be able to write code and create the best experience possible featured around a specific part of that product. So I love the idea that we can narrow our focus and really, own the domain of whatever piece of our application that we're dealing with. And micro frontends do enable us to do that successfully. Micro frontends also, in theory, allow for autonomous teams. JavaScript developers, we are picky and we are notoriously fickle. We want to write in whatever our framework flavor of choice is. So micro frontends would support the ability for various teams to write part of the application in Angular, part of the application in Vue, part of the application in React. And I think this does sound very, very appealing from a hiring aspect. Maybe you have a more seasoned Angular team, but you're hiring some people and they either have more Vue or React experience, and they could get up and running more quickly building this new part of your application in a different framework. There is a little bit of appeal there. We'll talk about the downsides of that later on, but this is something that micro frontend architecture does open the door for us to use. And there are a lot of companies using micro frontends and a lot of companies using micro frontends successfully. So I want to make that clear. Again, this is not a bashing micro frontends talk. This is simply a, you hear about the glamour and, oh, how amazing they are. This is the reality of what things could look like when you start to go down the implementation route for micro frontends. We've got a lot of different micro frontend approaches. Micro frontends are not technically a new concept. We just have a fancy name for it now, but we've been doing micro frontends since iframes were invented. And sometimes iframes are still the most viable solution depending on your company needs. We can do server-side compilation where we are, maybe having some sort of Java backend where we're loading up different pieces of our JavaScript based on routes there. We've got stitching frameworks like SingleSpa, which I'm a huge advocate of if you're just learning and getting started about micro frontends. We've got Module Federation and Webpack. Vercella's looking to multi-zones. And then we can use straight up web components for micro frontend architecture. I've got an example library here that's become really popular called React to Web Component, where people are starting to use this to be able to take pieces of the React application and then use it in a micro frontend architecture by converting them to web components. And then a little old school, but Angular Elements tried to do this many, many years ago. Didn't quite pick up the speed that we thought, but it is there and it is an option for being able to pull out components of your Angular architecture and use them other places. So if you're still like, hey, Jennifer, I don't care what you said. I'm like all hyped up on this conference. Micro frontends sound awesome. I'm just going to tune out the rest of your talk. Whatever, let's go. I would caution you and say, all right, hang on, you little Frankensteins. Because again, I want to share with you some of the realities that teams start to experience when going down the micro frontend architecture pathway. They can start to run into some really serious issues and organizational problems when they think they can just start to piece together pieces of a front end and get away with one cohesive whole product at the end of the day. So I want to walk you through a couple scenarios that I have seen happen on clients and may or may not have had successful resolutions to them. You've probably heard this a lot, but micro frontends are very, very dynamic. There's not necessarily a one size fits all for different organizations. And so I don't have an answer to a lot of these that doesn't start with, well, it depends on your company and your organization. So let's say we have a new team. They're working on a new feature inside of a micro frontend. This is a brand new team. They don't have a whole lot of context into the code base, but because we have micro frontends, they can basically start building their own thing from scratch and not have to worry about it. Well, what's actually probably going to happen is that team inadvertently replicates code. They know they need to make a request for login information. They need to make a couple different requests for, different data sets. But those calls are already being made for similar data throughout other micro frontends. So they're all excited. They go ahead and they ship their application, but all of a sudden the whole application performance tanks. Okay. Because we've added more code, we've added more API calls, and it can be really hard to figure out what's going on, where that performance issue is coming from when you've got this new piece coming into play. And then who's to say the new features that this team is working on are less important than some of the already existing features? How do you prioritize who should be responsible for curing those performance issues? It's going to depend on your organization. It's going to depend on your business. It's going to depend on, how you all want to structure and handle these things. The point here is this is something that very likely may happen to you that you need to be thinking about. And hopefully before it happens and before all of a sudden your users are very, very upset after a release because the application has become unusable and nobody's quite sure why. All right, scenario number 2. We've got a critical bug that gets logged in over the weekend. Maybe there's an offshore QA team. They're running a whole bunch of manual tests every so often, and there's this really critical show-stopping bug. But as far as the QA team is concerned, they're just dealing with one entire application. They have no concept of micro frontends. They just know this bug happened. and they report it. But who gets that bug? What does that reporting funnel look like? Like if that bug gets logged, how is it going to get to the right team? Are they going to be able to determine which team or which part of the code that bug came from? These are really real issues that you're going to run into with kind of sourcing where issues are coming from, and then making sure that you have the communication and infrastructure in place for when those bugs get logged, they can get funneled to the right place. I will say I was helping a larger company with they were doing a massive upgrade. So it did make sense for Micro Frontends, but they lacked a lot of organization and architectural overhead. And so what happened was we would get a bug in, there was no way to direct it to the right team, and it kind of just went and got forgotten about. And then we went through another release, and these bugs kept popping up. And then we got into some real serious issues because we had a backlog of over 20 bugs that were just kind of sitting there. Nobody really knew what to do or what to handle with them, but they started causing really critical application performance. And then it became a nights and weekends, all hands on deck situation to try and figure out what's going on, simply because it wasn't thought out ahead of time of what to do and how to direct these bugs appropriately when they got logged. All right, scenario number 3. This is a case where, we've got autonomous teams working. They are focused on an area of their products. They're getting really great user feedback. But what happens is the UX team dreams up a brilliant new design. Maybe it's, something new on a date time picker. And they're like, oh, this is really going to revolutionize how we do things. The dev team's really excited about it. They're all bought into this design. So they go ahead and they implement it in their micro front end. But now their micro front end has a different look and feel from the rest of the application, and it's very jarring. So they might have this really great idea and they write this special component for it, but it's going to look different from the rest of the whole cohesive application. So how should they handle that? Do they throw their new design out the window? Do they figure out how to orchestrate that design and have everybody else adopt it across their micro front ends? Again, this is going to depend on you and your organization and how to implement things. Scenario number 4, we've got another micro front-end team. It's a fairly isolated team working on a very complex part of the application. They get a massive change request that comes in. And so they have to basically throw all their sprint work out the window because this is a very urgent change request that needs to happen. So they work really hard on that, and that's the only thing they're focused on, and they go ahead and they get that shipped. Everything's fine. Their unit tests are passing, but in their franticness, they shipped a breaking change for another app that had a dependency on them. Who takes control of this situation? Who is in charge here? I'm going to talk later about how you can start to solve these issues. But again, I want to highlight these at the beginning so you're thinking about the kind of problems you may run into ahead of time if you haven't already implemented micro front ends, and be able to be ahead of the curve here and say, okay, well, if our apps are going to have dependencies on each other, what are we going to do about that? What happens if they break? How are we going to handle that? Whose team is going to take responsibility for that? Or if something absolutely has to break because we need to change something, how are we going to handle that across different micro front ends with different isolated dev teams working on them? All right, scenario number 5. We have a team and they are using Module Federation. This is a more inexperienced team. They've got maybe one somewhat seasoned front-end developer. They've got a lot of back-end developers who don't have a lot of JavaScript experience. They're dealing with an environment where they're trying to update Module Federation, and they get an error that looks like this. I'll give you a couple seconds to read it. I'm betting some of you are incredibly experienced JavaScript developers, TypeScript developers. And I want you to think to yourself, how would I debug this? This is an actual error that one of our client teams ran into that sucked easily weeks of a senior JavaScript developer's time trying to figure out where this bug came from. This is a very real situation. This was a team that was using Module Federation with Next.js. They were trying to upgrade Next.js to 13 because they really wanted to take advantage of the new app router and the server components. But their team was getting these untraceable errors. These are really, really difficult for even a senior engineer. And so if you're leaning into some of these technology solutions, you need to be aware that your team could get roadblocks by something like this. And a lot of times, these tools and these different libraries that we're using are moving so quickly that documentation maybe isn't there. If you have a team that struggles reading documentation, let alone jumping into source code to try and figure out what's going on, which is a very real gap that I see as consultants, is the struggle with A, documentation, but then B, complete lack of ability to go and look at source code when the documentation isn't there. That's a real serious blocker for a team. And, you know, I've seen this come up in GitHub issues where there aren't resolutions. It gets ignored for weeks or months. So you are tying critical architecture, critical business blocking decisions to something like this, where we're dealing with different things that weren't necessarily ever meant to go or work together. You could run into a really, really bad scenario that is going to effectively just completely roadblock your team. And then you're going to be on the hook to, you know, your project managers, your senior leadership saying, hey, why can't we get that stuff out the door? Why can't we ship it? Well, we don't know how. It's not a great look. Not a great look. All right, scenario number 6. This is a fun one. We've got a mid-level engineer on a feature team, and they encounter a weird Zone.js error. So for those of you who are not Angular developers in the room, Angular's change detection is built on a library called Zone.js. And the most seasoned advanced Angular developers I know don't touch Zone.js. Zone.js is a complex black box of magic that just works. We don't touch it. We don't want to touch it. But one of the very early errors you start to run into with having multiple Angular applications running in parallel in a micro frontend architecture is starting to deal with Zone.js issues. And so if you've got very seasoned engineers who aren't experienced dealing with this, they're going to really struggle debugging any of these issues, especially when they're developing in a standalone application framework and it's running fine. So there's so much we take for granted with modern frameworks. We have solved so many issues, and we can focus on the business. We can focus on understanding the business logic of what we need to write and just write functional code against that. We don't have to worry about making change detection work properly or anything like that. But when we shift into a micro frontend architecture where we start to pull back from a lot of these really great niceties that the modern frameworks offer us, we lose that. And now all of a sudden we are spending a lot more of our time again solving these JavaScript basic issues of things that we've taken for granted or never even had to think about before in our careers. All right. Next up, we've got scenario number 7. A team undertakes a monolithic application rewrite using the strangler pattern. Again, this is what I've seen clients use. This is a good solution as long as they've thought through how they're going to approach this appropriately. Because the reality of what happens is something like this. You know, they start building out these different micro front ends. They figure out, you know, how to go ahead and get those shipped and out the door. But if there's no process or project management, it's really difficult to tell what's been done. So let's say you have like this massive monolithic application that you're trying to rewrite. You've broken it into these different pieces. But if you don't have that documented, if you don't have that publicly available for people to say, okay, team A, comprised of individuals, you know, A, B, and C, is owning this piece of it. If there are bugs here, if there are UX concerns or discrepancies here, I know it's tied to that team. That's part of it. But then also, what is the status of these micro front ends? If you are looking at this huge application upgrade, how do you tell what's new code and what's old code? I was on this client project, and the only way we were able to do it, because none of this was documented, is QA or UX had to get on the phone with the developer. That developer literally had to pop open DevTools, look at that production instance, and then try and guess from the code whether that had been rewritten or not. So these are real problems that you start to run into if you have not thought ahead of time about how you're going to communicate clearly, how you're going to document, how you're going to report status of what this upgrade is and what these different micro front end pieces, their status of completion are, because that's the only way you're going to be able to assure quality or even know how much of the uplift effort is left to do. So what problems can't micro front ends solve? The crux of this talk. Micro front ends are not going to help you write better code. I'm sorry, that's the thing. Shipping good, small, maintainable, clean code is hard. These are hard problems to solve. Micro front ends can help a little bit, but they're not a silver bullet. They are not going to make everything magic for your team overnight. Micro frontends are not necessarily going to help you with sharing code. This is what I hear a lot of times that makes me facepalm with my clients. They're like, oh, well, we don't want to rewrite, or we don't want to do this. For some reason, they don't want to use a shared component library or something like that. And 9 times out of 10, when I'm hearing about, sharing code issues, mono repo, just use a mono repo. Go use NX. They provide brilliant tooling for mono repo support. Mono repo is not a bad word, especially when it comes to sharing code in a pragmatic way. Look into it. Application performance. I've heard this more than once, typically from some sort of technical leadership with no front-end experience that's heard about micro frontends and thinks they're going to be a good way to go. Application performance is not going to get better with micro frontends. You're going to be doing everything more. You're going to be shipping more JavaScript to the browser. You're going to be loading more frameworks. You're going to be making more API requests. All these things are going to get you less performance. My small caveat here is, okay, maybe you're doing something like running on a very old version of WordPress, and you're going to rewrite that into micro frontends. Okay, you've got me there. Yes, you would get better application performance, but most of the time when I'm hearing this from clients, they already have, JavaScript running in the browser, some sort of more modern approach, and they think that micro frontends are the secret check to better performance. Not the case. What problems are micro frontends probably going to cause? A lot, unless you've heard this talk and started to think through these things ahead of time. They will likely cause you bloat to duplicated code. It's very hard to manage the code that's written across all of these different and disparate teams. So there might be times that code is rewritten and you get bloat from that. There's going to be increased difficulty maintaining code quality. I have had clients before that want to use micro frontends because they are very protective about like secret new features and code names and things like that. And so they want everything isolated in a different repo where other people can't touch. But then it can become very difficult to maintain code quality and standards across the board if everybody's developing in a silo where they can't see what other people are doing. Again, mentioned this already, but you're going to start to run into performance problems. You'll run into responsibility confusion. This is at the QA level. This is at the UX level. This is at the, okay, if an error happens, who's responsible? Okay, if performance tanks, who's responsible? Who has to go clean that up? You're going to run into responsibility confusion. You're also going to run into upgrade roadblocks. Again, it's a very exciting time to be in front-end development and be in the micro front-end space, but we're dealing with a lot of new tools and technologies. They are not as bulletproof as a lot of my clients often think they are. And like that module federation problem that I saw that team roadblock by, this is something to be aware of as you're going to you're going to run into upgrade roadblocks. You're also going to run into having to solve the same front-end problems again that we've been solving for the last decade. And I'll talk a little bit more about that now, because instead of new problems to solve, we have old problems to solve that had already been solved using one framework for one application. When you go into micro frontend, you are having to think about routing all over again. I can deal with never writing a router again in my career. It's the same as writing a jQuery slider. Like, we've done it a million times. People who are much smarter, who have entire teams dedicated to this, have built better, more robust solutions. Do you really want to have to build a router again? Something you're going to have to think about with adopting micro frontends. Cross-app communication. We need to figure out what is the best way to communicate between our different apps. I reference this a lot if you're talking about cross-framework like Angular and React. Angular, we very heavily rely on RxJS for communication, for pub sub libraries, and all sorts of things. It's very normal and very native to us, but other developers across other frameworks who haven't been using RxJS for the last several years, that's a huge learning curve if that's something you're going to look at adopting. Bloat, again, due to duplicated code. All these great builders and things we've done to minify our code and make things really, really easy, well, that kind of gets chucked out the window when we might be dealing with, the same code across different micro frontends. I will say I had a client reach out to me that they were looking at implementing a micro frontend architecture because they were struggling to upgrade one of their Angular versions. And so they just wanted to rewrite a piece of their app in the new Angular version and go from there. And I'm like, you really want to ship 2 different versions of Angular to your browser? this is the easy solution that you want to go for, not a good idea. Sharing common code. Again, if you've got utility libraries or things like that, how are you going to share those across different micro front ends, especially if you're in a bunch of disparate repos? Maintaining consistent style and UX, handling deployment automation. We've got a lot of really great, really nice built-in tools now for deploying in any manner for our different frameworks. Well, now we have to figure out a lot of different dependencies again. We need to worry about code quality maintenance. We need to worry about how to handle breaking changes between applications. Here's a really fun one that I think gets a lot of people is with micro front ends, you know, all we're doing is putting JavaScript in the browser and then ripping it back out again when we're not done. But there are really specific things that frameworks handle for us, like cleaning up on teardown, removing event handlers, that as soon as we walk away from the frameworks handling all this for you, this is a thing you need to think about. And if you're not an experienced JavaScript developer who's been dealing with, you know, native APIs and dealing with event binding since before the framework years, you might not even know this is a concept because you've never had to. But all of a sudden, you can end up with some really serious memory leaks if this is something that you're not even aware you need to be thinking about with your micro front-end architecture. We need to figure out how we're going to handle testing. You know, what does end-to-end testing look like? How does that break down across micro front ends? Maybe you've got a team that shifted left really successfully in there, you know, writing their end-to-end tests alongside shipping code. Well, what's the breakdown between micro front ends and how do we keep those tests from being duplicated and not bloating our test run times? So is there a way to adopt micro front ends and profit? I hope so. I hope so. And that's what I want to help you do. So how can we adopt micro front ends and triumph? How can we adopt micro front ends and not deal with all these horrible scenarios that I've shared with you that I've seen clients run into? So number one is understanding your team's limits. Like I talked about, a lot of these concepts are really solid, but they are also concepts that are going to be very normal for people who've been building JavaScript applications for the last decade and who are very familiar with native DOM APIs and understand how to build for the web from before the React and the Angular days. So understanding where your team's skill level is at. What are their foresight capabilities? Are they going to be able to choose tools and libraries that are going to last? And then if they're dealing with more modern tools that aren't as tested, are they going to be able to debug their way out of breaking changes? So you need to understand where your team's at, and then you need to make sure you're considering your tools and approaches accordingly. If you've got a less experienced front-end team, you should not be going and implementing the latest and greatest that the best JavaScript minds are talking about at conferences, because you may not be able to do it as successfully as they do, lacking that level of experience. You need to focus on communication. Consumer-driven contracts are a really great way to go here. Creating contracts between teams, between micro front ends to say, hey, these are our responsibilities. This is how we're going to communicate. This is who's responsible for what. This is what we're going to do if something breaks or if something needs to change. And then you also need to foster opportunities to collaborate across verticals. You need people in high technical leadership positions that have oversight into all the moving pieces to help bridge those communication gaps and spot dysfunctions and make sure that the right contracts are in place. You need to prioritize collaboration. So this is a great quote from Michael that I'm going to reference here again if you haven't heard it already. You know, agree on naming conventions where isolation is not possible yet. Namespace, CSS, events, local storage, and cookies to avoid collisions and clarify ownership. These are decisions you need to make ahead of time, make sure everybody is aware of, and make sure are documented. So that way, if you hire a new team to build a new micro front end, they're not going to go rogue and do all this different stuff. They're going to have the documentation available to follow these naming conventions and patterns that your team has prioritized to collaborate on. You need to figure out deployment. This is a huge sticking point. I say that micro front ends are only as good as your ability to successfully and seamlessly deploy them. If you're an organization or a company that doesn't have good CI/CD infrastructure in the first place, if it is a nightmare to deploy an application, it's going to be a huge nightmare deploying more than one application, because you need infrastructure per micro front end that you're going to deploy. You need, fallback practices for what's going to happen? What if something goes down? What if something doesn't ship successfully? How does that impact the rest of the application? There's a lot that needs to be handled on the DevOps side regarding deployment for you to successfully adopt micro frontend architecture. You need to commit to documentation. I see teams in one code base, one front end that suck at documentation. This is only going to get worse at scale. So you need to really advocate for your team to be documenting code styles, dependencies, deployment flows, everything. Because the reality is this: we break into these autonomous teams, we're shipping micro front ends, that's great. But maybe there's a team and work has scaled down. There's no features to be built for that micro front end. And so that team gets disbanded, and then they go and they help these other micro front end teams that have more features and more development. Like, that's how we move resources around. Well, if you don't have your micro front end documented, you're literally putting your developers through a new hire onboarding process all over again. They need to relearn how your team is doing things, understand how to function. And so, onboarding one developer is hard enough. Some companies, this takes 6 months. Are you going to do that kind of onboarding per micro front end? It can be a real nightmare and a real time suck. So the better you are at your documentation, the more successfully your organization is going to be for team members to transition and contribute to micro front ends and the reality of the way things end up working out regarding priorities and feature development. You should also have experts on call for backup. Obviously, there are a whole bunch of brilliant consultants at this conference speaking here today. My company, we're happy to be your experts as well, because your team might get stuck. And so if you get stuck, you don't want to be going to a senior VP being like, well, we can't ship because we have this vague TypeScript error that we don't know what to deal with. Make sure that you can call in some consultants, somebody who's very, very experienced who can help you out of a hard situation if you get stuck. Big picture, modern micro front-end tooling is still very, very new. There's so much evolving. It's really, really exciting, but I cannot understate how untested robustly some of these tools are. So you may see a lot of talk and you may see a lot of hype about these things, but that does not mean this is something that you are not going to run into undocumented scenarios or GitHub bugs or issues that have been open for months. This is a very real reality you need to be aware of. There is no singular micro front-end solution. I can't give you a list of best practices or one single tool that's going to solve all your needs because those don't exist yet. Micro front-ends are so organization dependent based on how you're structured, what problems you're trying to solve. So this one single solution doesn't exist yet and possibly might not exist ever. Micro front-ends are here to help us solve business problems, not technical ones. Being able to ship features more quickly, that's a business problem, not a technical one. Being able to have more focused product teams, again, that's a business problem, not a technical one. If your problem isn't directly related to a product or business need, you probably or might not need micro front-ends. I do have a lot of helpful resources listed here, and I'll link these slides after so you don't have to worry about recording these or anything like that. But here's the slide. These slides are available at microfrontendproblems.jenniferwadella.com. There's a QR code if you would like to connect with me on LinkedIn if you need to either trauma dump about your micro front-end experience or if you are needing help or just somebody to ask questions to. I'm happy to help you in whatever capacity I can. So that is what I have for you today. I hope you can go down this micro front-end architecture pathway successfully, armed with some of the problems that you might run into and be able to get ahead of the curve and think through some of those. So thank you so much for having me, and I hope you have a wonderful rest of the conference, you lovely human beings.
Okay, thank you, Jennifer. Very interesting talk. We got a couple of questions, and we are little bit hard on time, so maybe we cannot show all the questions. Here's the first one. Daniel is asking, as you mentioned, there are often instances where you feel a company isn't ready to implement micro frontends for a solution. What are the milestones flags that indicates a company is mature enough to support it?
Yeah, so I think number one is going to be, an experienced team of front-end engineers that have been, writing code for a lot longer than just React or just Angular or something like that. DevOps is going to be the other big one. Like, is there a good DevOps team in place that really knows what they're doing, that deployments are really easy and really seamless, and then they're going to be able to do and replicate that at scale? Those are two of the biggest ones. And then the other thing is, you know, you've got to have good project management in place. You've got to have good technical leadership in place to kind of make sure that all the pieces are coming together. This is not something that can just be done in silo development. That's a way to go down for disaster. So you need, you know, good business, good software development practices in place to then be able to do, you know, one front end, let alone micro front ends at scale.
Okay, the next question. Karthik wants to know, just curious to know, what was the problem behind cannot read property of undefined reading code?
You know what? I don't even know if I remember. So this is an active client that we still have, and it was one of my teams working on it. I don't actually remember what the issue was, and I'm pretty sure they've run into it more than just that one time. Yeah, it's that big.
Maybe another guy can answer it in the chat.
Nobody's going to be able to answer that in the chat. That's impossible to debug. So.
Okay, just a hint. The last question comes from this is Lava. What ES-build tools do you have integrated for deployment? Sorry.
I'm not sure if I understand that question, because I don't have this isn't one project. I'm speaking from a collective experiences of a bunch of different projects, and I don't know if any of them have used ES-build off the top of my head.
Okay. Thank you, Jennifer, for being here and to enlighten us. And now we have a raffle with some prizes after your talk. And I wish you a nice day.
Thanks. Thanks so much.
Bye.
Bye.
So here we are. Everybody who wants to sign to the raffle, please scan the QR code and enter your email address, the same which you used for register the conference. Okay, the wheel is getting filled up. Okay, I would say let's start the raffle. And we got a winner for it's Daisy, and the prize is the packed ebook voucher for your ebook of your choice. Congratulations. Please spin the wheel again. Okay, lucky Luigi, the person with that name we have won a voucher for a t-shirt, and I guess it is the third time this one is winning. So the name is the program. Fine, and spin the wheel again, the last time for this session. Okay, and the last winner is Martin Bleeker. He wins a JetBrains license. That's great, and congratulations to all the people who win a prize. Yeah, that's for this session, and we will back in 5 minutes with our last talk for the day. Stay tuned. Thank you. Hello, I'm back again to our last guest for today. It's Zach Jackson. I guess a lot of people know who Zach is, and he's the maintainer of Webpack and of React Universal and the Redux First Router and a lot of other things. And he's the creator of the Module Federation. And to list all his stuff and open source technologies maybe takes the whole session time. So I will pass over to you, Zach, and it's great that you are here. And yeah, here we go.
All right. Well, yeah, it's fantastic to be here, and thank you for having me. So I guess we'll get right into it. So I'm here to speak about Module Federation and a bit beyond. So for anybody who doesn't know the basics, since this is a Micro Frontend conference, I imagine we're all at least familiar with the concept of federation, but just in case. The idea is you can share and import code at runtime between different independently built or deployed parts. So you've got on the one side, that's kind of what it looks like to configure the plugin, and on the other side, this is what it would look like to consume it. So hopefully we all have seen this somewhere before, or at least a bit familiar with the concept. All right, so since we wrote this, which I think we came up with it about 4 years ago, it's grown quite a bit in that time. Lots of big logos have kind of started to use it, and through this kind of process, I think we've learned quite a bit from our user base. The big thing that we did learn is that it's time for a redesign. So some of the things that we have noticed in the last couple of years, the needs of applications really have outgrown the original design of it. As software has become more complex, we have new bundlers entering the space now. Webpack isn't necessarily as appetizing to select when you're looking at your build infrastructure choice. And I think there were a lot of workarounds and hacks that either I've had to implement or users have had to implement that would have been nice to clear out of the way. So to kind of give you an idea on what was behind the redesign. So the company that I currently work at is ByteDance. And we have quite a large infrastructure team over there, and we are also one of the largest users of Federation globally. So our infrastructure team has a very specific mindset for how we solve or write our infrastructure tools for the larger company to power all of the applications that we have. So I pulled some quotes just to kind of help everybody understand the mindset or of how the company operates, or the level of scale or velocity that we try to do our application releases at. So essentially, we needed something that would keep up with this kind of momentum. And since Federation has been a big powering point for the company, what we're trying to look for is how we could build out more organizational enablers versus just a developer tool. My favorite quote, though, is this one from Harvard Business Review. And it kind of says, why has nobody been able to replicate the success of the strategy on how we release software into markets and how we're able to operate so efficiently? Their conclusion was that other companies haven't implemented the organizational enablers that helped us overcome the kind of siloed mindset, which really inhibits the collaboration.
Zach, sorry for the interruption. Yeah. There are a lot of comments on the channel that the guys cannot see your presentation. So
okay, let me stop sharing and reshare my whole screen, and let's see if that works.
There was only the first page of the whole time.
Okay, my bad. All right, is it moving now? Are we seeing?
Yes, it's moving. So.
All right, sorry about that. Sometimes Keynote gets stuck. All right.
No problem.
All right, I'll play back through these basics. Here we go. What it looks like. Companies that have been using it, the growth that it's had over the past couple of years. Lots of familiar logos we've probably seen in there. Our redesign reasons. All right, getting into our quotes again. I'll just give everybody a moment to kind of read these. But, I think a nice one here is like the middle one, where we launched 12 entertainment apps in the first few months, company. And we did this mostly just to test these apps across foreign markets to look for opportunities. So a lot of kind of what we're trying to do with these organizational enablers is drive down the cost of exploration. If we can explore really broadly and R&D really broadly and launch a lot of applications with the cost of launching them reduced, we can obviously iterate and find more markets to go into, more ideas that will work out without really an excessive cost. This is kind of what our infrastructure team tries to do, is reduce the cost, speed up the iterations so that the business can test more things faster and launch them a lot quicker. And then the quote from Harvard Business Review that I really liked, again, really it's about removing things that inhibit collaboration and that can help break us out of the silos. So back into where I would left off. This is kind of the scale. Since ByteDance is the largest user of Federation, this is kind of the scale that we're operating at, and the demand that we've kind of got on our infrastructure and on the tools and on the architecture. We've got over 15,000 front ends. We have 10,000 plus front end engineers. We do around 10,000 deployments every week into a production environment. We have thousands of remotes at thousands of versions. And on the business end, we have over 1,000, user-facing business products. This is either in the App Store or on websites, or I guess it would be really mainly those two. So this is where we kind of started to come out with Module Federation v2. So it was a major rewrite. The big things I wanted to introduce were something kind of like a hook lifecycle or an SDK. I wanted to pull it out of Webpack so that we are more agnostic. And a big goal here was trying to increase engineering throughput, improve the deterministic stability of Federation. If anybody has used it before, you might know if you share something, let's say we're going to share React. Every time you reload the page, you'll always get the right version of the module you want, but you won't necessarily be able to guarantee who's going to give it to you. So if everybody's sharing React 18, it might come from application 1, and if you reload the page several times, it might decide to come from application 2 later on. There was no guaranteed deterministic route of the module sharing. It would just give you the thing that was going to be within the Semver range. And then we also wanted to kind of improve the user experience aspects of it a bit, from loading things, dealing with waterfalls, or if you've dealt with the SSR issues before, CSS flicker is challenging, other various challenges like that. Even preloading it is also kind of tricky in the V1 design. So in V2, these were kind of some of the areas we wanted to tackle. So the biggest area that I like is this new runtime API. So usually you would have your plugin where you can configure your application or your federation options, but you wouldn't have a way to really do it outside of a static compilation plugin. So in this new runtime, it's essentially what we've done is we've taken what you can do at compile time and we've kind of brought that into the runtime area. So we've actually inverted how the whole process of federation works. Federation is really now just a library. And what happens is the bundlers implement the library and kind of just fill out this object for us. So whatever you put in the plugin, more or less just goes into a init call inside of the bundler runtime, and it just does the same thing. So we've extracted that out into a library so that you don't need to have a compiler plugin to actually do anything that you would do with the compiler plugin. We've also introduced, so on the one end, we've got, here's what it would look like to add remotes. And then, again, using the runtime API, if say I wanted to add shared modules, this is kind of the avenue that you would be able to use as well. So you can either just, use this lib key that we have on here, and what lib is if it's synchronously available. You can just add a variable, like if you were going to use an external or something like that. And then we also have a getter key, which is basically if it's async. So if you wanted to dynamically import React and not actually choose React from an existing host or something like that, then you could use that option as well. We do have a lot of this written out in our docs, and we do have new docs that'll kind of show a little bit later. But these are kind of the two main aspects that we've introduced into the federation runtime for end users. So beyond just inside of the runtime, we've introduced what was my favorite part, which is called the runtime plugins. So the idea behind these is, the best way to kind of put it is, imagine you've got like Express middleware, but for require. So as an import is happening, maybe I want to decide things on the fly. Maybe I don't know the URL of the remotes until I'm in the environment. So it'd be nice to have some kind of middleware layer where before request is made for a module, I could figure out the environment, figure out what's supposed to happen, or just change the order of operations, change what it's going to go and do. When I'm loading shared modules, maybe I want to mess with that. Before I'm about to load a shared module, maybe I want to do a lookup on the application to determine certain things. I would say a good example of how I've used this in the more advanced end was I will use the onload hook and I'll use the load share hooks. And I can, when I'm importing a module, I could go in, sorry, it's early for me. Before I go into a module, I could see, is the thing I'm about to import a different framework? So the example I've used in the past is like, let's say I've got a React 17 and React 19, and I'm going to import a component from the 17 repo. Now, let's say this is a scenario where I do actually need two separate copies of React. If anybody has used Federation, you'll know that's not really how it works. You kind of have to have singletons for everything. But with a runtime plugin, what I can do is I can see that there's an incompatibility. They need two different major versions, and Symver of a singleton is not going to pass it. So inside of the runtime plugin, I could set up one where I say, well, once I get the module, I'm going to actually intercept it. And instead of just passing it back to the host, instead I'm going to automatically mount it onto a ref, and I'm going to give the host kind of like a adapter component, and the host is going to send props into the thing you're importing, and we're just going to re-render it, kind of like you would do with maybe something kind of like single spa, or something like that, where you're not necessarily using the JSX style, but as the end user, you are still doing that. So you're still just importing it and working with it as JSX, but technically you could be importing Angular code, or you could be importing Vue, or in any other direction, but you wouldn't know that you're not importing React, and you wouldn't interact with it in a non-React style because the runtime plugin would allow you to build adapters or translation layers between the modules themselves. So that's like a more advanced scenario of it. And I do have a couple simpler examples just to kind of show you. And before, I just want to reiterate that these are runtime plugins. So I can add them through if you saw on my previous slide here, this config also takes a runtime plugins option, and you can just add an array of functions. So it is at runtime that you can utilize these. In the compiler plugin, we have a little an additional option on there called runtime plugins, and it just takes an array of require resolves as well. So it's the same kind of concept, but it's not a compile time solution. It's a runtime middleware layer for federation. So some examples that I've got here. Let's say I wanted to override shared modules. So this is just a simple React component. You'll see there, Lodash has now changed from 3 to 4. And I'm just using stuff that I have in memory from reading the new Federation APIs that I can access. And you can see I just swapped out React DOM with a different version of React. And all of this is just based on the living data from what these two applications have available. And using the runtime plugins and creating a little UI, I can read the information available, and I can instruct the runtime to change how it behaves. And every time I hit save, I'll pretty much refresh the page. And I'm using something like local storage just so that I have a place to store the rules that I'm setting to override the default way that module sharing or anything else is resolved inside of module federation. So this just kind of demonstrates the control layer that you can have, or the amount of flexibility that you've got available. You'll also see it shows like where things are used in and so on, so you can actually see who's using the parts and pieces like that, which I thought was pretty cool as well. So another great example here is, let's say you have offline remotes. If something goes down, this is always a very big question. How do we fix it? What do we do? You can sometimes use a dynamic import to catch the remote if it's offline, but it's not always guaranteed that it'll work. I think the scenario where I see it crash the most often is if the remote entry isn't even there to begin with. I think if you're trying to access something out of the remote that doesn't exist, you can try catch it with the import catch. But if the container doesn't exist in the first place, I think this causes a hard error in the runtime code. So anyway, this has always been a very painful issue of how do you really protect against it. So what we've introduced is a hook called error load remote. So if your remote isn't online or a thing you're trying to access out of it doesn't exist, the error load remote hook will throw. And you can intercept this hook here, and you can determine how do you want to handle it. The whole idea behind error load remote is it gives you the error information and all of that, but if you return a module-like function from error load remote, that's what the host ends up consuming. So if the remote is offline, or I can't get to it, or it doesn't exist, in this scenario, what I'm going to do is I'm going to use this get module function, and I'm just going to have it return a React component that renders the error message as a string. So in the next example here, this is kind of what that looks like. I have two apps. App 2 is never online, so I just start app 1 and I go to it, and I would expect this to throw my application. But instead, the app will render, and all I see is that instead of button 2 showing up here, I'm getting an error message saying, hey, it's offline, and this is why it's offline. But the application continued to operate and function. So another example of using these kind of runtime plugins is if you want something, usually what I find is users have asked for dynamic remotes, but there's different kind of scales of dynamic remote. There's I just want to change the URL of the remote entry, at the startup of the application, but I know I'm importing button and I know I'm importing header, and you kind of know it's static imports everywhere, but it's a dynamic connection to a certain remote depending on an environment or a user or authentication or something like that. So the pain was if you wanted that kind of flexibility, you would usually have to go to fully dynamic remotes, where you're using either like a window get or a load remote or something like that, and you can't use require and import from anymore just because you want that bit of dynamicism at the top of the application. So using a runtime plugin, you can create that. So in this scenario, I've got my init call, and I'm pretty much just creating like a hash map above. And I can loop over it, and I can check, well, if anything exists in the override, then I'm going to use that. And replace the existing application with some kind of subbed in other option. So in this scenario, I'm just kind of mocking like an API call out with a promise all, but in reality, this could be a API endpoint that you're reaching out to, or something on the window where you store your configs or anything else. But the whole idea is during initialization, I have an async hook where I can choose to loop over the remotes and rewrite what they are, where they're going, what I'm asking for, while still preserving the static imports throughout my whole application. So this is just using the init hook, and you would be able to do something like that. This is kind of what it looks like in that example. So you'll see in the previous one, I've got some local storage here for button where I have my override. So when I click the override, I'm just storing something in local storage, and I refresh the page. And in doing so, I have 3 applications. I have app 1, app 2, and app 3. And what I'm doing is when it goes green is I'm still importing app 2/button, but the runtime plugin allows me to rewrite that to say, okay, well, actually, you're going to be connecting to app 3's remote entry and loading button from them. So, you could use this for different version deploys of remotes or for green-blue testing, kind of like I'm demonstrating here. But the idea is in your app code, you're not changing your imports. You're just able to change what they mean just in time. So another kind of example of dynamically mapped remotes, this one is a little different than the previous one that I showed you. The main reason is you'll see I'm using this before request hook instead. So before request really means that I'm going to do the logic right before the bundler, as it's making the import call. If I do it in the init, I'm saying do it up front. I know everything up front. If I say before request, that means as late in the application lifecycle as possible. So if you needed the application to start up and maybe you needed auth to happen and the application to run in order for you to figure out, what will the third page click down be, you could use before request to rewrite these only just in time once you have data that you've collected throughout the application. So it's kind of similar, but it's a different part of the life cycle, but you can still achieve the same concept or the same thing. So another really nice feature that we've introduced is remote federated types. So if you're a TypeScript user, we have hot reloading types across remotes. You'll see in here, I'm adding types. I go to a different app. Immediately when I'm there, you'll see it went red. I fulfill the types. Now, if I go back and remove the types from my remote, and if I go back here, you'll see my host is already throwing a type error. So we don't need to install anything. We don't need to configure any additional plugins. This is just built into Module Federation 2. It works, pretty much in every direction, and it's, kind of what you would expect. Remote type hinting across the board. Now, after I recorded this video, we did introduce something new, which is the ability to do dynamic type hinting from the browser. So this works really well if you're import froming your code. Like I have import, remote 1 button, so there is some static analysis I can perform and I know what to go and find. But what happens if you're using, the Federation API and you're saying, load remote variable, and there's nothing to statically analyze. So I can only do it in the browser. So what we've done is we've taken the API and we've also exposed it into the browser runtime. So that means if you went into the browser and you just pulled up your browser console and you did something like, let's just say underscore federation dot API dot register remote, app 3, and you put in the remote, when you hit enter, if you come back into your IDE, you will see that the types have synchronized just like they're doing here when I'm doing it statically. But for any information we can't statically analyze, the browser will flush the information out in development mode and send it back to our type broker, and it will pretty much do the same thing that it would do at compile time, but we can do this at runtime with the browser filling in the information that we can only find out during the browser's execution stage. We've also introduced proper fast refresh and hot module reloading. So this was also a big issue that everybody's complained about forever. And you'll see in here now I have 2 different apps and I can change them however I want. And you'll see the demo app is updating as we're making the changes here. Let's see if I go and delete this. I put something else in here, and we pop it open again. And, once again, it is working. And if I change the title, instantly, as you would expect, fast refresh works across the different app boundaries. What's actually cool is in a later tool I'll show you that we've released, you can actually do this in deployed environments. So I can mix production with fast refresh and develop against production with local modules and hot reload and fast refresh a production environment without impacting anybody else. We've also introduced something called the runtime kind of lock files, or this capability for it. And at ByteDance, this is how we manage our thousands of remotes and thousands of applications and keep them stable. Is we have something kind of we call it internally VMOC, and VMOC is essentially our kind of control plane for managing all the apps and the dependency graphs of everything in here. And what it actually does is it's using this lock file system that we've developed. So we have the JS remotes that you can see, like that bottom one, but we also have introduced the JSON remote protocol. When you're using the JSON remote, we can do things like hot reloading, type syncing, things like that, because we can perform look-aheads on the module graph before actually executing any code. The other benefit is it allows us to replay Webpack's algorithms on an edge worker or something like that. So we can calculate we can calculate how the app will behave without executing the application. Therefore, we can create lock files for it. So this is kind of what it would look like. This would be our edge server, and you can see I've just got, read manifest. This could be fetch, or in VMOC, this is fetching. So it fetches all the JSON manifests for the remotes. And then we can call the generate snapshot from manifest. And pretty much it'll give us back a payload that we can insert into the DOM or send back over a API call. And when it's received, the application will not behave any other way beyond what the snapshot tells it. So it won't. If we wanted to do a deployment, for example, and this is kind of how things work, we don't actually move zip files around our infrastructure to redeploy anything. All that is actually happening is that this snapshot changes. So if we want to update production, our deploy is actually just a database record change for this snapshot in a table. And that is the deployment, because all the code technically already exists somewhere on the internet. So nothing needs to really happen beyond telling Federation that its new snapshot or its new lock file has been updated, and it should now respect the behavior of the new lock file. The final part of this is kind of what it looks like to insert this into Federation using a runtime plugin. So we're obviously hooking into some helpers that we've got. We parse it, and then we just inject it into our native our runtime helpers here, and register the global snapshot, and then the application becomes deterministic and immutable, and it will never change unless the snapshot changes. So getting into a couple other tools, we've got Chrome Dev Tools here, the ability to change certain aspects and see when our hot reloading works in here. You'll see some type hinting that kind of pops up in this space as well. You'll see in our UI, you can see the relationships between these different tools. You can see as you change things in the code base, the UML will update, and you can see kind of like what's going on inside of, or who's consuming what parts are exposed, how are things connected to each other. Another cool example, this is using hot module reloading in a kind of deployed environment. So I'm able to say, take a production application, and I can use a module proxy. And what I'm going to do is I'm going to replace it with a red, it starts out with a red button, and I'm going to replace it with a different version of that button that I have locally. So I enable my module proxy, and I can say, okay, remote 2 equals localhost 3003, and I just pointed at the remote entry. And now this deployed application is replacing one of those references with my local reference, and I'm able to, again, perform normal HMR or anything else, just as if I was in localhost, but the host can be in a production environment using production versions of React and all of that, and fast refreshed, everything else should still work. So you can find all of this stuff on the doc site. modulefederation.io has been updated, so we're still adding more to it, but it should give you a pretty good idea. Places to go, recipes we've got, the way we configure it, all the new options that are available, the the bundlers that are supported, and so on. So, like I said before, inside of ByteDance, we have something called VMOG. I think in general, if anybody has worked with micro frontends before, you probably would have noticed that it is a little tricky to manage these, especially the deployment order of operations, or controlling it, or seeing who uses what and where. So it was hard. And what we have gone off and introduced is this thing called Zephyr. So I'm going to give you an example here of what it looks like between a normal application and a Zephyr application when it comes to deploying something to stage or production, or anywhere that's not your machine. So in the traditional one, you'll see we've done a commit and a push. And we're going into, let's say, Netlify in this case, and we're waiting for CI to get running. And then we'll sit here awkwardly for however long it takes, and and it'll deploy out the application that you want. Now we've seen CI's picked it up. So the reason I'm kind of demonstrating this is even at ByteDance, we found a lot of the cloud deployments that we need to perform are it's impacting our iteration loops for things that we don't really care about at this moment. So if I need to see it in stage and I don't plan on deploying this PR to production or this commit to production, then why am I waiting the amount of time for all of this to run, when all I want to do is see what's going on right away? So it took about a minute to do that. Now we're going to switch over and we're going to use a Zephyr one. So I uncomment the plugin, I run a build, and the application is deployed. So there was no CI. There was just the build. And this is off on the cloud in any environment you want. Now let's say we're going to change something. What's our iteration loop time to get back to a deployed environment? And we're redeployed again. And so it took us, I think this is using a Webpack, it took us about 1 second to get it back into a remote environment. We do it again, and there you go. And so we can keep on doing this. It takes about, and I think when we switch over to faster bundlers, we get this down to, I think the fastest we're able to bring the iteration loop down to is, I believe it's about 200 milliseconds delay between when you hit save and between it's back in a cloud environment. Now, this is not just pushing something straight to production, even though you could push it to production. This actually can be artificially gated. So we've put in the rules so that you can determine if every time you hit save, what do you want it to do? You could push this into production, but you can set up the rules to say, well, just because the build is there doesn't mean it can be shown to everybody else. So maybe we kind of work in reverse, where we say, well, the code is already available immediately, so I can work with it, I can iterate on it quickly. But in order to get this code or this module snapshot to update in a deployed environment for other users to see, you might want to wake up your CI and have it just go and rerun your unit tests, or use our TypeScript syncing system and just validate that your type contracts are still good. And if those artificial gates pass, you could then update the database record and say, okay, well now the thing that I just hit save on, that can become production. But the whole point is that you don't really need a whole lot of infrastructure around here to actually see what's going, to get things out. It's very fast, it's very quick to iterate on, and you can obviously make it as safe or unsafe as you would want, or as your organization would want through setting up organization rules. But being able to bring down that iteration loop speed is, it's been a very important aspect for us at ByteDance, and having this ability to solve a lot of problems around order of operations with micro frontends is quite nice. So I think one of the other big things I do want to call out is with this cloud thing is we don't actually sell you or want to sell you cloud. So the idea behind Zephyr Cloud is it wants to use your existing cloud infrastructure. If you're on AWS, it just wants an AWS key for the accounts that it can help manage the resources. There's not really any markup on compute or any of that, because we don't want your cloud to begin with. It just kind of wants to manage the cloud that you've got better and help you see what's going on and speed up that iteration loop on whatever system you use. Cloudflare, AWS, Azure, things like that. Another cool thing that we actually have been working on introducing in this product is this concept of kind of compute offloading. So imagine you need to deploy something and you need it really quick. Then maybe we could say, let's push it to a Cloudflare Edge worker. Because Cloudflare Pages, the point of presence takes a while. So we can't immediately roll it out from Pages. But I can put it into the key value stores in Edge worker. And then soon as the point of presence is more readily available, we can promote the deployment into Cloudflare Pages automatically for you. So you could have something, say, like AWS, Cloudflare Workers, Cloudflare Pages, and depending on the workload or depending on the demands that you need for the application, Zephyr could dynamically determine which compute nodes to use. So it can move things from AWS back to Pages, from Pages back to AWS, depending on whatever workload is required. You just connect your clouds and you can state where you want it to go, or you could have it do something like compute offloading and tell it maybe optimize for cost or optimize for latency. And it will figure out the fastest locations to put the different parts of your application for you. So to give you an idea on what the visuals look like on this end, if we click into something in Zephyr and inside of VMock and at ByteDance, we have a very similar kind of concept here. I can click into a node and I could see from my app, I could see what it depends on and who's depending on it. And I can see the different modules or different files in each code base and what they're linked to. So I'm aware of the version, who's using it, and where they're using it. If I don't want to see that much detail, I can obviously zoom back out and look at the node views here to see the relationships or the directions the connections are moving in. And yeah, that essentially gets into Zephyr. So one nice thing about working at ByteDance is we have a huge amount of applications, and everything that we do is really around organizational enablement for the business. So we're driven pretty much by business metrics. The only reason that we exist, the only reason we do any work is, does it improve the momentum of the business? And do we meet the demand put on our infrastructure, on our tools, and on the capacity of what they can do? So one of the nice things that we do with a lot of our infra tools is we benchmark them for the value they actually return to make sure we're doing it right. So these are some really great metrics I was able to collect from my company on what we've seen on average across the thousands of remotes, hundreds of teams, thousands of apps that use Federation. Overall, we've seen 60% reduction in our build times. In Webpack, we've seen about 8 to 10 minute savings, about 2,500 CI hours per project a week, roughly 80% reduction in initial JS size. The biggest number really here, I would say, is code is the bottom three. On average, across all of our teams, we've witnessed a 300% increase in engineering output. That including a 80% reduction in code rollout time. Since all of our code is just a module snapshot, it went from taking, I think, about 10 to 15 minutes to walk code through environments to under 2 minutes to get any code across any of the 1,000 apps that we need. And probably the biggest number here is going to be, we have about 500 deployments or product deployments to end users per project per year. And at our scale of 1,000 applications, we're looking about 500,000 more features getting into the hands of end users per year than we were before, with the only change being moving those over to Federation, powered by something like VMock or Zephyr. If you do want to read a bit more about Zephyr, you can go to zephyrcloud.io or connect with the team on Twitter. And now let's rewind a little bit. So I said there were some new bundlers coming out and so on, and Federation was made bundler agnostic. So about 5 months ago, we introduced Federation support to RSPack. So for any of you who don't know what RSPack is, it's designed to be a drop-in replacement for Webpack written in Rust. So I'm one of the maintainers of RSPack now, and I work on the core team there. And what we see is RSPack is about 11 times faster than Webpack, and it should work with the majority of Webpack plugins, loaders, configs that you currently have. The average user takes less than 1 hour to migrate from Webpack to the Rust toolchain of RSPack. Obviously, Federation works, and all the other things that you would think of would work in there. And you can kind of see the difference in speeds. The one thing that's really strange, and I do need to go and speak to the team and understand why, but the development build the production server is actually, the production build is actually faster than the dev build. You'll see my dev one's 149 milliseconds, but to do a production optimized build, it only took 70 milliseconds. So I'm not quite sure how that's possible, but you can kind of see the deltas between what the RSPack one looks like and what the Webpack speeds look like. And you can see we're looking at 700 milliseconds, 2 seconds, so on and so forth, versus, the slowest one is 230 milliseconds. So that kind of gives you an idea on the speed increase. But RSPack also does keep getting faster and faster. I think about a week or so ago, about a week or so ago, we dropped the speed down by another 10 to 15%. So some of the things that we're looking at adding into RSPack in the future, a big one is going to be remote caching. So we're going to be introducing remote distributed caching, and it will be a free open source addition to RSPack. So you can host the cache server yourself, and you can share that cache server among whoever in the company you're working with. If somebody's already built 80% of the application, you make a branch, change the other 20% of it, you're really only recompiling that 20%, and you're pulling all the other modules out of the remote shared cache. We are also looking at, and this is a bit of a stretch goal, but looking at distributed compilation. The idea behind that would be, imagine if we could offer a fixed time on builds. So usually the bigger the application, the slower the build becomes. And it's usually kind of like a linear growth. If it's 50,000 modules, it might take 4 seconds. If it's 100,000 modules, it'll probably take 8 seconds. So what if we wanted to say, we want to guarantee that every build always builds in 2 seconds. So with distributed compilation, the idea would be you could invoke more instances of RSPack on your cloud, and we could introduce something kind of like a client and daemon, where the RSPack client could break up the graph, dispatch the work out to the daemons. They each build only one small section of the graph, push it into the cache, and then the client pretty much just reassembles the cache and the module graph, and then just seals the build and emits the chunks. So in theory, you could wake up 10, 100, 1,000 build workers, and you could parallelize the compilation across multiple backends as well, and speed that up. I think for most users, you probably won't need that, but if you do have a really large application, that would be very nice to be able to control that build time regardless. So one other cool piece of news that kind of popped up with RSPack is, I think it was just last week. It was when I was at Render ATL. So I think it was last week. We actually ended up winning Breakthrough of the Year at JS Nation. So that was a really awesome piece of news. I just wanted to kind of share out here, and we're very honored to have received that for RSPack. We also do have like a slightly larger family around RSPack. If you do want to check it out, we do have a big Rust tool chain that we've kind of rolled out, but I'm only going to touch on 1 or 2 that are more relevant to Micro Frontend conference. So obviously, if you want to check out RSPack, rspack.dev. If you don't like Webpack style configuration, we also have kind of like a Vite flavored one called rsbuild.dev. You still have all the power of RSPack, but you have the simplicity of their configuration style. If you do want to read a bit about the rationale behind it, you can always go to our Git org, and we did have a really good discussion, or just Google the rationale behind creating RSPack, and you'll see the document pop up. And you can kind of read all the research and development that we did, everything else we rewrote before deciding on Webpack's API and rewriting it in Rust as the only kind of way to support our business. So kind of getting into the ROI of it, since we do have this data here, overall, some really impressive numbers. Biggest ones are across the board at our company, we have an 80% reduction in our CI cloud costs. About 30 minutes saved per build, per project. About 200 hours a day on CI per project, and per developer, they save about 7 hours a day, assuming they only ever did 5 dev cold starts in that day. So we kind of measured every time it takes for you to press save, every cold start, every time you tear down the server and start it back up. We kind of track all of that in our company to figure out our business metrics and find the areas where we can shorten the gap on time burnt unnecessarily. So it might look like a small number, but monitoring all this, we've ended up at saving about 400 hours a year. just assuming you know, on 5 kind of developer startups, plus all the saves that you do in between. I think we had a bench at about 100 hot module reloads a day. So anyway, but this kind of gives you the idea of the ROI that we have seen across the board here. We have also worked with other big companies who have adopted RSPack and used Federation and things like that. And from when they adopted it, they saw about a $32 million a year reduction in their operational expenses. Or capital expense, engineering time, pretty much. So including CI, including the time it takes to start their dev server, all of that. I think the loss was about $120,000 for every day that they didn't use RSPack. And then when they switched over to it, that was the gain they ended up getting from it. But we've also spoken to a few other companies as well. Another one has told us that they are saving millions of dollars in bandwidth costs per year since they've switched over. And at ByteDance, our own return on investment, a conservative one, has been RSPack's value is in the hundreds of millions of dollars in ROI for us. That's across engineering hours, cloud costs, and the user experience lift that kind of comes with you know, improving the user experience. So some of the tools we've also introduced around our little family that are kind of, you know, I'd say not, these are relevant to every developer, I feel, not necessarily Micro Frontend, but a big one is if anybody's used Bundle Analyzer, it's been very painful when apps get complicated. And so we've obviously had this issue as well. And so what we ended up writing was something called RS Doctor. This works for Webpack and RSPack, like it says in the title. But what, ooh, do I not have my other slides in here? I don't think I do. All right, but what I would do is if you want to check it out, definitely go to rsdoctor.dev. Nice things that it gives you is how long things take to compile. Where's your tree shaking not working so well? Are there unused exports in your build and you can go and inspect them? You can see the timing of everything. How long does it take for, you know, SWC loader to work, or a post CSS loader, or a SAS loader? Which files are slowing down your build? What's resolvers are inefficient? Flame charts that kind of show up in the UI of this thing on the back end. Any warnings that we find, type inspection, whole bunch of other things we've kind of packed into this tool to give us something kind of like a one-stop shop to understanding what modules are used, duplicated, where's the build size coming from, where's the build speed being lost. The last kind of thing I want to point out here is if you are a Micro Frontend user or Federation user, ByteDance also has its own meta framework. This is what we use internally. And again, we're the largest user of Federation here, so it has been very refreshing to stumble across that we owned this, because we've been able to tighten up that integration between them. And we do have some PRs we're working through the system now that are going to introduce a lot of server-side rendering capabilities into modern JS, specifically around Federation. So things like being able to automatically discover the roots of other remotes, or being able to deploy an empty app shell to AWS and everything else is just put on S3, and the app shell never needs to be updated because the root discovery is automatic, making sure there's no waterfalls, making sure it's efficient, making sure the CSS never flickers, kind of all the things you would expect from a normal SSR experience. We're moving from our internal copy of modern JS to our open source copy of it. And like I said, that process is in the works. So if you are looking for a good, tight experience in this ecosystem, this is what we use, and this is what we need to work well. And we've kind of owned the supply chain of all the parts. And, you know, this is what I'm hoping we can push in to make a really good, solid React Micro Frontend layer for kind of the bigger companies like us who need these things. So last thing, a bit on our roadmap. Across the board on the RSPack end, we are going to be introducing a NPM packaging solution called RSlib. The closest way to describe it is like a meta framework for authoring packages. So a big problem we've had with Webpack is it's never good at making ESM, tree shakeable ESM. So we've been working with the Webpack Foundation and obviously the RSPack team to introduce a much better ESM output format that is designed to be tree shakeable and designed for package building. So we'll be bringing those capabilities forward under RSlib, which should offer you, you know, a build framework for making libraries. On the Federation end, I'm busy working on import maps. We've got an ES build Federation plugin that is almost done. We have a roll-up one that's also in the works. And then we already do plan to work with the roll down team from Vite once roll down gets a little bit more matured to add Federation into the Rust end of Vite as well. We've got the V1 of RSPack coming up next month. On the RSPack end, we're also looking at import maps inside of RSPack. Multiple output targets, so being able to build CommonJS, RSC, web worker, browser, all from a single build instead of needing multiple builds. Tree shakeable package builds, and those features will show up in powering our RSlib. On the Federation end, we've got we're introducing something called the Module Federation framework capabilities layer. The idea behind this is taking a lot of the ideas from single SPA and adding them into an additional point of federation. So the ability to have mount points or router bridges between multiple apps. So I could import an Angular app and I could forward the React router props and context into Angular. And I could also pull them back and forwards to allow multiple apps and multiple routers to act as one and to mount and unmount accordingly, but using federation as the underlying solution for doing so. A nice one we're also looking at is RSpeedy. So I believe this is still very early on in development, but inside the company, we have a lot of apps, a lot of native apps, and we actually have our own meta framework for React Native app development. And we are looking at open sourcing that sometime this year or maybe leading into a bit of next year. But the idea would be almost like a alternative to Expo with a very light micro VM for all the JS stuff that needs to be done on a full Rust tool chain. And of course, I have got my ulterior motives here of when we release this native app framework, I'm definitely going to try and do what I'm doing to modern JS to it and make sure that we have a really tight module federation powered React Native framework right out of the box. And then of course on modern JS, we are looking at SSR, root discovery, and other niceties over there. And like I said, that PR is already passing our CI. We're just cleaning up a couple extra areas of it. But anyway, that's kind of the big update on what's going on here. Thank you. And yeah, stay tuned for news coming across various channels or at conferences or just on our docs.
Okay, thank you, Zach. Great talk. And sorry again for the glitch at the starting point.
No, it's all right.
We have a couple of questions, so we will start with the questions from Alvaro. Do you need to configure some DTS files or something in the tsconfig JSON? I often get the error module not found when importing my remote module.
Yeah, so the main thing you would do is if you're using Module Federation plugin from Webpack, you would stop using that and you would npm install Module Federation /enhanced. And then if you go to our docs, you can just look, I think you can look on the announcement page or on the guide, and it will show you TypeScript. And it'll basically tell you, cool, here's how you enable TypeScript. There's a little guide on it. But basically all you do is you go to mapped paths and you would say @mftypes, I think. And then what we do is we read your tsconfig and we inject all the types. We pull them from a zip file, and the remotes carry a zip file with them in the manifest mode. And essentially, we synchronize all the types back onto your file system. So yeah, that's how you would solve it. If you're using normal federation, then you would switch over to V2's version, which is again not part of Webpack, not part of RSPack. We have an independent ecosystem that we can control and maintain and move forward, and then we just have the compilers implement our runtime and not drive it.
Okay, one more question from Kathrik. Going via manifest way, wouldn't that have an extra hop to server to load manifest first and then remote entry?
Yeah, so I think the main thing with the manifest on our end is because at ByteDance we have we've got VMock on our back end. So the manifest thing was kind of a solution to give to the open source because they don't have our server infrastructure. And the V2 was originally actually an in-house fork that they had built and bound directly to their infrastructure. So since we can't release our infrastructure as a whole, what we've done is we've figured out a way to provide this to you. So yes, this will cause a secondary load if you want all the additional benefits, but I'm pretty sure if you're looking at several other solutions out there, they all involve overhead loads to do this. How we ideally deal with it is we inject it in right from the edge worker, so we pre-calculate it, so there's no need for any JSONs to come down because we can compute the result of the JSONs on an edge worker, and we insert the snapshot, which essentially means that Federation doesn't think at all in the browser. It just listens and does what it's told exactly, similar to like a monolith or a statically compiled graph. But yes, you will have to be conscious of, if you're using the JSON protocol, you will introduce a secondary request that is unavoidable unless we start evaluating remote code on your servers and everything else, and that introduces another big challenge. So with everything, there is a drawback.
Okay, thank you, Segeri. We have a couple of more questions, and I hope we can send you the questions. You can answer it, or maybe we can answer the questions. We are hard on time, and we have a raffle, so the guys are waiting to win some prizes. Thanks again, Segeri, for being here, and yeah, start the raffle. So please check the QR code for the raffle and sign in, type in your email address, which you used for signing up the conference. Yeah, the wheel is filling up with names, that's great. Okay, then let's start the raffle. Okay, we got a winner from Florian's ebook, which is Sarah. Then start again. And the second winner is Nirini with a t-shirt as a prize. Great. And the last round. So we have another winner, JZ, which is the JetBrains license. Awesome. Congratulations to the winners, and thank you for being here, and thank you to Segeri. And now we are close to the last talk with Florian. Please stay tuned, and goodbye from my side.
All right, welcome back to the Micro Frontend Conference 2024. Unfortunately, we've already reached our last talk of this conference. Very sad, I know. But before welcoming our last speaker to the stage, I also want to highlight our 2 workshops once again. You can see them now here on that slide. They are also, they are offered as part of the conference. We are offered 2 workshops, one from Manfred Steyer, Micro Frontends with Angular Federation and Web Components, and one from Florian Rappel, Tooling Independent Micro Frontends with Module Federation. So if you're interested in one of them, just head over to the conference website. That is conference.microfrontends.cloud/2024/workshops. And there you're going to find all the information you need to decide if one of these workshops could be something for you. Awesome. Besides that, I now want to welcome one of the main organizers, actually, of this conference to this stage. Welcome, Florian Rappel.
Hello.
How are you doing, Florian?
Very nice to be here.
First of all, thanks a lot for all the efforts you've put into this conference. I think I can speak for everyone that attended this conference. We very much appreciate it. Thanks a lot. Just a quick introduction. Florian is a solution architect here at SmartBuild in Munich, and he's specialized in the creation of scalable distributed web applications. And he's the creator and main contributor of the Micro Frontend framework Pyro, which we've already heard a couple of times today in different talks. Furthermore, he's the author of the book, The Art of Micro Frontends, which you can actually also win during the raffle after this talk. So stay tuned for that. Today, he will introduce a very exciting new project he's been working on that makes it actually possible to use Micro Frontends anywhere you want. Painless Micro Frontend orchestration with PK. Have fun with the closing keynote, Florian. The stage is all yours.
Thanks a lot, Felix. Thanks for the kind words. I think this whole event here would not be possible without the outstanding team at SmartBuild here. Everyone who's contributed either as moderator or also behind the scenes, so tech with the nice cake and everything. I guess that was a really nice and very well done organization by everyone. And also, of course, much appreciated to all the speakers. But we're not there yet at the closing words. What I want to present you is a project that I've been, let's say, tinkering with for the last couple of months, and that is now finally very close to being released. We will not release it today, so I can already spoiler that. We will not hit the release button this time, but it is very close to being hit. And what I want to do with this talk today is to open up a dialogue if what you see there makes sense, if it solves a problem, or if it's just a useless thing that doesn't have any existence, justification whatsoever. So here I really want to open the dialogue. But before I do that, also a few words about myself from me. With everything that you heard from Felix, I want to encourage you also to always reach out to me if you have any problem in the area of scalable front-end development. We are always eager to hear you, getting a dialogue, and maybe have one or the other project together. That's why we are here and why we can be hired. So always get in touch. You have my LinkedIn profile always written on the bottom. Just write me a message and we are good. With that being said, what is the state of Micro Frontends? And I don't want to give another, let's say, a whole keynote as last year. So that's why I want to make it brief and just look at a couple of the technologies that we have out there and that are being used and what they are actually solving. So on the one hand, we of course have component models being out there and being, let's say, fully grafted. On the client side, we are mostly dealing with single spar, for instance, which brought up this generalized component model, mount, unmount, update, bootstrap maybe, all these lifecycle methods in there in a universal component model. But this is, of course, not the only effort. We, of course, have something like open components, for instance, which brought that even earlier and has specialized on the server side to bring a universal component model that can be used for rendering micro frontends. Now, if you look a little bit further and say, well, okay, this is maybe the life cycle of components, maybe you need that, maybe not. But what you may need in general is, of course, how do you now compose these micro frontends? How do you load them? And especially, how do you make it possible that they share dependencies among each other, which of course is a controversial topic. I don't think there's something like share nothing or share all. The truth always lies, of course, in the middle. Some dependencies you might even need to share due to technical constraints. So these technologies are certainly needed. And what you have here is, for instance, a native approach, as sketched on the left-hand side with native federation using import maps and ESMs. And of course, something more, I'm always saying, or will say in this talk, Webpack module federation, but make no mistake, it's now in the stage of moving out. We have support already in ES build, in Beat, and of course, RSPack is a very close one. So this gets broader and broader. So always when I talk about Webpack module federation, what I mean, of course, is module federation. That being said, this is the other aspect that you can use. And then, of course, you might have even things like Pyral that, of course, I can't dismiss on my own slides, which uses, for instance, SystemJS, but is compatible also, for instance, with Webpack module federation. So you could write a pilot just using a Webpack and module federation or RSPack and module federation and ship it and go sideline the whole Pyral tooling if you want to, and it would also just work because, yeah, it can leverage and is compatible with the runtime. Okay, so we have this component model figured out, sharing and loading is figured out, and Pyral, of course, brings all these things already for loose coupling and combines all this into one package. So we have a universal component model in there, and of course, ways to share and load dependencies and micro frontends. So all is cool, or we can go home. Technically, everything is solved, and as we heard in the opening keynote by Luca, the real problem is not in the technical area. So what am I doing here? What's the problem? Now, there are certain things you can bring up which won't be solved technically at the moment, or will be very difficult to achieve technically. Again, if I write Webpack here, you can replace it also with RSPack or anything compatible with Webpack module federation. So in order to consume a Webpack module federation micro frontend, you would need also a compatible process, meaning that you would need, for instance, another Webpack bundled solution there, right? This is not so easy, as we heard, of course. We're now extracting out the runtime of module federation, but yeah. What about native federation, for instance? Could we use just native federation and module federation? They both have federation in the name, so it should work, right? No, does not compute here. It does not work, and so, of course, once you, from your architecture point of view, decided for one or the other technology is ruled out. And even though you might now say this is a rather, let's say, esoteric case here, this is not real world, let's pick this example. You wrote a micro frontend using Webpack module federation, and now your classic team approaches you and says, this thing is cool that you delivered. We have a PHP rendered site, and we want to include your micro frontend there. What will you tell them? Will you tell them, well, it will work, but you first need to have extra tooling, maybe then combine it into a new script, embed that script, have all these extra steps, who's maintaining that script? How do you now bring it there? Can't they just do that already? Do they now need to know what you use as a component in your microphone? A lot of questions will arise. You will not have the answer to all of those questions naturally. And in general, it will be very hard to use it just from any technology. Even though the thing where would you use it, client-side rendering in this example, would still be the same. It would be very difficult for this team to bring it in. So we require a compatible host for sure. And you might say, okay, that's one issue. We can maybe live with that. Fine. Let's look at another thing that you might say is interesting or not. you start with your Webpack-powered application, and this is a single-page application, of course. And you include, of course, your micro frontend, now written again with compatible technology. So Webpack it is here, Webpack is there, all cool. But now, what if another team approaches you and says, okay, we are also using Webpack, but we are using it a different process. We have now Next.js, for instance. Okay, so this is server-side rendering, and your next answer would be there is something for Webpack, but it works a little bit differently, and you would need to produce the micro frontend again. That wouldn't be a good answer, though. So potentially, yeah, you will look for something else, and maybe the end result will be that in your Webpack process, therefore, for instance, Next.js in this example, you would change it that only, let's say, for the client-side bundle, the module federation micro frontend would be loaded, and it would take care of it. Maybe that it's not appearing in RSC or a React server-side render component, but only in the one that appears in the client side. Nevertheless, wouldn't it be much nicer when, at least with what is within the micro frontend, doesn't have any constraints on the client, it would also just work. So do we really have to think about that the error doesn't work or what's inside? It should be rather what's inside that matters and not the outside technology, right? So that should allow that we just use it on multiple environments, because at the moment, it's not so easy to make this transition, right? There's no environment transition possible. And finally, and this is now more of a problem of Pyrel that I see, but one that, of course, is motivational for me to actually come up with this new project is Pyrel itself brings already a lot of things to the table. But one of the things that might block you from either knowing Pyrel or using Pyrel is that it comes with an app shell that requires you to have React in there. Now, this React part, of course, can be rather minimalistic, and maybe you don't have any layout in there whatsoever, but nevertheless, you would have it. And whatever you do, you have this package. Well, historically, we had a package called Pyrel Base. We still have this, but this package, I mean, never really paid off for us in that sense that it allowed either us or anyone else to place useful systems on it, right? So you always had at least Pyrel core, but then you have React already in there, and that's not good, right? So you want to maybe have something without React. Because right now, believe it or not, Pyrel is used a lot, for instance, with Angular-powered micro frontends, and even maybe in some teams that are only using Angular-powered micro frontends. So there is still then React in there, but only in the app shell. And the question, of course, would be, what if we change the app shell to run on Angular? And of course, in the picture that I've drawn, we swapped now places, and now this Angular-powered app shell might use React, but it could, of course, then much more easily use other Angular-powered micro frontends. And it would allow certain things. But again, at the moment, not possible, because even though there are some techniques where you can bring Angular directly into the app shell, there will always be this React part in there, and you can't strip it out. And that's, in my opinion, a problem we want to get rid of. This problem can, of course, be summarized as framework dependency. We don't want to be framework dependent. We want to be independent. So what if we just start with HTML? HTML is good. HTML is great. Some people will tell you, oh, server-side rendering or plain HTML is all you need. So what if we just start with HTML? We covered all of the cases that we've seen. For instance, PHP that uses HTML, right? So yeah, HTML is great. So all you would need to do is just reference a script. And that's it, right? No bundler needed for that, so no additional tooling or anything. All you need to do is drop a single line of script, like what you do with HTMX, what you do with Alpine, or all these other very, very lightweight frameworks, right? That are just libraries that you import and that bring something to the table. Now, how do you now reference components coming, let's say, from module federation? Well, what if you could just have a web component, and that web component allows you then to specify what you want to have shown, which component from which micro frontend. And that's all. The rest will be then taken over by the script that you referenced. So this script is there to load, call, whatever, and orchestrate all the things that are necessary and relevant in the micro frontend space that you just now spawn here. So far, so good. And this is where we actually thought about creating something new. Now the question will naturally come up. What's the relation between Picard and Pyrrole? And what's the story with Pyrrole version 2 that we announced at last year's conference? So we've been tinkering a lot with that. And as mentioned, there is this Pyrrole base layer that we think is rather useless at the moment. And the main idea was that it is not useless. And what we want to do is we want to replace Pyrrole base with Picard. And that will form the basis for Pyrrole version 2. And of course, there will be still Pyrrole core and everything. And the app shell will change a little bit. There will be a compatibility layer later on, right? And so you can still use and migrate to Pyrrole version 2. And using that compatibility layer, even the app shell will be rather, changes there will be rather minimalistic. But there will be some changes to the app shell. There won't be any changes to the pilots. And we will also see that in the demo in a second. Picard already works with all the pilots out there, out of the box. So even if you say, I don't use anymore my Pyrrole-based app shell, I go to some PHP-based application, it will load all the pilots and it will work. So that's a little bit the idea. So Picard is like a really small library, but this is the library. This is everything that you would need for Micro Frontends. And if you want more, you can either go to Pyrrole, or you can make your own thing based on Picard. But maybe you're already happy with Picard. But let's do one step after the other. What is it that we want to provide with Picard? First of all, we want to provide it on multiple, let's say, registries. So in NPM, but also we are thinking about JSR here, so the new kid on the block. We want to provide a package that essentially contains a library that is rather simple, really to the point, and has 0 dependencies. So really you can just import it somewhere and it will just work. There's no additional installation. There will be no dependencies that need to be installed together with it. So it's already pre-bundled, if you want to, or pre-built, depending on the area of use. And this area of use actually are the different variants that you want to ship it in. So we want to support different platforms. As an example, we want to run, of course, in the browser. As you've seen, we start with HTML. You want a script reference. Well, that's the browser, right? So it should just run. You have a PHP output. You drop a script reference. It works. Great. But then again, we want to support different platforms like, for instance, Node or Dino or Bun if you want to. So server-side platforms where you also import that, but it will behave a little bit different. We come to that in a second. But the quintessence of the whole thing is that it works with or without a bundler because, well, you can drop a script reference in your browser, you can write on your single-page application, import it there and customize things, or you already work on your server-side rendered solution, I don't know, a Next.js or a plain Express application, and drop it in there, and it also works, right? And this is a little bit the idea. It ships already in this variants, and it should do the right thing on the right platform. Potentially, you need to import the right subscript from the package, but nevertheless, most of the time, you just reference Picard, and it will just do the right thing because, yeah, bundlers usually select the right exports, etc. The qualifiers usually match, and it just works from there. Now, what does it actually provide? It provides a set of, for instance, web components when it's running in the client, a set of APIs when it's running in the server, and it, of course, will be compatible with things like React and Angular, not out of the box shipping in the sense that, oh, you didn't do anything, you export from the Micro Frontend a React component, automatically does the right thing. But of course, based on the universal component model, it will just be compatible and it will work with, for instance, the conversions from Pyrrole. Potentially, it will also work with other conversions that are out there. For instance, Astro has in the integrations always such converters. Potentially, can make it compatible to this. I'm not sure how much effort it would be. That's something we look into, but it for sure will work on the converters from Pyrrole and their new model. And it will work with the component model from SingleSpar. So if you have already a parcel from SingleSpar, for instance, it would just work with this thing out of the box. So it combines all this, and the idea, again, with Picard is not to teach you a new way to write Micro Frontends, but to rather have a way how to use Micro Frontends anywhere. And that's the thinking here. Now, what about these variants that I was talking about? So here we're looking at 3 platforms, make no mistake. I'm not here saying that it's only running in Chrome or only in Node.js or only in Astro, but these are just examples for these platforms that I want to talk about. So in the browser, what we want to ship at the end of the day is a script that contains a loading mechanism for dependencies and whatnot, for understanding, for instance, a micro front discovery service or feed, as I name it here, and to provide a set of web components or elements that you can then use whatever is exported from micro frontends anywhere. And this behavior of this script that is then created for clients is a single scoped, meaning that once it runs in your browser and it just assumes that this is it. This is it. There are no other users here, right? This is a single user who sits now on the screen and interacts with the site. And therefore, it also does lazy loading for everything, right? So any component, everything is lazy loaded only when you need it. The only difference is, the only crucial point is that Micro Frontend discovery service is, of course, requested in the beginning to already populate that, but also not with the highest priority. So other network requests have, of course, still the preference. All right, and as mentioned, it uses web components, which is quite important. Now, on the server side, this is a little bit different. Still, we have, of course, a loading mechanism to load, for instance, dependencies of microfronts, etc. But then the feed response is there, and based on all that information that we gathered, we now can't use just web components, right? Because they would need a live document object model. Instead, what this thing does is it stringifies essentially all the renderings, if it's possible, from the universal component model that's given now from the exported components of a micro frontend. And speaking of that, it allows you also to have a dedicated endpoint in your server that delivers these fragments. So what I mean with that is that you not only have now the ability when a request comes in and you render the response, that you stringify now the usages of components of micro frontends and place it, of course, in this response, but also that you can say, hey, for this component of a certain micro frontend, render me now just how it would look like. Of course, that is a crucial part internally for the stringification part, but exposing it as an API is quite necessary in order to, for instance, do it in combination on the client, as we will see in a second. So you can expose that and just render smaller fragments of your page, which are corresponding to micro frontends or components from micro frontends. So for servers, we ship in that, and that is a little bit different than client side, because here we have multiple scopes. So essentially, you could then decide, do you keep the same scope or reuse an existing scope for this request, or do you create a new scope? And the scope is essentially all this information that comes for this user, right? And that has, of course, certain aspects to it, because the feed service you want to call just once, and you want to eagerly call it now. You don't want now that the request comes in and you're now going to the discovery service to say, hey, what micro frontends are there? It would be way too slow. And then you would maybe prefer also doing it on the client anyway. So what you want to do is you already have from the discovery service the response, and that gives you everything. But now for this particular request, you want to look at all these micro frontends and say, hey, which of these micro frontends now make sense to render for this one user? Potentially not all micro frontends are allowed to render for this one user. And even if they are, potentially they would render differently than for another user, because maybe, you know, they're localized, or there are some statements depending on the user's role, whatever. So that they might be sensitive to the request. And so we scope this, that we don't get, let's say, in caching conflicts and reuse an existing response for the same user. But still, you already see it's multi-layered, because you can't just do everything again for every request. That would be way too resource hungry, and so we did it a little bit differently. An important part, serialization. Finally, what is now the specialization in platforms like Astro or others, where you say, hey, you have a server side, so Next.js is also an example here, and you want to do something here too, right? You already want maybe to render out a complete serialization, a complete HTML of your website. But then some parts of the site, they still have an interactive parts, like these islands, right? And you still need to hydrate them. So you need to detect that. And for these things, you want to reuse your custom elements. You want to preserve them, therefore, of course, what you did on the server. And therefore, you need to have a loader, still not as massive as beforehand, but still a loader for the dependencies and everything. And you need to have the same elements part that we saw before in the first variant. But now, key point is we also have a connection to the fragments, because whenever you change something, like you want to have a new element in there, a new component from a micro frontend, how do you get the answer? You didn't load the discovery service micro frontends, and therefore you don't know what all exists. But what you can do is you go back to the server and then you ask the server, which is the fragment endpoint that we discussed, render me this. And if that makes sense, you get back a rendering and then you can rehydrate and everything's awesome. So you have this combined use here, which is the same as the client, but a little bit different, right? And these are the three main variants that we will ship. It has a resume scope, so it's the single scope, but it takes the one that was generated on the server specifically for the request. It just resumes that, and it's eagerly lazy loaded, meaning that the server already did everything. We resume there, but now we continue in a lazy loaded fashion, and we are not doing full rendering in web components, but only hydrations. And the full rendering is always done via the fragment server. So you can see already these three variants, they are different, right? But they are all based on the same code base, what we will do in Pika. We just, have a build process there, combine the things that make sense for each platform, and then have the right variant in the package. And that's a little bit how we think about it. This is where I go into demos. I think I still have enough time to cover a few of these demos. Hopefully I'm not running out of time, but let's tackle one after the other. Let's start really simple, just some static HTML. And all these demos are just meant to give you the idea. I kept them all hopefully to some minimum. The last one is a little bit more extensive, but we will see when we get there. And I hope I bring over the idea. But otherwise, always just feel free to raise the question in YouTube chat or on Discord, right? So that being said, this is the static page. It's a really simple static page, so just some HTML I crafted together, and it uses Bootstrap, but it also uses, of course, this script that at the moment I don't get from Unpackage or so, but just, as a build artifact, and this is the script Pika.js. This, again, is just a build artifact here out of our code base. We're here in the Pika repository. Now, the whole page just shows a little bit of static content, right? We have a hello world and a Jumbotron. Awesome, I love Jumbotrons. And the page contains some fragments from Micro Frontends. Okay, what can you tell me more? Now, there are some columns. We have 3 columns. The first column, we just have some static content. But in the second column, we received from, let's say, another team, hey, we have something to provide here. This team was working on module federation, so they already gave us this URL that is rather long, but it leads to remote entry JS in something like MF Simple HTML. Okay, nice name. And we refer to it here in the source attribute of a custom element called PyComponent. The name, by the way, can be changed, but by default, and this is the way where I just reference Pika.js, it is called everything pi minus. We could, of course, call it Pika, but you already see Pyro starts with PI, Pilot starts with PI, now Pika is PI. We really think that Lambda is for server and Pi is for the client or for front end. But anyway, all right. So source is the one attribute. It tells now Pika where this thing can be found, and you need here, and this of course is the subject to change, so if you have a better idea, just tell me. We have a prefix that tells it this is module federation, so MF column. And now the next thing is, since it's module federation, you need to know the container, because that way it will be placed on window, and we call it simple HTML. Okay, nice. And then we have this add syntax. Again, module federation requires this kind of syntax here, and when we tell it the URL. So far, so good. Now, of course, the question is, what do we actually want to get from this container? We want to get something that we called column. So this is our import, and we're done. And we will render that here. Now, next column, we do something similar, but we want to have some micro frontend that another team gave us. And this team was using native federation. So here you got a remote entry JSON, and we have as a prefix NF. So native federation, awesome, covered. Again, they named it your column. If you think that's bad that both have the same name, it's a little bit intentional. There will be a demo where we use this, let's call it a coincidence, which is not, and we render multiple things, and stay tuned for that. And then finally, we have also a name called counter from this thing here, which leads to an index meta JSON, but this will be a pilot. So I'm using here pilot. There is no prefix. This is also, of course, something to discuss. Do we need something? So pilots are meant to be the default here. Do we really need a default? Something again that can be discussed. We are open here. And yeah, that's it. So source is here the pilot. The name of the component it registers is called counter. And that's it, right? So how does this page look like? Yeah, wrong address here, but it looks the same. The address might have changed, but the content did not. So we have our Jumbotron, then we have our columns, and then we have this little counter. If we look at the browser tools, what we can see is that the Pi components, of course, remained, but Picard rendered now inside something, right? And this is already there and is nice, is working. We're happy. We got all these columns and they were filled out now with the rendering of the different teams. And if we look at the network tab, what was happening, if we just refresh, we see it loads, Picard.js is loaded, then it loads the different entry points, so either the remote entry JS, the JSON from native federation, from Pyrrole or the pilot with the JSON, and then we load the individual JavaScripts which lead to the one generated from native federation, the one leading to generated by module federation, and the one leading to the entry point from Pyrrole. And that's it, right? So we rendered this whole thing. We brought together 3 different things. This is really meant to be simple. There are no dependencies in any of these microphones. It's really just simple HTML to spit out. So in that sense, it's the let's call it easiest microphones that you can deal with, but Picard just renders them. Now, this, of course, is one way where you really strongly couple it and you say, hey, I got this name and I got the source, and it might be how you do it with module federation, but you may want to leverage the power of Micro Frontend discovery service, and you can out of the box. So what you could do is you say you reference the script, but then in the script you give it an attribute and you call that feed. And again, we are up to discussions here. So maybe you prefer a different name, like service or service URL or data minus service URL or something like this. So tell us what you think about these names. At the moment, nothing is shipped for a good reason because we want to open a discussion here. And you could say the Picard demos, and we've seen all these microphones, they were already located at this position here. We just grab this feed. So now we still can refer to the components via the Pi component custom element, but the source is much simplified. We don't have now any URL in there or any prefix. We now just refer to them by the name that was given in the discovery service. So let's have a look. Let's head over to the browser and let's see how that looks in the network tab. Let me close this and redo. So we now see that Picard demos is loaded, and this is good because this should be the only metadata necessary. It follows now this schema model that Luca presented also in the opening keynote, right? And what you can see is we got our names in here, like MF simple HTML, and it says, oh, we got a URL here, so we know already what the remote entry JS will be. So all the information is known. We got our extras, so we know what the ID, etc. will be, and all the information can be gathered. We are happy, right? And same is, of course, true for all the other things, like the pilot that is in there. All the extras specify the metadata for the pilot, so we know what we deal with here. All right. So that being said, the rest is then same as beforehand. So we just load then the individual things, like our 48.js or the index.js or this column JS, and just load now the things to have the component finally there and rendered. Final thing in the static HTML area that I wanted to show is what you can do now with something beyond simple components. So we also have a web component called PySlot, for instance. So what a slot is very similar to a component, but instead of specifying what is the microfrontend where it comes from, you just specify the name of the component. And then all microfrontends will be queried if they provide such a name, such a component with such a name. Right, and the simplest use case is here with the counter. We just say, I don't care where it is, but if there is a counter, showcase it here. But you might even go one step further. You might say, hey, if I have components that have been registered with the name column, render them here, but don't just render them, but place them in a template, which I called here column template. So they will be placed in this div class call ID4, and they will be placed exactly where the slot is. So we will get exactly the same layout as here, where everything is then put in a column, and it will therefore resemble the same thing as beforehand, and all with just a single line here. And if there would be a third microfrontend coming in, again with a column name, then we would have another column. Sure, this Bootstrap layout is not really tailored for this, because then finally we would end up not with 12, but with 16 columns, which is not the number of columns that Bootstrap wants to see. But you get the idea, right? So that you can now have something with a template that really defines how these things are rendered. And in the final layout, if we have a look, it looks like this. Again, I didn't clear the network tab, but you see we're again working against our feed. And then we are loading the individual ones. So here there's no change. But if we look at the code, we see that our PySlot is here. And you see it now created these 2 additional columns so that we have actually these 3 columns. And each column, of course, then hosts a Py component. And the Py component has its rendering inside. So cool. And you see now there's a different name. So you've used the component ID that was now found out by Picard, and this component ID is just a random ID that gets generated internally. Whenever we find a new component and we create its mapping, we get it a unique ID, and therefore we can, for really fast rendering, refer to this ID. It will just work. All right. So that's just some static HTML. We could go into more depth, for instance, about a router here, but let's do this maybe in the section about a single page application. Let's look at still the Tractor version 1 example, right? Because this is something that you might know. It looks like this at the end. You've seen that maybe countless times, and we will migrate, of course, to the Tractor version 2 soon. But for the moment, we still have, of course, here Tractor version 1, and yeah, it works. So it's always a good litmus test to find out if what you're doing with your framework or your idea works or doesn't. Now, what code would be needed to create this? Well, I mean, let's say it's really a single page application. So we start with a bundler here and I don't know, use React or something. It doesn't matter. We have here a code base that's based on Vite, actually, to have that bundling done. And I now import from Pika, but I referenced it in this repository. Maybe we should also copy over here, use that approach. But anyway, we reference it from the client part that will be built. And what we get out is a function called initialize Picard. So this is, of course, when we reference the script that we've seen earlier, we've done automatically and there's nothing to do. With this approach here, we can, of course, customize it and play around with it. So for instance, I give it here a feed. This feed contains all the micro frontends that will be shown of, in this case, blue and green. The red part we will deal in here just to showcase how that looks like. Now, this thing was already developed way before we had any idea of Picard. So I needed a little bit more because those have been pilots. And Picard doesn't really, I mean, it knows how pilots are structured, etc., but it doesn't know so much about the API. That has changed fundamentally. But luckily, there's a services thing. We can inject a service for extending pilots. So what we do here is we extend the pilot API and we bring in some missing APIs that are not there out of the box in Picard, like register extension, we just call it register component, which is there out of the box in Picard, and create state, that's also not there in the Picard, but we can easily either bring it in then later on from Pyrrol. In this case, I just re-implemented it, really, really simple. But that's not the main part. You could also then share dependencies centrally. So ideally, these microphones that you have are done, let's say, with module federation and use distributed sharing. So you have no problem there. But if you have a scenario like here, where you have a pilot and that one assumes a certain dependency to be already available, like React, you can, of course, do this with Picard as well. You just place it in there. Again, there's no build tooling. I don't use the Parse CLI or anything. It just works with any bundler that's out there. So all you do here is you share React, and that's it. The rest is rather simple, because here I just render my product page. Only thing to note in here is we are using our web components, PyComponent. We name them. We give them the source. This is essentially the same that you've seen beforehand, right? In the example with static HTML. And it just works here as well. And the end result is, again, what you can expect here, a working application where these boundaries are fully defined by PyComponents, like here the basket info, for instance, fully rendered by the system of Picard. All right, now that's a single page application. What else? You might ask about routing, and there are multiple ways to solve routing. I just want to give you one really simple idea. Hopefully get the, let's see, is this right? Yeah. So one thing that Picard can also use out of the box is client-side routing, and it doesn't need the React router or anything for it. So what it does is it creates a special kind of convention where it prefixes your slot components. So in this case, if you have a slot with a rel router, then it will be able to, let's say, hijack that and react to changes of it. So for instance, if I now click on About, the history changes, history API, Picard knows about it, and Picard will just change automatically this name here, and it will change it to page:/about, so essentially the page we see here, and then it matches inside via, let's say, a standard route matching, also to get, let's say, parameters out of the route, and match, of course, what component you have already registered for it. So you wouldn't register, let's say, pages like you do in Pyrrol, where you have register pages, still register just a component. The only thing that changes is that your register is now as a page colon, whatever route you want to have, and Picard takes care of the rest. But you can already see what's the escape hatch if you have a pilot and how it transforms, because if you call the register page API on a pilot, it would of Picard just call register page and, you know, make page colon whatever route you gave it, and it would just work. The beauty about it is that I could, of course, also fake it. I can just change here in the browser, and it would just automatically then say, oh, by the way, my attribute changed. What do I need to do to get this state? Now, of course, it is not so nice to do, because now I have a mismatch between the history API and what we see here. But you get the idea that all you need to do is really change this part of the system, and Picard will take care that it just does the right thing. All right, so a couple more things to do before we can wrap up. But yeah, let's talk about server-side rendering before we call it a day, right? Now, I already told you this thing was tuned for multiple platforms. So here we have a server-side rendered example. Let me just see, it's still working good. And if I click somewhere, I have full refreshes. So you can see that, of course, in the network tab. You click somewhere and everything is loaded again. You click somewhere, okay. I can click on the basket, and I add some items, and I click around, right? And the basket remains the same, and I always load this page. It's fully server-side rendered. There's no single JavaScript that's reaching here the client, so this thing will still work. If I disable JavaScript, it just works. So how does it do that? Well, I mean, it just uses a different variant than what we've seen beforehand. what we see here is that we start, of course, with everything, and you import initialize PK now from later on the server-side variant of PK, which ideally will be picked automatically for you. In the worst case, you do it via submodule selector, but anyway, and then it looks very much the same what you've seen beforehand. We are using now a different feed because beforehand we were using client-side routing and everything. Now the Micro Frontends in this feed, well, they don't assume anything, they just has a user form that goes back. You could now go into the direction of having all these multiple scopes. I didn't. This again, this demo is not meant to showcase this. You can always use React Express session and have a cookie in there and map that. Didn't do it here. Just have a count that's global. So any other user that would access it here would see the same count. And again, that was the main part of it. And we handle just this post here, which is done when you click the button for buying one of these tractors, right? The other thing that's relevant here is that we use the decorate API of PK, which is then capable of looking at a certain content here of the product page and then translating it. Because on the product page, we are still using these Py components. But then again, PK kicks in on the server side, and the outcome is that if we look at the generated source code, it's a little bit small, but bear with me, then you see that already we have this basket in there, right? So everything is already fully filled out, and PK already did all that for you. So you don't need to worry about it. It transports something that's completely server-side rendered. Therefore, you can disable JavaScript and everything. The web components are still in there. I mean, if you disable JavaScript, they will just not turn on, but the content will still be displayed. And if you have the JavaScript, they can now hydrate, but that would be part of the hydration demo that I may not have time to come to. But yeah, let's see about once I present the roadmap. All right, so we had a lot of things, and I really am eager to get your feedback. What's the roadmap now for this whole thing? We are now in June, and we are heading now into the first release with all the examples that you've seen here and even more, and the documentation page being out there, and of course, giving you, let's say, getting started that should be useful at this point in time. But of course, we want to get a little bit further. So what we will do is in July, we will have articles and also first integrations available. And one of the first integrations will not be Astro, but it will be among the first. The first one will be Pirate Blazor Server. It was asked today already on the Discord channel, and there we are still a little bit waiting for the 0.5, which should now come next week or so. Sorry for the delay, but the server side is still full Blazor part. But then, of course, it has this variant of PK that takes over on the client side and then works against the server, which transports in the fragments. But it has a lot of benefits because, well, pretty much the whole reading out of Micro Frontends discovery service, etc., you do in Blazor, but all the rest is then kicked off on the client again. So we got this pre-rendering and all the interactivity done by Blazor, of course, via the WebSocket and whatnot, or WebAssembly. But then, of course, for all the rest, or maybe changing a Micro Frontends component, we still call the Fragment API that just works in tandem again. So the Fragment API on the server needs to be implemented in Blazor using .NET. But then again, client side is PK, it will just take care of that. In August, we are already planning to have a 0.1 release, so it's end of August, something like this, maybe start of September. And that's why we want now to open this discussion to have now good pre-releases of that and then have a 1.0 already there. Because again, PK is meant to be rather small and we don't want to blow it up. There will be no CLI or anything. It will not help you with an emulator or anything. This is Pyro's job. PK's job is just to enable the use of Micro Frontends anywhere. And in November, we want to have the first pre-release of Pile version 2, what we announced last year that will come, and it now uses PK.js as a basis instead of Pile base. Now, I still have the Islands and Dynamic Hydration demo, but potentially we already have some comments, and I think also maybe I can use it among my final words then later on. So I would defer this demo now and get over to have some questions answered and maybe fulfill someone's dream of winning in a raffle. That would be really awesome. And with that, thanks for the attention, and let's hear it now.
Thank you, Florian. Very cool talk. Thanks a lot. And the audience also, like, just reading the comments, they seem to be super excited to get their hands on PK for the first time, and also what that means for Pyro version 2. And we also have a question in this context. So Robson is asking, what does it mean for the future, for future Pyro version 2 plugin like dashboard or menu? Would that be then implemented using web components instead of restricted to React?
Yeah, the answer is there a little bit. Also, it depends. Now, what you do right now in Pyro with your pilots wouldn't change. Potentially, of course, if you would start from scratch, it would change. But the last thing you want to do, and we always said that, and I want to reiterate it again, because this is one of the things we promised, and this is a promise that is not negotiable. There will be no changes required to pilots, meaning that if you do today, you use dashboard with the Pyro dashboard plugin for Pyro, and therefore you have a register tile API, and you use that API in your pilot, and you migrate now your app shell to version 2. There might be multiple steps needed for doing that, but anyway, your pilot doesn't need to change. And it will just work, and your dashboard tile will still be React-based. And so the whole thing will keep working in that sense. Now, the story gets a little bit more complicated if we look under the hood, because what we did right now with Pyro is that in React, you get a clean tree, so to speak. So you have your root node, you have other nodes, maybe then you have a component from your Micro Frontend, but that's just there, sitting in this tree, right? Now, with PK, that tree would be broken like it is, for instance, for foreign components like Angular or whatever. And you got now your web component in there, and that hosts now your React component, which gets a new tree. So we can still optimize here. So it would not get a new React tree. It would use the React projection. These are technical details. But all I want to say is that from the perspective of the document object model, it will look a little bit different there, right? Even though it would be still one React tree, the DOM tree would change a bit with PK. And for most people, this will not have any impact. But if you have a selector that requires that, I don't know, under a certain DOM element, there's another DOM element, and this DOM element would now come from your Micro Frontend component, it might not work out because there might now be a Py component, for instance, in between, or even more, right? Like a Py slot and a Py component. So this could be problematic, and we are not sure yet how to deal with that in this compatibility mode. In general, it shouldn't impact anyone because, yeah, you shouldn't make this assumption in your selectors on this transition boundary, let's call it. But yeah, it can and it will happen for some, and we are still thinking how you might be able to control it. By the way, you could already today introduce such a boundary in Pyro. We have a flag in your Pyro JSON. It will enable this boundary too for React flows. So there is already a way to already, let's say, investigate if it would work or not. We introduced it, I think, with the 1.4 version of Pyro. It's a flag no one knows, I guess, but it is, so there are ways already to check. But otherwise, regarding dashboard, etc., there's nothing needed for you to do.
Great. Thanks for the detailed answer. I think we're running out a little bit of time here. We also want to do the raffle. But I think, Florian, you're, of course, happy to answer all upcoming questions in the comment section as well. Perfect. And, of course, there are going to be some final words from you as well, I think. But let's first do the raffle together, I would say. Mm-hmm. And same story. As already mentioned during the introduction, you could win one of Florian's books, a copy of his Out of Micro Frontends ebook, JetBrains writer license again, and also T-shirt with any color you want. I actually have the gray one, really like that one, but of course, I mean, don't have to agree. You can also choose green. I don't know, do we have pink? No, but a lot of different colors for your disposal.
I don't think pink was one of them, but they are great. They're great. Good selection we have there.
And I one person was also asking, where do I find the T-shirt? You can
Yeah,
win
last
it
year
now.
the web shop that didn't go as well as
True.
planned. So this year we thought let's not put in the effort to place the web shop there. But yeah, if you guys want the T-shirt, just contact us. We will find a way to get it for you for maybe low money. But we can always talk, and then you can decide if you want to have it. But there's no official shop this time.
Okay.
But
So
it
the
could be
users
some
was
of
a
your
part of the
feedback,
raffle.
right? So if you guys want to have it, then write it. Say next year, please, again, another web shop or something.
It would be great if that user actually wins it now. Let's see. All right. I think we have enough participants for the
So
raffle.
you got
Let's go.
my fingers crossed that you win it then.
Code wave death. Okay, this was just the JetBrains license.
Just.
So you can still win the T-shirt. Yeah, congrats. Michaela, Federico, you got the JetBrains license. Let's go. Let's spin the wheel again. Ooh, that was so close. That was so close. But Ryan C, you got it. You got the T-shirt. Congrats. And now we got the copy of Florian's book. Let's spin it one last time. And the book goes to Dorian _ OK. Congrats to you as well.
It's not me.
Great. That was the final raffle.
Nice.
And I think I can also head it over to you, Florian, for the final words. Do you want to like still show the demo, or you can choose?
A little bit of everything. First of all, thanks for moderating this one, Felix. Again, thanks to everyone involved. Thanks to all the participants. It was a long day for everyone here and our offices, for all the speakers, of course, the speakers also are worldwide, right? So not always was the time zone the most easiest to let's say, get used to. So some people really woke up quite early or had to stay up really late. So I want to thank everyone for your contribution to make this conference and Micro Frontends in general a success. It was outstanding like last year, and we didn't think that we could repeat it. I think we took your feedback. I hope you all appreciate what we did this time. Any feedback, of course, is seen well. We want to improve here, and we want to make the best events for the Micro Frontends space that can be done. I also want to thank, of course, our sponsors. Without these awesome companies and, of course, the people approaching me and I'm being in contact with, this event also wouldn't be possible. If it would be possible, we would have much less cool prizes, right? So thanks again to Wallaby, to JetBrains, to also, of course, Sessionize for giving us the CFP platform, to Wallaby with all their great products that they have, to JameDev who made it possible to have the awesome speakers dinner yesterday and have also a nice cake here. I want to really thank everyone, also VIA developers, our friends there who also made a little bit of advertisement for the event. This is much appreciated, and we couldn't be here today without your support. Also, of course, to SmartPiot and the team, everyone who was working behind the scenes for the tech. This was outstanding. You did an awesome job today, nailed everything. Our computers here were steaming out like last year. It was really nice weather. We had to open all the windows to have a little bit of fresh air inside our offices. But I think It was a great day, and everyone had a great time. I hope everyone in the audience also had a great time. I want to have one final demo just to, give you home. I don't want to show you code for this final demo. You've seen the Netflix islands quite often, hopefully, maybe not. But I want to show it now working to you with Picard. And so this thing is server-side rendered. This time, when I'm doing a demo now, let me also switch off JavaScript. How do I do that? Like this. And you see it's still working, and I can browse, and I can even log into this thing. And there I have scopes enabled. So yeah, I'm logged in now, but no one else is. And this works. So great. Cool. I can enable JavaScript again. I'm still logged in as Jane, right? But now it's behaving a little bit differently, because if I now look at the network tab, right, there's not a whole flash of something. There's just, well, this fragment was being called. We're calling the fragment API. And so this is the fragment API. I hope you can see that. Let me make it a little bit larger. And the response is just here, our Pyro slot. In this thing, I renamed it. So I don't want to show the code now, but as mentioned, you can rename things. You can give component name and slot name. As I already said, you can configure this whole thing. And I renamed it because I'm reusing the same Micro Frontends I did for an earlier demo on how Pyro can be used in such an islands architecture. But the great thing is that certain things are just rendering on the client, like you haven't seen on a pure non-JavaScript rendering, the search box, while other things just render purely on the server, and others just hydrate and provide a better experience, like the routing here. And that's a little bit the whole idea. So Picard here delivers again, because you can now just use this, have here, it's just an Express server, but it could be something else, could be something on the edge if you want to, and it just delivers that, brings the Micro Frontends together, and has the orchestration layer. So Picard, as we want to say, is the captain in your new federation, next generation of federation. And we think it's quite exciting. We want to know now what we could do to improve it, what is all needed in the documentation, of course, what other things could be in there, what examples you want to see. And yeah, get in touch with us if you want to try it out. And we would really love to get as much user feedback as possible, because I think this was one of the things missing with Pyro initially, maybe. And that would be really awesome to gather as much as possible from your side to make this thing useful and useful for you to use. With this being said, thanks everyone for attending the Micro Frontends Conference 2024. We wish you all a pleasant, day, pleasant evening, pleasant midnight now, wherever you are, and let's keep in touch. We are back soon with more announcements, for instance, for the Micro Frontends meetup that will be monthly starting in July, or the workshops. Happy to see you in one of these events. Take care and see you around.
Bye-bye.